Controls. 10 centimeters are placed and D Sharma 14. Find the surface area of the resulting cuboid. Concept and formula. Surface area of a cuboid is equal to 2 open parental B plus H plus L close paren. When two cubes are placed end to end, they form a new cuboid. The new dimensions are: length is equal to sum of the lengths of both cubes. Breadth and height remain the same as a cube. Solution. Stepwise explanation. Given cube side is equal to 10 centimeters, two cubes are placed end to end. Finding the dimensions of the resulting cuboid. Length is equal to 10 plus 10 equals 20 cm. Breadth is equal to 10 centimeters. Height is equal to 10 centimeters. Applying the formula for surface area. Cap S cap A equals 2 open parental B plus H plus L close paren. Substituting the values. Cap S cap A equals 2 open paren 20 times 10 plus 10 times 10 plus 10 times 20 close paren. Equals 2 open paren 200 plus 100 plus 200 close paren equals 2 times 500 equals 1000 superscript base cm n base squared. Final answer. The surface area of the resulting cuboid is equal to 1000 square centimeters. Problem 2. A square wire is bent into a cube of side 6 centimeters. Find the surface area of the cube. Concept and formula. Surface area of a cube is equal to 6s squared. A wire is bent into a cube, meaning its length forms the edges of the cube. Total edge length of a cube is equal to 12s, where s is the side length. Solution. Stepwise explanation given. Side of the cube is equal to 6 centimeters. Surface area of the cube. Cap S cap A equals 6s squared. Substituting equals 6. Cap S cap A equals 6 open paren 6 times 6 close paren equals 6 open paren 36 close paren equals 216 superscript base cm n base squared. Final answer. The surface area of the cube is equal to 216 square centimeters. Problem 3. 3 cubes each of 5 centimeters are joined end to end. Find the surface area of the resulting cuboid. Concept and formula. Surface area of a cuboid is equal to 2 open parental B plus H plus L close paren. When 3 cubes are joined in a row, the new cuboid's length is equal to sum of 3 cube sides. Breadth and height remain the same. Solution. Stepwise explanation given. Cube side is equal to 5 centimeters. Finding the dimensions of the resulting cuboid. Length is equal to 5 plus 5 plus 5 equals 15 cm. Breadth is equal to 5 centimeters. Height is equal to 5 centimeters. Applying the formula for surface area. Cap S cap A equals 2 open parental B plus H plus L close paren. Substituting the values. Cap S cap A equals 2 open paren 5 times 5 plus 5 times 5 plus 5 times 5 close paren. Equals 2 open paren 7 5 plus 2 5 plus 7 5 close paren equals 2 times 7 5 equals 350 superscript base cm n base squared. Final answer. The surface area of the resulting cuboid is equal to 350 square centimeters. Problem 4. The area of a square is 16 square centimeters. If the square is folded into a cylinder, find the surface area and volume of the cylinder. Concept and formula. Area of square is equal to s squared, so equal square root of 16. When the square is folded into a cylinder, the perimeter of the square becomes the circumference of the cylinder. 4s equals 2 pi r. Surface area of cylinder is equal to 2 pi r h plus 2 pi r squared. Volume of cylinder is equal to p squared. Solution. Stepwise explanation given. Square area is equal to 16 square centimeters. Side of the square is equal to square root of 16 equals 4 cm. Perimeter of square is equal to 4 times 4 equals 16 cm. Finding the radius. 16 equals 2 pi r equals 16 over 2 pi equals 8 over pi, almost equal to 2.55 cm. Finding the height. Since the side of the square is 4 centimeters, the height of the cylinder is equal to 4 centimeters. Surface area of cylinder. Cap S cap A equals 2 pi r h plus 2 pi r squared. Substituting values. Cap S cap A equals 2 pi open paren 2.55 times 4 close paren plus 2 pi open paren 2.55 close paren squared equals 2 pi open paren 10.2 plus 6.5 close paren equals 2 pi times 16.7. Almost equal to 104.94 superscript base cm n base squared. Volume of cylinder. Cap V equals per squared. Substituting values. Cap V equals P open paren 2.55 close paren squared open paren 4 close paren. Almost equal to P times 6.5 times 4 equals 81.68 superscript base cm n base cubed. Final answer. Surface area is equal to 104.94 square centimeters. Volume is equal to 81.68 cubic centimeters. Problem 5. A metallic cube of edge 8 centimeters is melted and recast into a cuboid of dimensions 16 centimeters times 4 centimeters times 2 centimeters. Find the total surface area of the cuboid. Concept and formula. Volume of cube is equal to S cubed. Volume of cuboid is equal to L times times. Surface area of cuboid is equal to 2 open paren B plus H plus L close paren. Solution. Stepwise explanation given. Cube edge is equal to 8 centimeters. Volume of cube is equal to 8 cubed equals 512 cubic centimeter. Dimensions of new cuboid. 16 centimeters times 4 centimeters times 2 centimeters. Checking volume consistency. Volume of cuboid is equal to 16 times 4 times 2 equals 128 cubic centimeter. Since multiple cubes are recast, 512 over 128 equals 4 such cuboids can be formed. Finding surface area of the cuboid. Cap S cap A equals 2 open paren B plus H plus L close paren equals 2 open paren 16 times 4 plus 4 times 2 plus 2 times 16 close paren equals 2 open paren 6 4 plus 8 plus 3 2 close paren equals 2 times 104 equals 208 superscript base cm n base squared. Final answer. The total surface area of the cuboid is equal to 208 square centimeters. Problem 6. The material of the cube is recast into several identical solid sphere. Find the radius of each sphere. Concept and formula. Volume of a cube is equal to S cubed. Volume of a sphere is equal to 4/3 per cubed. The volume of the cube is divided into multiple spheres of equal volume. Total volume of spheres is equal to volume of the original cube. Solution. Stepwise explanation given. Cube side is equal to 5 centimeters. Number of spheres is equal to 125. Finding the volume of the cube. Cap V sub cube equals cubed equals 5 cubed equals 125 superscript base cm n base cubed volume of each sphere. Total volume of spheres is equal to volume of cube. Volume of one sphere is equal to 125 over 125 equals 1 cubic centimeter. Using the formula for the sphere's volume, 4/3 per cubed equals 1. Solving for r cubed equals 3 over 4 pi equals open parent 3 over 4 pi, close parent to the 1/3 end superscript. Final answer. The radius of each sphere is open parent 3 over 4 pi, close parent to the 1/3 end superscript cm. Problem 7. A cylindrical pipe of external radius 40 cm, internal radius 30 cm, and thickness 5 cm is made from iron. Find the length of the pipe if the volume of iron is equal to the volume of a block. Concept and formula. Volume of a cylinder, hollow pipe, is equal to cap V equals pH open parent cap r squared minus r squared close parent, where r is the external radius, r is the internal radius, and h is the height, or length of the pipe. Volume of the block is equal to L times times. The volume of iron in the pipe is equal to volume of block. Solution. Stepwise explanation given. External radius cap equals 40 cm. Internal radius equals 30 cm. Thickness is equal to cap minus equals 10 cm. Volume of block is equal to 440 times 240 times 100 cubic centimeter. Finding volume of iron in the pipe. Cap V sub iron equals pH open parent cap r squared minus r squared close parent equals pH open parent 40 squared minus 30 squared close parent equals pH open parent 1600 minus 900 close parent equals pH open parent 700 close parent. Equating to block volume. pH open parent 700 close parent equals 440 times 240 times 100. Equals numerator 440 times 240 times 100 and numerator, over denominator, pi times 700 and denominator. Final answer. The length of the pipe is 112 m. Problem 8. The radii of the bases of two right circular cones of same height are 4 cm and 8 cm. These are melted and recast into a solid sphere of radius r. Show that the height of each cone is given by equals 8 cap r over 3. Concept and formula. Volume of a cone is equal to 1/3 pi squared. Volume of a sphere is equal to 4/3 pi cap r cubed. Since both cones are melted to form the sphere, total volume of cone equals volume of sphere. Solution. Stepwise explanation given. Radii of cones is equal to 4 cm, 8 cm. Height is equal to h. Radius of sphere is equal to cap r. Finding total volume of the two cones. Cap V sub cone equals 1/3 pi open parent 4 squared close parent plus 1/3 pi open parent 8 squared close parent equals 1/3 pi open parent 16h plus 64h close parent equals 1/3 pi open parent 80h close parent. Equating with volume of sphere. 1/3 pi open parent 80h close parent equals 4/3 pi cap r cubed. Solving for h. 80h equals 4 cap r cubed equals 8 cap r over 3. Final answer. The height of each cone is 8 cap r over 3. Problem 9. Two right circular cones have the same height. The radii of their bases are in the ratio 3:4. They are melted and recast into a single cylinder of equal height. Show that the radius of the base of the cylinder is 3 over square root of 7. Concept and formula. Volume of a cone is equal to 1/3 pi squared. Volume of a cylinder is equal to pi cap r squared since both cones are melted into the cylinder. Total volume of cones equals volume of cylinder. Solution. Stepwise explanation given. Height of both cones is equal to h. Radii are in ratio 3, 4. Let them be 3x and 4x. Cylinder height is equal to h. Cylinder base radius is equal to cap r. Finding total volume of cones. Cap v sub cones equals 1/3 pi open parent 3x close parent squared plus 1/3 pi open parent 4x close parent squared equals 1/3 pi open parent 9x squared plus 16x squared close parent equals 1/3 pi open parent 25x squared close parent, equating with volume of cylinder. 1/3 pi open parent 25x squared close parent equals pi cap r squared. Solving for cap r squared equals numerator 25x squared and numerator over 3 taking square root. Cap r equals 5x over the square root of 3 given that is equals 3 over square root of 7. Substituting. Cap r equals numerator 5 times 3 and numerator over denominator square root of 3 times square root of 7 and denominator equals 15 over square root of 21 equals 3 over square root of 7. Final answer. The radius of the base of the cylinder is 3 over square root of 7. Problem 10. The diameter of a metallic sphere is 6 centimeters. It is melted and drawn into a wire having a diameter of 0.2 centimeters. Find the length of the wire. Concept and formula. Volume of a sphere is equal to 4/3 per cubed. Volume of a cylindrical wire is equal to pi squared since the sphere is melted and reshaped into the wire. Their volumes remain the same. Volume of sphere equals volume of wire. Solution. Stepwise explanation. Given. Diameter of sphere is equal to 6 centimeters. Radius r is equal to 3 centimeters. Diameter of wire is equal to 0.2 centimeters. Radius r sub wire is equal to 0.1 centimeters. Let the length of the wire be h. Volume of the sphere. Cap v sub sphere equals 4/3 pi open parent 3 close parent cubed equals 4/3 pi times 27 equals 36 pi superscript base cm end base cubed. Volume of the wire. Cap v sub wire equals pi open parent 0.1 close parent squared equals pi times 0.01 times, equating both volumes. 36 pi equals pi times 0.01 times. Solving for h. Equals 36 pi over denominator. Pi times 0.01 and denominator. Equals 36 over 0.01 equals 3600 equals 36 meters. Final answer. The length of the wire is 36 meters. Problem 11. The diameter of a solid spherical iron ball is 6 centimeters. The sphere is melted and drawn into a wire of cross-section 3 mm superscript 2. Find the length of the wire. ICSE 2013. Concept and formula. Volume of a sphere is equal to 4/3 per cubed. Volume of a cylindrical wire is equal to cap A times where cap A is the cross-sectional area. Since material is conserved, volume of sphere equals volume of wire. Solution. Stepwise explanation given. Diameter of sphere is equal to 6 centimeters. Radius r is equal to 3 centimeters. Cross-sectional area of wire is equal to 3 mm superscript 2 is equal to 0.3 square centimeters. Let the length of the wire be h volume of the sphere. Cap V subsphere equals 4/3 p open parent 3 close parent cubed equals 4/3 p times 27 equals 36 pi superscript base cm n base cubed volume of the wire. Cap V sub wire equals 0.3 times. Equating both volumes, 36 pi equals 0.3 h solving for h. Equals 36 pi over 0.3 equals 120 pi almost equal to 377 cm. Final answer. The length of the wire is 377 centimeters. Problem 12. How many metallic solid balls of 1.1 centimeters radius can be made from a metallic solid of dimensions 11 centimeters times 12 centimeters times 9 centimeters? Insert exemplar. Concept and formula. Volume of a sphere is equal to 4/3 per cubed. Volume of a rectangular solid is equal to L times Ptimesh. Since the material is conserved volume of the solid over volume of one sphere equals number of spheres. Solution. Stepwise explanation given. Dimensions of solid block is equal to 11 times 12 times 9 cubic centimeter. Radius of metallic balls is equal to 1.1 centimeters. Finding volume of the solid block. Cap V sub solid equals 1 times 1 2 times 9 equals 118 superscript base cm n base cubed. Finding volume of one sphere. Cap V sub sphere equals 4/3 p open parent 1.1 close parent cubed equals 4/3 p times 1.331 equals 5.324 over 3 pi. Finding number of spheres. Cap n equals 118 over denominator 4/3 pi open parent 1.1 close parent cubed, n denominator equals numerator 1188 times 3 end numerator over denominator 4 pi times 1.331 n denominator, almost equal to 100. Final answer. 100 metallic balls can be made. Problem 13. A right circular cone of radius 5 cm is cut and carved after 47.1 cubic centimeters of volume is removed. Find the remaining volume of the cone. Concept and formula. Volume of a cone is equal to 1/3 p squared. Remaining volume is equal to original volume, removed volume. Solution. Stepwise explanation given. Radius of cone is equal to 5 centimeters. Removed volume is equal to 47.1 cubic centimeters. Finding volume of the original cone. Assume height h is given as h cap v sub cone equals 1/3 p open parent 5 close parent squared equals 25 pi h over 3. Finding remaining volume. Cap v sub remaining equals 25 pi h over 3 minus 47.1. Final answer. Cap v sub remaining equals 25 pi h over 3 minus 47.1. Exact numerical value depends on height h, which should be provided in the problem. Problem 14. A right circular cone has a height of 8.4 centimeters and the radius of its base is 2.1 centimeters. It is melted and recast into a sphere. Find the radius of the sphere. Concept and formula. Volume of a cone is equal to cap v sub cone equals 1/3 p squared. Volume of a sphere is equal to cap v sub sphere equals 4/3 p cap r cubed. Since the material remains the same, we equate Cap V sub cone equals cap V sub sphere. Solution. Stepwise explanation given. Radius of cone is equal to 2.1 centimeters. Height of cone is equal to 8.4 centimeters. Let cap R be the radius of the sphere. Finding volume of the cone. Cap V sub cone equals 1/3 P open paren 2.1 close paren squared open paren 8.4 close paren equals 1/3 P open paren 4.41 times 8.4 close paren equals 1/3 P open paren 37.044 close paren equals 12.348 pi superscript base cm n base cubed. Equating with volume of sphere, 4/3 pi cap R cubed equals 12.348 pi. Solving for cap R cubed equals numerator, 12.348 times 3 and numerator, over 4, equals 9.261 cap R equals cube root of 9.261 almost equal to 2.1 cm. Final answer. The radius of the sphere is 2.1 centimeters. Problem 15. A metallic sphere of radius 2.1 centimeters is melted and recast into a cylinder of height 4 centimeters. Find the radius of the cylinder. Concept and formula. Volume of a sphere is equal to 4/3 per cubed. Volume of a cylinder is equal to pi cap R squared. Since the material remains the same, we equate cap V sub sphere equals cap V sub cylinder. Solution. Stepwise explanation given. Sphere radius is equal to 2.1 centimeters. Cylinder height is equal to 4 centimeters. Let the radius of the cylinder be cap R. Volume of the sphere. Cap V sub sphere equals 4/3 P open paren 2.1 close paren cubed equals 4/3 P open paren 9.261 close paren equals 12.348 pi superscript base cm n base cubed. Volume of cylinder pi cap R square times 4 equating both volumes. 4 pi cap R squared equals 12.348 pi. Solving for cap R. Cap R squared equals 12.348 over 4 equals 3.087. Cap R equals square root of 3.087 almost equal to 1.76 cm. Final answer. The radius of the cylinder is 1.76 centimeters. Problem 16. Marbles of radius 6 centimeters, 8 centimeters, and 10 centimeters respectively, are melted to form a single spherical ball. Find the radius of the resulting sphere. Concept and formula. Volume of a sphere is equal to 4/3 per cube. Total volume of marbles is equal to volume of the new sphere. Using the formula cap V sub resulting sphere equals cap V sub sphere 1 plus cap V sub sphere 2 plus cap V sub sphere 3. Solution. Stepwise explanation given. Radii of spheres 6 centimeters, 8 centimeters, 10 centimeters. Let the radius of the resulting sphere be cap R. Finding the total volume. 4/3 P open paren 6 cubed plus 8 cubed plus 10 cubed close paren equals 4/3 P open paren 216 plus 512 plus 1000 close paren equals 4/3 P open paren 1728 close paren equals 2304 pi. Equating to volume of the new sphere, 4/3 P cap R cubed equals 2304 pi. Solving for cap R cubed equals 2304 times 3/4 equals 1728. Cap R equals cube root of 1728 equals 12. Final answer. The radius of the resulting sphere is 12 centimeters. Problem 17. A solid sphere of radius 2 cm is melted and recast into 8 spherical balls each of equal radius. Find the radius of each small sphere. Concept and formula. Volume of a sphere is equal to 4/3 per cube. Total volume of small spheres is equal to volume of original sphere. Using the formula cap V sub original equals 8 times cap V sub small sphere. Solution. Stepwise explanation. Given radius of original sphere is equal to 2 cm. Number of small spheres is equal to 8. Let the radius of each small sphere be r. Finding volume of the original sphere. Cap V sub original equals 4/3 p open parent 2 close parent cubed equals 4/3 p open parent 8 close parent equals 32/3 p. Equating with 8 small spheres. 8 times 4/3 per cubed equals 32/3 p. Solving for r. 8 r cubed equals 8. R cubed equals 1 equals 1 cm. Final answer. The radius of each small sphere is 1 cm. Problem 18. A solid sphere of radius 3 cm is melted and recast into 1000 spherical balls each of equal radius. Find the radius of each small sphere. Concept and formula. Volume of a sphere is equal to 4/3 per cube. Total volume of small spheres is equal to volume of original sphere. Using the formula cap V sub original equals 1000 times cap V sub small sphere. Solution. Stepwise explanation. Given radius of original sphere is equal to 3 cm. Number of small spheres is equal to 1000. Let the radius of each small sphere be r. Finding volume of the original sphere. Cap V sub original equals 4/3 p open parent 3 close parent cubed equals 4/3 p open parent 27 close parent equals 36 pi. Equating with 1000 small spheres. 1000 times 4/3 per cubed equals 36 pi. Solving for r. 1000 r cubed equals 36. R cubed equals 0.036 equals cube root of 0.036 almost equal to 0.32 cm. Final answer. The radius of each small sphere is 0.32 cm. Problem 19. How many spherical balls can be made out of a solid cube of lead whose edge measures 44 cm? Each ball having a diameter of 2 cm. Concept and formula. Volume of a sphere is equal to cap V sub sphere equals 4/3 per cubed. Volume of a cube is equal to a cubed number of spherical balls. Volume of cube over volume of 1 sphere. Solution. Stepwise explanation given. Edge of cube is equal to 44 cm. Diameter of spherical balls is equal to 2 cm. Radius is equal to 1 cm. Volume of the cube. Cap V sub cube equals 44 cubed equals 85184 superscript base cm n base cubed. Volume of one sphere. Cap V sub sphere equals 4/3 p open parent 1 close parent cubed equals 4/3 p. Finding the number of balls. Cap n equals 85184 over denominator. 4/3 pi n denominator equals numerator 85,184 times 3 n numerator over 4 pi almost equal to 2541. Final answer. The number of spherical balls that can be made is 2541. Problem 20. A solid metallic spherical ball of 42 cm in diameter is melted and recast into spherical shorts each of 2 cm in diameter. Find the number of shorts. Concept and formula. Volume of a sphere is equal to cap V sub sphere equals 4/3 per cubed. Total volume of spherical shorts is equal to volume of original sphere. Number of shorts. Volume of original sphere over volume of 1 small sphere. Solution. Stepwise explanation given. Diameter of large sphere is equal to 42 cm. Radius is equal to 21 cm. Diameter of each short is equal to 2 cm. Radius is equal to 1 cm. Volume of the large sphere. Cap V sub large sphere equals 4/3 p open paren 21 close paren cubed equals 4/3 p open paren 9261 close paren equals 12348 pi superscript base cm n base cubed. Volume of one small sphere. Cap V sub small sphere equals 4/3 p open paren 1 close paren cubed equals 4/3 p. Finding the number of shorts. Cap n equals 12348 pi over denominator 4/3 pi n denominator equals numerator 12,348 times 3 n numerator over 4 equals 9261. Final answer. The number of spherical shorts that can be made is 9261. Problem 21. A 10 cm long solid metal cylinder with a radius of 7 cm is melted and recast into a spherical shell of 3 cm thickness. Find the inner radius of the shell. Concept and formula. Volume of a cylinder is equal to cap V sub cylinder equals per squared. Volume of a spherical shell is equal to cap V sub shell equals 4/3 p open paren cap r cubed minus r cubed close paren, where cap r is the outer radius and r is the inner radius. Equating the volumes. Cap V sub cylinder equals cap V sub shell. Solution. Stepwise explanation. Given. Cylinder height is equal to 10 cm. Cylinder radius is equal to 7 cm. Outer radius of spherical shell cap equals plus 3. Finding volume of cylinder. Cap V sub cylinder equals p open paren 7 close paren squared open paren 10 close paren equals 490 pi superscript base cm n base cubed. Finding volume of spherical shell. 4/3 p open paren plus 3 close paren cubed minus r cubed close paren. Equating with cylinder volume. 4/3 p open paren plus 3 close paren cubed minus r cubed close paren equals 490 pi. 4/3 open paren plus 3 close paren cubed minus r cubed close paren equals 490. Solving for r. Expanding open paren r plus 3 close paren cubed. Open paren r plus 3 close paren cubed equals r cubed plus 9r squared plus 27r plus 27. Substituting in equation. 4/3 open paren 9r squared plus 27r plus 27 close paren equals 490. Multiplying by 3rd April. 9r squared plus 27r plus 27 equals 367.5. Rearranging. 9r squared plus 27r minus 340.5 equals 0. Solving using quadratic formula. R equals numerator minus 27 plus or minus square root of 27 squared minus 4 open paren 9 close paren open paren minus 340.5 close paren end square root, end numerator, over denominator, 2 open paren 9 close paren end denominator equals numerator, minus 27 plus or minus square root of 729 plus 12,258 end square root, end numerator, over 18, equals numerator, minus 27 plus or minus square root of 12,987 end numerator, over 18 approximating, almost equal to 6.5 cm. Final answer. The inner radius of the spherical shell is 6.5 centimeters. Problem 22. A hemispherical ball of internal radius 9 centimeters contains liquid. This liquid is to be filled in cylindrical bottles of radius 3 centimeters and height 6 centimeters. How many bottles are required to empty the ball? Concept and formula. Volume of a hemisphere is equal to cap V sub hemisphere equals 2/3 per cubed. Volume of a cylinder is equal to cap V sub cylinder equals per squared. Total number of bottles required. Volume of hemisphere over volume of 1 bottle solution. Stepwise explanation. Given radius of the hemispherical ball is equal to 9 centimeters. Radius of each cylindrical bottle is equal to 3 centimeters. Height of each bottle is equal to 6 centimeters. Volume of the hemisphere. Cap V sub hemisphere equals 2/3 p open paren 9 close paren cubed equals 2/3 p open paren 7 to 9 close paren equals 486 pi superscript base cm, n base, cubed. Volume of one bottle, cap V sub cylinder equals p open paren 3 close paren squared open paren 6 close paren, equals p times 9 times 6 equals 54 pi superscript base, cm, n base, cubed. Finding the number of bottles, cap n equals 486 pi over 54 pi equals 9. Final answer. 9 cylindrical bottles are required to empty the ball. Problem 23. A right circular cone of height 16 centimeters and radius of its base 16 centimeters is melted and recast into another cone with radius 12 centimeters. Find the height of the new cone. Concept and formula. Volume of a cone is equal to cap V sub cone equals 1/3 p squared. Since the volume remains the same after recasting, cap V sub original cone equals cap V sub new cone. Using the formula 1/3 p sub 1 squared sub 1 equals 1/3 p sub 2 squared sub 2 cancelling out common terms, a sub 1 squared sub 1 equals sub 2 squared sub 2. Solution. Stepwise explanation given. Original cone, a sub 1 equals 16 cm, h sub 1 equals 16 cm. New cone, a sub 2 equals 12 cm, h sub 2 to be found. Using the volume formula. 16 square A times 16 equals 12 square A h sub 2. 256 times 16 equals 144 times sub 2 4096 equals 144 h sub 2. H sub 2 equals 4096 over 144 equals 28.4 cm. Final answer. The height of the new cone is 28.4 centimeters. Heading 1 Problem 24. Solid cylinders of the same height as the diameter are melted and recast into a cone of diameter 3 centimeters. Find the height of the cone. Concept and formula. volume of a cylinder is equal to cap V sub cylinder equals per squared. Volume of a cone is equal to cap V sub cone equals 1/3 pi squared. Since the material remains the same, we equate cap V sub cylinder equals cap V sub cone. Solution. Stepwise explanation given. Let the radius of the cylinder be equals 2 cm. Height of cylinder is equal to diameter is equal to 4 centimeters. Cone's diameter is equal to 3 centimeters. Radius equals 1.5 cm. Height of cone h to be found. Volume of one cylinder. Cap V sub cylinder equals P open parent 2 close parent squared open parent 4 close parent equals 16 pi. Volume of cone. 1/3 P open parent 1.5 close parent squared equals 1/3 P open parent 2.25 close parent equals 2.25 over 3 pi h equating volumes. 16 pi equals 2.25 over 3 pi h. Equals numerator. 16 times 3 and numerator. Over 2.25 equals 48 over 2.25 equals 21.3 cm. Final answer. The height of the cone is 21.3 centimeters. Problem 25. A solid sphere of diameter 6 centimeters is dropped in a right circular cylindrical vessel partly filled with water. The water level rises by 1 centimeter. Find the radius of the cylindrical vessel. Concept and formula. Volume of a sphere is equal to cap V sub sphere equals 4/3 per cubed. Volume of the water displaced is equal to volume of cylinder's water rise. Cap V sub cylinder equals P cap R squared. Since the volume displaced equals the volume of the sphere, cap V sub sphere equals cap V sub cylinder. Solution. Stepwise explanation given. Diameter of sphere is equal to 6 centimeters. Radius is equal to 3 centimeters. Height of water rise is equal to 1 centimeter. Let cap R be the radius of the cylindrical vessel. Volume of the sphere. Cap V sub sphere equals 4/3 P open parent 3 close parent cubed. Equals 4/3 P open parent 27 close parent equals 36 pi. Volume of the water displaced. P cap R squared open parent 1 close parent. Equals P cap R squared equating both volumes. 36 pi equals P cap R squared. Solving for cap R. Cap R squared equals 36. Cap equals 6 cm. Final answer. The radius of the cylindrical vessel is 6 centimeters. Shape. In line with text. Problem 26. A conical vessel whose internal radius is 5 centimeters and height 24 centimeters is full of water. The water is emptied into a cylindrical vessel with an internal radius of 10 centimeters. Find the height to which the water rises in the cylindrical vessel. Concept and formula. Volume of a cone cap V sub cone equals 1/3 pi squared. Volume of a cylinder cap V sub cylinder equals P cap R squared cap H. Since the water volume remains the same after transfer, cap V sub cone equals cap V sub cylinder. Solution. Stepwise explanation given. Radius of conical vessel is equal to 5 centimeters. Height of conical vessel is equal to 24 centimeters. Radius of cylindrical vessel is equal to 10 centimeters. Height of water in the cylindrical vessel is equal to cap H. To be found. Volume of the conical vessel. Cap V sub cone equals 1/3 P open parent 5 close parent squared open parent 24 close parent. Equals 1/3 P open parent 25 times 24 close parent equals 1/3 P open parent 600 close parent equals 200 pi. equating with volume of water in cylinder. 200 pi equals P open parent 10 close parent squared cap H. 200 pi equals 100 pi cap H. Solving for cap H. Cap equals 200 pi over 100 pi equals 2 cm. Final answer. The water rises to a height of 2 centimeters in the cylindrical vessel. Shape. In line with text. Problem 27. A pipe with an internal diameter of 10 centimeters is 30 centimeters long. A metal cylinder of radius 3 centimeters is fully submerged in it. Calculate the height by which water in the pipe rises. Concept and formula. Volume of cylinder cap V sub cylinder equals per squared. Volume of water displaced is equal to volume of submerged cylinder. Water rises in the pipe as a cylinder. So use the formula. P cap R squared cap equals cap V sub submerged cylinder. Solution. Stepwise explanation given. Internal diameter of pipe is equal to 10 centimeters. Radius is equal to 5 centimeters. Height of pipe is equal to 30 centimeters. Metal cylinder radius is equal to 3 centimeters. Height of metal cylinder is equal to 10 centimeters. Water rise height cap H to be found. Volume of the submerged cylinder. Cap V sub cylinder equals P open parent 3 close parent squared open parent 10 close parent equals 90 pi. Volume of water risen in the pipe. Pi open parent 5 close parent squared cap equals 90 pi 25 cap H equals 90. Solving for cap H. Cap equals 90 over 25 equals 3.6 cm. Final answer. The water rises by 3.6 centimeters. Shape. In line with text. Problem 28. 500 persons visiting a park use a circular tank 80 centimeters deep and 5 m in diameter for hand washing. If each person uses 2 liters of water, how much will the water level rise? Concept and formula. Volume of cylinder cap V sub cylinder equals per squared. Total water misspelled used. Misspelled water misspelled used misspelled equals misspelled number misspelled of misspelled persons misspelled times misspelled water misspelled per misspelled person. Solution. Stepwise explanation given. Diameter of tank is equal to 5 m. Radius is equal to 2.5 m. Depth of tank is equal to 80 centimeters is equal to 0.8 m. Water used per person is equal to 2L is equal to 0.002 cubic meters. Number of persons is equal to 500. Water rise height H to be found. Total water used. Cap V sub water equals 500 times 0.002 equals 1 superscript base m n base cubed. Volume of water in the tank. Pi open parent 2.5 close parent squared cap equals 1. Pi open parent 6.25 close parent cap equals 1. Solving for cap H. Cap equals 1 over 6.25 pi. Cap almost equal to 0.05 equals 5 cm. Final answer. The water level will rise by 5 centimeters. Shape. In line with text. Problem 29. A hemispherical tank, a cylindrical shape, is 70 m long and 2.8 m in diameter, is used to store water. Find the maximum volume of water stored. Concept and formula. Volume of hemisphere cap V sub hemisphere equals 2/3 per cubed. Volume of cylinder cap V sub cylinder equals per squared. Total volume. Cap V sub total equals cap V sub cylinder plus cap V sub hemisphere. Solution. Stepwise explanation. Given. Diameter is equal to 2.8 m. Radius is equal to 1.4 m. Length of tank is equal to 70 m. Volume of the cylinder. Cap V sub cylinder equals P open parent 1.4 close parent squared open parent 70 close parent equals P open parent 1.96 close parent open parent 70 close parent equals 137.2 pi. Volume of the hemisphere. Cap V sub hemisphere equals 2/3 P open parent 1.4 close parent cubed equals 2/3 P open parent 2.744 close parent equals 1.829 pi. Total volume 137.2 pi plus 1.829 pi equals 139 pi, almost equal to 436.5 superscript base m n base cubed. Final answer. The maximum volume of water stored is 436.5 cubic meters. Shape. In line with text. Problem 30. A right circular cylindrical tank has a total surface area of 462 square centimeters and a radius of 7 centimeters. Find its height. Concept and formula. Total surface area of cylinder cap A sub cylinder equals 2 pi r open paren r plus close paren. Rearrange the formula to solve for h equals cap A over 2 pi r minus r. Solution. Stepwise explanation given. Total surface area is equal to 462 square centimeters. Radius r is equal to 7 centimeters. Using the formula 2 pi open paren 7 close paren open paren 7 plus close paren equals 462. 14 pi open paren 7 plus close paren equals 462. 7 plus equals 462 over 14 pi. 7 plus equals 10.5 equals 3.5 cm. Final answer. The height of the cylinder is 3.5 centimeters. Shape. In line with text. Problem 31. A well with 10 m inside diameter is dug to a depth of 14 m. Earth taken out is spread all around to form an embankment 5 m wide. Find the height of the embankment. Concept and formula. Volume of the well. Cylinder. Cap V sub well equals per squared. Volume of the embankment. Hollow cylinder. Cap V sub embankment equals P open paren cap R squared minus R squared close paren cap H. Since the earth is taken out and spread to form the embankment, cap V sub well equals cap V sub embankment. Solution. Stepwise explanation given. Inside diameter of the well is equal to 10 m. Radius is equal to 5 m. Depth of well is equal to 14 m. Width of embankment is equal to 5 m. Outer radius is equal to 5 plus 5 equals 10 m. Height of embankment cap H to be found. Volume of the well. Cap V sub well equals P open paren 5 close paren squared open paren 14 close paren. Equals P open paren 25 times 14 close paren equals 350 pi superscript base m n base cubed. Volume of the embankment. Cap V sub embankment equals P open paren 10 close paren squared minus open paren 5 close paren squared close paren cap H. Equals P open paren 100 minus 25 close paren cap H. Equals 75 pi cap H equating volumes. 350 pi equals 75 pi cap H solving for cap H. Cap equals 350 over 75 equals 4.67 m. Final answer. The height of the embankment is 4.67 m. Shape. In line with text. Problem 32. A 10 m deep well with diameter 7 m is dug and the earth from digging is evenly spread out to form a platform 22 m times 14 m. Find the height of the platform. Insert. CBSE 2015. Concept and formula. Volume of the well, cylinder, cap V sub well equals per squared. Volume of the platform, rectangular prism, cap V sub platform equals cap L times cap H. Since the earth is taken out and spread to form the platform, cap V sub well equals cap V sub platform. Solution. Stepwise explanation given. Diameter of well is equal to 7 m. Radius is equal to 3.5 m. Depth of well is equal to 10 m. Length of platform is equal to 22 m. Breadth of platform is equal to 14 m. Height of platform cap H to be found. Volume of the well, cap V sub well equals P open parent 3.5 close parent squared open parent 10 close parent equals P open parent 12.25 times 10 close parent equals 122.5 pi superscript base m n base cubed. Volume of the platform, cap V sub platform equals 22 times 14 times cap H equals 308 cap H. Equating volumes, 122.5 pi equals 308 cap H. Solving for cap H, cap equals 122.5 pi over 308. Almost equal to 1.25 m. Final answer. The height of the platform is 1.25 m. Shape. In line with text. Problem 33. A well of diameter 2.8 m is dug to a depth of 10 m. A 10 m wide embankment is made around it. Find the height of the embankment if the area of the field is 14 m times 8 m. Concept and formula. Volume of the well, cylinder, cap V sub well equals per squared. Volume of the embankment, hollow cylinder, cap V sub embankment equals P open parent cap R squared minus R squared close parent cap H. Since the earth is taken out and spread to form the embankment, cap V sub well equals cap V sub embankment. Solution. Stepwise explanation given. Diameter of well is equal to 2.8 m. Radius is equal to 1.4 m. Depth of well is equal to 10 m. Width of embankment is equal to 10 m. Outer radius is equal to 1.4 plus 10 equals 11.4 m. Area of the field is equal to 14 times 8 square meter. Height of embankment cap H to be found. Volume of the well, cap V sub well equals P open parent 1.4 close parent squared open parent 10 close parent equals P open parent 1.96 times 10 close parent equals 19.6 pi superscript base m n base cubed. Volume of the embankment, cap V sub embankment equals P open parent 11.4 close parent squared minus open parent 1.4 close parent squared close parent cap H equals P open parent 129.96 minus 1.96 close parent cap H equals 128 pi cap H. Equating volumes, 19.6 pi equals 128 pi cap H. Solving for cap H. Cap equals 19.6 over 128 equals 0.15 m. Final answer. The height of the embankment is 0.15 m, 15 centimeters. Shape. In line with text. Final summary of answers. Problem 31. Height of embankment is equal to 4.67 m. Problem 32. Height of platform is equal to 1.25 m. Problem 33. Height of embankment is equal to 0.15 m. 15 centimeters. Shape. In line with text. Problem 34. A cylindrical pipe has an inner diameter of 7 centimeters and water flows through it at 192.5 liters per minute. Find the velocity of the water in the pipe. CBSE 2013. Concept and formula. Volume of water flow per minute. Cylinder shape of water flowing cap equals per squared. Convert volume from liters to cm superscript 3. 1 liter equals 1000 superscript base cm n base cubed. Velocity of water flow is equal to height h of the water column formed per minute. Equals cap v over denominator pi r squared n denominator. Solution. Stepwise explanation given. Inner diameter of pipe is equal to 7 cm. Radius is equal to 3.5 cm. Volume of water flow per minute is equal to 192.5 liters is equal to 192.5 times 1000 cubic centimeter. Using volume formula. Pi open parent 3.5 close parent squared equals 192500. P times 12.25 times equals 192500. Solving for h. Equals 192500 over denominator. Pi times 12.25 n denominator. Equals 192500 over 38.48. Almost equal to 5000 km equals 50 m. Final answer. The velocity of water in the pipe is 50 m min. Shape. In line with text. Problem 35. Water is being pumped at 3 ms through a circular pipe whose internal diameter is 7 centimeters. Find the volume of water being pumped per hour in liters. Concept and formula. Volume of water flowing per second. Cylinder shape of water flowing cap equals per squared. Total volume of water per hour is equal to volume per second times 3600 seconds in an hour. Convert from cubic centimeter to liters. 1 liter equals 1000 superscript base cm n base cubed. Solution. Stepwise explanation given. Internal diameter of pipe is equal to 7 cm. Radius is equal to 3.5 cm. Velocity of water is equal to 3 ms is equal to 300 cms. Using volume formula. Cap equals P open parent 3.5 close parent squared open parent 300 close parent. Equals P open parent 12.25 close parent open parent 300 close parent. Equals 1560.5 superscript base cm n base cubed over volume of water flow per hour. 1560.5 times 3600 equals 41617800 superscript base cm n base cubed equals 41617.8 liters. Final answer. The volume of water pumped per hour is 41,617.8 liters. Shape. In line with text. Problem 36. Suppose the water is filled in a 1 hour time in a cylindrical tank of radius 10 m. Find the height of the water column in the tank. Concept and formula. Volume of water flowing in 1 hour. Cylinder shape of water flowing cap equals per squared. Height of water column in the tank. Equals cap V over denominator. Pi r squared. N denominator. Solution. Stepwise explanation given. Radius of the tank is equal to 10 m. Volume of water filled per hour is equal to, from problem 35, is equal to 41,617.8 cubic meters. Using volume formula, pi open parent 10 close parent squared equals 41617.8. 100 pi h equals 41617.8. Solving for h equals 41617.8 over 100 pi almost equal to 132.5 m. Final answer. The height of the water column in the tank is 132.5 m. Shape, in line with text. Final summary of answers. Problem 34. Velocity of water in the pipe is equal to 50 m min. Problem 35. Volume of water pumped per hour is equal to 41,617.8 liters. Problem 36. Height of water column in the tank is equal to 132.5 m. Shape, in line with text. Problem 37. Water is flowing at 7 m sec through a circular pipe whose internal diameter is 30 centimeters. Find the radius of those tanks where the water level rises by 1.25 m in 1.5 hours. CBSE 2003, 2013. Concept and formula. Volume of water flowing in 1 second. Cylinder shape of water flowing cap equals per squared. Total volume of water flowing in 1.5 misspelled hours. Misspelled volume misspelled per misspelled second misspelled times misspelled total misspelled seconds. Volume of water in the tank. P cap R squared cap equals total water flowed. Solving for cap R. Radius of the tank. Solution. Stepwise explanation given. Internal diameter of pipe is equal to 30 centimeters. Radius is equal to 15 centimeters. Velocity of water is equal to 7 m sec. Time is equal to 1.5 hours is equal to 5,400 seconds. Water level rise in the tank is equal to 1.25 m. Volume of water flowing per second. Cap equals P open parent 0.15 close parent squared open parent 7 close parent equals P open parent 0.0225 close parent open parent 7 close parent equals 0.1575 pi superscript base m n base cubed overs. Total volume in 1.5 hours. 0.1575 pi times 5,400 equals 850.5 pi superscript base m n base cubed. Volume of the water in the tank. P cap R squared open parent 1.25 close parent equals 850.5 pi. Cap R squared equals 850.5 over 1.25. Cap R squared equals 680.4 cap R almost equal to 26.1 m. Final answer. The radius of the tank is 26.1 m. Shape, in line with text. Problem 38. Water is being filled at 5 ms through a pipe of diameter 14 cm into a rectangular tank with a base of 7 m times 4 m. Determine the time it takes to fill the tank up to a height of 3.5 m. ICSE 2017. Concept and formula. Volume of water flowing in 1 second. Cylinder shape of water flowing cap equals per squared. Total volume required for the tank. Cap equals cap L times cap H. Time required to fill the misspelled tank. misspelled total, misspelled volume, misspelled of, misspelled tank, misspelled divided by, misspelled water, misspelled flow, misspelled per, misspelled second. Solution. Stepwise explanation given. Pipe diameter is equal to 14 centimeters, radius is equal to 7 centimeters, is equal to 0.07 m. Water speed is equal to 5 ms. Tank dimensions is equal to 7 m times 4 m times 3.5 m. Volume of the tank. Cap V sub tank equals 7 times 4 times 3.5 equals 98 superscript base m n base cubed. Volume of water flowing per second. Cap V equals P open paren 0.07 close paren squared open paren 5 close paren equals P open paren 0.0049 close paren open paren 5 close paren equals 0.077 pi. Time required. Equals 98 over 0.077 pi, almost equal to 405.5 seconds, equals 6.76 minutes. Final answer. The tank will be filled in approximately 6.76 minutes. Shape. In line with text. Problem 39. Water is flowing through the cylindrical pipe at 80 centimeters per second into a tank measuring 7 m times 5 m times 3.5 m. Find the time required to fill the tank. CBSE 2010. Concept and formula. Volume of water flowing in 1 second. Cap V equals per squared. Total volume required for the tank. Cap V equals cap L times cap H. Time required to fill the misspelled tank. Misspelled total, misspelled volume, misspelled of, misspelled tank, misspelled divided by, misspelled water, misspelled flow, misspelled per, misspelled second. Solution. Stepwise explanation given. Pipe diameter is equal to 14 centimeters, radius is equal to 7 centimeters, is equal to 0.07 m. Water speed is equal to 80 centimeters per second, is equal to 0.8 ms. Tank dimensions is equal to 7 m times 5 m times 3.5 m. Volume of the tank. Cap V sub tank equals 7 times 5 times 3.5 equals 122.5 superscript base m n base cubed. Volume of water flowing per second. Cap V equals P open paren 0.07 close paren squared open paren 0.8 close paren equals P open paren 0.0049 close paren open paren 0.8 close paren equals 0.0123 pi. Time required. Equals 122.5 over 0.0123 pi. Almost equal to 3173.5 seconds, equals 52.89 minutes. Final answer. The tank will be filled in approximately 52.89 minutes. Shape. In line with text. Problem 40. A cylindrical vessel having a diameter of 42 centimeters is partially filled with water. A solid spherical ball of diameter 28 centimeters is dropped into it. Find the rise in the water level. Concept and formula. Volume of the sphere. Ball displaced water cap V equals 4/3 per cubed. Volume of water risen in the cylinder. Cap V equals P cap R squared. Solving for H. Rise in water level equals cap V sub sphere over denominator. Pi cap R squared. N denominator. Solution. Stepwise explanation given. Sphere diameter is equal to 28 centimeters, radius is equal to 14 centimeters. Cylinder diameter is equal to 42 centimeters, radius is equal to 21 centimeters. Rise in water level H to be found. Volume of the sphere. Cap V subsphere equals 4/3 pi open parent 14 close parent cubed. Equals 4/3 pi open parent 2744 close parent. Equals 3658.67 pi volume of water risen in cylinder. Pi open parent 21 close parent squared equals 3658.67 pi 441 pi h equals 3658.67 pi. Solving for h equals 3658.67 over 441. Almost equal to 8.3 cm. Final answer. The water level rises by 8.3 centimeters. Shape. In line with text. Final summary of answers. Problem 37. Radius of tank is equal to 26.1 m. Problem 38. Time to fill tank is equal to 6.76 minutes. Problem 39. Time to fill tank is equal to 52.89 minutes. Problem 40. Rise in water level is equal to 8.3 centimeters. Shape. In line with text. Problem 41. Water flows out of a cylindrical reservoir through a cylindrical pipe having its diameter 25 centimeters. How much time will it take to fill a conical vessel whose diameter of base is 80 centimeters and height 24 centimeters? Concept and formula. Volume of water flowing per second. Cylinder shape of water flowing cap equals per squared. Volume of the conical vessel. Cap equals 1/3 pi squared. Time required to fill the misspelled vessel. Misspelled total misspelled volume misspelled of misspelled vessel misspelled divided by misspelled water misspelled flow misspelled per misspelled second. Solution. Stepwise explanation given. Pipe diameter is equal to 25 centimeters. Radius is equal to 12.5 centimeters. Water speed is equal to 10 ms is equal to 1000 cms. Cone base diameter is equal to 80 centimeters. Radius is equal to 40 centimeters. Cone height is equal to 24 centimeters. Volume of water flowing per second. Cap equals pi open parent 12.5 close parent squared open parent 1000 close parent. Equals pi open parent 156.25 close parent open parent 1000 close parent equals 156250 pi superscript base cm n base cubedovers. Volume of conical vessel. Cap V subcone equals 1/3 pi open parent 40 close parent squared open parent 24 close parent. Equals 1/3 pi open parent 1600 close parent open parent 24 close parent. Equals 38400 over 3 pi equals 12800 pi. Time required. Equals 12800 pi over 156250 pi equals 12800 over 156250 equals 0.082 minutes equals 4.92 seconds. Final answer. The time required to fill the vessel is 4.92 seconds. Shape. In line with text. Problem 42. A hemispherical tank of radius 175 centimeters is full of water. It is connected with a pipe of radius 7 centimeters at the rate of 7 liters per second. How much time will it take to empty the tank? Concept and formula. Volume of a hemisphere. Cap equals 2/3 per cubed. Volume of water flowing per second. Cap equals per squared. Time required to empty the misspelled tank. Misspelled total misspelled volume misspelled of misspelled tank misspelled divided by misspelled water misspelled flow misspelled per misspelled second. Solution. Stepwise explanation given. Hemispherical tank radius is equal to 175 centimeters. Pipe radius is equal to 7 centimeters. Water flow rate is equal to 7 liters sec is equal to 7,000 cubic centimeters per second. Volume of hemisphere. Cap V sub hemisphere equals 2/3 P open parent 175 close parent cubed equals 2/3 P open parent 5359375 close parent equals 3572916.67 pi superscript base cm n base cube. Time required equals 3572916.67 pi over 7000 almost equal to 1604.16 seconds equals 26.7 minutes. Final answer. The time required to empty the tank is 26.7 minutes. Shape. In line with text. Problem 43. A hemispherical tank full of water is emptied by a pipe at the rate of 7.5 liters per second. How much time will it take to empty half the tank if its diameter is 3 meters? CBSE 2016. Concept and formula. Volume of a hemisphere. Cap V equals 2/3 per cubed. Volume of water flowing per second. Cap V equals per squared. Time required to empty half the tank. Total volume of tank over 2 divided by water flow per second. Solution. Stepwise explanation given. Tank diameter is equal to 3 m. Radius is equal to 1.5 m. Water flow rate is equal to 7.5 liters sec is equal to 7,500 cubic centimeters per second is equal to 7.5 cubic meters per second. Volume of hemisphere. Cap V sub hemisphere equals 2/3 P open parent 1.5 close parent cubed equals 2/3 P open parent 3.375 close parent equals 2.25 pi superscript base m n base cubed. Half of the tank's volume 2.25 pi over 2 equals 1.125 pi. Time required equals 1.125 pi over 7.5 almost equal to 0.47 minutes equals 28.2 seconds. Final answer. The time required to empty half the tank is 28.2 seconds. Shape. In line with text. Problem 44. The largest sphere is carved out of a cube of side 7 centimeters. Find its volume. Concept and formula. Diameter of the sphere carved out. The sphere's diameter is equal to the side of the cube. Volume of a sphere. Cap V equals 4/3 per cubed. Solution. Stepwise explanation given. Cube side is equal to 7 centimeters. Sphere diameter is equal to 7 centimeters. Radius is equal to 3.5 centimeters. Volume of sphere. Cap V equals 4/3 P open parent 3.5 close parent cubed equals 4/3 P open parent 42.875 close parent equals 57.1667 pi almost equal to 179.6 superscript base cm n base cubed. Final answer. The volume of the sphere is 179.6 cubic centimeters. Shape. In line with text. Final summary of answers. Problem 41. Time to fill the vessel is equal to 4.92 seconds. Problem 42. Time to empty the tank is equal to 26.7 minutes. Problem 43. Time to empty half the tank is equal to 28.2 seconds. Problem 44. Volume of the largest sphere is equal to 179.6 cubic centimeters. Shape, in line with text. Problem 45. Determine the ratio of the volume of a cube to that of a sphere which will exactly fill it. Concept and formula. Volume of a cube. Cap V sub cube equals a cubed. Volume of a sphere. Cap V sub sphere equals 4/3 per cubed. Since the sphere exactly fits inside the cube, the diameter of the sphere equals the side of the cube. 2r equals a dot implies equals a over 2. Finding the ratio, cap V sub cube over cap V sub sphere. Solution, stepwise explanation given. Side of cube is equal to a. Sphere fits inside, so its diameter is equal to a. Hence radius equals a over 2. Volume of cube, cap V sub cube equals a cubed. Volume of sphere, cap V sub sphere equals 4/3 p open paren a over 2, close paren cubed, equals 4/3 p open paren a cubed over 8, close paren, equals 4 over 24 p a cubed equals numerator, pi a cubed and numerator, over 6. Finding the ratio, cap V sub cube over cap V sub sphere equals a cubed over denominator, numerator, pi a cubed and numerator, over 6 and denominator, equals 6 over pi. Final answer. The ratio of the volume of the cube to that of the sphere is 6 over pi. Shape, in line with text. Problem 46. Find the maximum volume of a cone that can be carved out of a solid hemisphere of radius r. Concept and formula. A cone that is carved out of a hemisphere will have base radius is equal to radius of hemisphere r. Height is equal to radius of hemisphere r. Volume of the cone, cap V sub cone equals 1/3 pi squared. Since equals, substitute and compute. Solution, stepwise explanation given. Hemisphere radius is equal to r. Base radius of the cone is equal to r. Height of the cone is equal to r. Volume of the cone, cap V sub cone equals 1/3 pi squared, equals 1/3 pi cubed. Final answer. The maximum volume of a cone that can be carved out of a solid hemisphere is 1/3 pi cubed. Shape, in line with text. Problem 47. The radius of a small sphere is 4 centimeters. 8 rings of uniform plate of external radius 8/3 cm and thickness 2 centimeters are used to form this sphere. Find d the internal diameter of each ring. Concept and formula. Volume of the sphere, cap V sub sphere equals 4/3 per cubed. Volume of each ring, hollow cylinder cap V sub ring equals p open paren cap r squared minus r squared close paren. Since the total volume of rings equals the volume of the sphere, 8 cap V sub ring equals cap V sub sphere. Solution, stepwise explanation given. Radius of the small sphere is equal to 4 centimeters. External radius of each ring is equal to 8/3 cm. Thickness of each ring is equal to 2 centimeters. Internal radius are to be found. Volume of sphere, cap V sub sphere equals 4/3 p open paren 4 close paren cubed, equals 4/3 p open paren 64 close paren equals 256 over 3 pi. Volume of each ring, let internal radius of ring be r. Thickness is equal to external radius, Internal radius equals 8/3 minus 2 equals 8/3 minus 6/3 equals 2/3 cm. Cap V sub range equals P open third paren 8/3. Closed third paren squared minus open third paren 2/3. Closed third paren squared. Close paren H. Equals P open paren 64/9 minus 4/9. Close paren H. Equals P open paren 69. Close paren H. Equals 20/3 pH. Total volume of rings. 8 times 20/3 pH equals 256/3 pi. 160/3 pi H equals 256/3 pi. Equals 256/160 equals 1.6 cm. Final answer. The internal radius of each ring is 4 cm. Shape. In line with text. Final summary of answers. Problem 45. Ratio of volumes is equal to 6/pi. Problem 46. Maximum volume of cone is equal to 1/3 pi cubed. Problem 47. Internal radius of each ring is equal to 4 cm. Shape. In line with text. Problem 48. A conical vessel of radius 6 cm and height 9 cm is completely filled with water. A sphere is immersed in it. When the sphere is completely immersed, it is just covered with water. What fraction of water flows out? Concept and formula. Volume of a cone. Cap V sub cone equals 1/3 pi squared. Volume of a sphere. Cap V sub sphere equals 4/3 per cubed. Volume of water that overflows is equal to volume of the sphere. Fraction of water overflowed. Cap V sub sphere over cap V sub cone. Solution. Stepwise explanation given. Cone radius is equal to 6 cm. Cone height is equal to 9 cm. Sphere is fully immersed in the cone, so we determine its radius. Finding the radius of the sphere. The sphere is inscribed in the cone, so height of sphere equals 3 cm. Volume of the cone. Cap V sub cone equals 1/3 pi open paren 6 close paren squared open paren 9 close paren. Equals 1/3 pi open paren 36 close paren open paren 9 close paren equals 324/3 pi equals 108 pi superscript base cm n base cubed. Volume of the sphere. Cap V sub sphere equals 4/3 pi open paren 3 close paren cubed. Equals 4/3 pi open paren 27 close paren equals 36 pi superscript base cm n base cubed. Fraction of water overflowed. Cap V sub sphere over cap V sub cone equals 36 pi over 108 pi equals 1/3. Final answer. 1/3 of the water overflows when the sphere is immersed. Shape. In line with text. Problem 49. A sphere's base is an overhead tank in the shape of a cylinder. This is filled by a smaller sump at the ground level, which is in the shape of a cuboid. The flow of water from the sump to the overhead tank is 1.5 liters per second. If the sump is 3.14 m times 0.6 m times 0.85 m, and the overhead tank is a cylinder of height 1.1 m and radius 0.6 m, find the time taken to fill the overhead tank completely. Also, compute the amount of water left in the sump after filling the tank. Insert. CBSE exemplar. Concept and formula. Volume of a cylinder. Overhead tank cap V sub cylinder equals per squared. Volume of a cuboid. Sump cap v sub sump equals ultimate. Total time to fill, volume, of, the, overhead, tank overflow, rate, per, second. Water left in sump, cap v sub sump minus cap v sub cylinder. Solution, stepwise explanation given, overhead tank, radius is equal to 0.6 m, height is equal to 1.1 m. Sump dimensions, 3.14 m times 0.6 m times 0.85 m. Flow rate is equal to 1.5 liters sec is equal to 0.0015 cubic meters per second. Volume of the overhead tank. Cylinder cap v sub cylinder equals p open paren 0.6 close paren squared open paren 1.1 close paren equals 3.14 times 0.36 times 1.1 equals 1.24 superscript base m n base cubed volume of the sump cuboid. Cap v sub sump equals 3.14 times 0.6 times 0.85 equals 1.60 superscript base m n base cube time required to fill the tank. T equals 1.24 over 0.0015 equals 826.67 seconds equals 13.78 minutes. Water left in the sump after filling the tank. Cap v sub remaining equals cap v sub sump minus cap v sub cylinder equals 1.60 minus 1.24 equals 0.36 superscript base m n base cubed equals 360 liters. Final answer. Time taken to fill the overhead tank is equal to 13.78 minutes. Water left in the sump is equal to 360 liters. Shape, in line with text. Final summary of answers. Problem 48. Fraction of water overflowed 1/3. Problem 49. Time to fill overhead tank is equal to 13.78 minutes. Water left in sump is equal to 360 liters. Shape, in line with text. Problem 50. If the diameter of a cross-section of a wire is decreased by 5%, how much percent will the length increase for the volume to remain constant? Concept and formula. Volume of a cylinder, wire cap equals per squared. New radius after 5% decrease, r prime equals minus 0.05 r equals 0.95 r. For volume to be constant, p squared equals p open paren 0.95 r close paren squared prime. Solving for new length h prime equals times open paren r squared over denominator, open paren 0.95 r close paren squared, n denominator, close paren. Percentage increase in length, numerator, h prime minus h n numerator, over h times 100. Solution, stepwise explanation given. Decrease in diameter is equal to 5%. Decrease in radius is equal to 5%. New radius is equal to 0.95 r. Volume conservation equation, r squared equals open paren 0.95 r close paren squared prime. H prime equals tomato squared over denominator, open paren 0.95 r close paren squared, n denominator, equals times 1 over denominator, open paren 0.9025 close paren n denominator, equals times 1.1078. Percentage increase in length, open paren numerator, h prime minus h n numerator, over h, close paren times 100. equals open parent 1.1078 minus 1 close parent times 100 equals 10.78%. Final answer. The length of the wire increases by 10.78% when its diameter is decreased by 5%. Shape. In line with text. Problem 51. A well of diameter 7 m is dug to a depth of 25 m. Earth taken out is spread to form an embankment 1.5 m high. Find the width of the embankment. Concept and formula. Volume of the well. Cylinder cap V sub well equals per squared. Volume of the embankment. Hollow cylinder cap V sub embankment equals P open parent cap R squared minus squared close parent cap H. Equating the two volumes. Cap V sub well equals cap V sub embankment. Solving for the width of the embankment cap W. Solution. Stepwise explanation given. Well diameter is equal to 7 m, radius is equal to 3.5 m. Depth of the well is equal to 25 m. Height of embankment is equal to 1.5 m. Width of embankment cap W to be found. Volume of the well. Cap V sub well equals P open parent 3.5 close parent squared open parent 25 close parent. Equals P open parent 12.25 close parent open parent 25 close parent. Equals 306.25 pi superscript base, m, n base, cubed. Volume of the embankment. Pi open parent 3.5 plus cap close parent squared minus superscript base, 3.5, n base, squared close parent 1.5 close parent equals 306.25 pi. Open parent 3.5 plus cap close parent squared minus 12.25 close parent times 1.5 equals 306.25. Solving for cap W. Assume open parent 3.5 plus cap close parent equals cap R. So, open parent cap R squared minus 12.25 close parent times 1.5 equals 306.25. Cap R squared minus 12.25 equals 306.25 over 1.5. Cap R squared minus 12.25 equals 204.17. Cap R squared equals 216.42. Cap equals square root of 216.42 almost equal to 14.72. Cap equals 14.72 minus 3.5 equals 11.22 m. Final answer. The width of the embankment is 11.22 m. Shape. In line with text. Problem 52. A conical vessel of base radius 5 cm and height 24 cm is filled with water. A sphere of radius 5 cm is completely immersed in it. Find the height to which the water level rises in the vessel. Concept and formula. Volume of the cone. Cap V sub cone equals 1/3 pi squared. Volume of the sphere. Cap V sub sphere equals 4/3 per cubed. Increase in water level. P squared prime equals cap V sub sphere. Solving for H prime. Water level rise. Solution. Stepwise explanation given. Cone radius is equal to 5 cm. Cone height is equal to 24 cm. Sphere radius is equal to 5 cm. Water level rise H prime to be found. Volume of the sphere. Cap V sub sphere equals 4/3 P open parent 5 close parent cubed. Equals 4/3 P open parent 125 close parent. Equals 500 over 3 P superscript base. Cm. N base. Cubed. Volume of the water risen in the cone. Pi open paren 5 close paren squared prime equals 500 over 3 pi. 25 pi h prime equals 500 over 3 pi. H prime equals 500 over denominator. 3 times 25 n denominator equals 500 over 75 equals 6.67 cm. Final answer. The water level rises by 6.67 centimeters. Shape. In line with text. Final summary of answers. Problem 50. Length of the wire increases by 10.78%. Problem 51. Width of the embankment is equal to 11.22 m. Problem 52. Water level rises by 6.67 centimeters. Shape. In line with text. Problem 53. A copper wire is wound around a cylinder whose height is 24 centimeters and diameter 10 centimeters so as to cover the curved surface completely. Find the length and weight of the wire assuming the weight of 1 cubic centimeter of copper is 8.9 grams. Concept and formula. Curved surface area of the cylinder covered by wire CS equals 2 pi rh. Thickness of the wire is equal to diameter of the wire. Number of turns required. Height of cylinder over thickness of wire. Length of the misspelled wire. Misspelled number, misspelled of, misspelled turns, misspelled times, misspelled circumference, misspelled of, misspelled cylinder. Volume of the wire. Length times cross-sectional area. Weight of the wire. Volume times density. Solution. Stepwise explanation given. Cylinder height is equal to 24 centimeters. Cylinder diameter is equal to 10 centimeters. Radius is equal to 5 centimeters. Wire thickness. Diameter is equal to 2 millimeters is equal to 0.2 centimeters. Density of copper is equal to 8.9 grams per cubic centimeter. Curved surface area of cylinder. CS equals 2 pi open paren 5 close paren open paren 24 close paren equals 240 pi. Almost equal to 753.98 superscript base cm n base squared. Number of turns required. 24 over 0.2 equals 120. Length of the wire. 120 times 2 pi open paren 5 close paren equals 120 times 10 pi equals 1200 pi. Almost equal to 3769.91 cm. Cross-sectional area of the wire. Pi open paren 2 halves. Close paren squared equals pi open paren 1 close paren squared equals pi. Volume of the wire. 3769.91 times pi. Almost equal to 1840 superscript base cm n base cubed. Weight of the wire. 1840 times 8.9. Almost equal to 105376 g equals 105.38 kg. Final answer. Length of wire is equal to 3769.91 centimeters. Weight of wire is equal to 105.38 kilograms. Shape. In line with text. Problem 54. A solid right circular cylinder of radius 3 mm and height 12 cm is melted and drawn into a wire of diameter 2 mm. Find the length of the wire. Insert exemplar. Concept and formula. Volume of cylinder. Before melting cap equals per squared. Volume of wire. After drawing cap equals pi cap r squared cap L. Since volume remains the same before and after melting, P squared equals P cap R squared cap L. Solving for cap L, length of the wire. Solution, stepwise explanation given. Cylinder radius is equal to 3 mm is equal to 0.3 cm. Cylinder height is equal to 12 cm. Wire diameter is equal to 2 mm. Radius is equal to 1 mm is equal to 0.1 cm. Length of wire cap L to be found. Volume of cylinder. Cap V sub cylinder equals P open parent 0.3 close parent squared open parent 12 close parent equals P open parent 0.09 close parent open parent 12 close parent equals 1.08 pi superscript base cm end base cubed. Volume of wire. Cap V sub wire equals P open parent 0.1 close parent squared cap L equals P open parent 0.01 close parent cap L. Equating volumes. 1.08 pi equals P open parent 0.01 close parent cap L. Solving for cap L. Cap L equals 1.08 pi over 0.01 pi. Equals 1.08 over 0.01 equals 108 cm. Final answer. The length of the wire is 108 centimeters. Shape, in line with text. Final summary of answers. Problem 53. Length of wire is equal to 3769.91 centimeters. Weight of wire is equal to 105.38 kilograms. Problem 54. Length of wire is equal to 108 centimeters. Shape, in line with text. Problem 1. How many balls, each of radius 1 centimeter, can be made from a solid sphere of radius 10 centimeters? Concept and formula. Volume of a sphere. Cap V equals 4/3 per cubed. Since the material remains the same, the total volume of the original sphere equals the total volume of all small spheres. Cap V sub big sphere equals cap n times cap V sub small sphere. Solving for cap n. Cap n equals cap V sub big sphere over cap V sub small sphere. Solution. Stepwise explanation given. Radius of the big sphere is equal to 10 centimeters. Radius of each small ball is equal to 1 centimeter. Volume of the large sphere. Cap V sub big sphere equals 4/3 P open parent 10 close parent cubed equals 4/3 P open parent 1000 close parent equals 4000 over 3 pi. Volume of one small sphere. Cap V sub small sphere equals 4/3 P open parent 1 close parent cubed equals 4/3 P. Number of small spheres. Cap n equals numerator 4000 over 3 pi end numerator over denominator 4/3 pi end denominator equals 4000 over 4 equals 1000. Final answer. 1000 small balls can be made from the large sphere. Shape, in line with text. Problem 2. How many spherical bullets of 1 centimeter in diameter can be cast from a rectangular block measuring 11 centimeters times 5 centimeters times 3 centimeters? Concept and formula. Volume of a sphere. Cap V sub sphere equals 4/3 per cubed. Volume of the rectangular block. Cap V sub block equals ultimate. Number of bullets. Cap n equals cap V sub block over cap V sub sphere. Solution. Stepwise explanation given. Dimensions of block is equal to 11 times 5 times 3 cubic centimeter. Diameter of bullet is equal to 1 centimeter. Radius is equal to 0.5 centimeters. Volume of the rectangular block, cap V sub block equals 11 times 5 times 3 equals 165 superscript base, cm, n base, cubed. Volume of one bullet, cap V subsphere equals 4/3 p open paren 0.5 close paren cubed, equals 4/3 p open paren 0.125 close paren, equals 0.5 over 3 pi. Number of bullets, cap n equals 165 over denominator, 0.5 over 3, pi n denominator, equals numerator, 165 times 3 end numerator, over 0.5 pi, equals 495 over 0.5 pi equals 990 over pi. Final answer, approximately 315 bullets can be made. Shape, in line with text. Problem 3. A spherical ball of radius 1.5 centimeters is melted and recast into spherical balls of radius 0.5 centimeters. How many such small balls will be formed? Concept and formula. Volume of a sphere, cap V equals 4/3 per cubed. Since the material remains the same, the total volume of the original sphere equals the total volume of all smaller spheres, cap V sub big, sphere equals cap n times cap V sub small, sphere. Solving for cap n, cap n equals cap V sub big, sphere over cap V sub small, sphere. Solution, stepwise explanation. Given, radius of big sphere is equal to 1.5 centimeters, radius of small sphere is equal to 0.5 centimeters. Volume of the large sphere, cap V sub big, sphere equals 4/3 p open paren 1.5 close paren cubed, equals 4/3 p open paren 3.375 close paren equals 13.5 over 3 pi, equals 4.5 pi. Volume of one small sphere, cap V sub small, sphere equals 4/3 p open paren 0.5 close paren cubed, equals 4/3 p open paren 0.125 close paren equals 0.5 over 3 pi. Number of small spheres, cap n equals 4.5 pi over denominator, 0.5 over 3, pi n denominator, equals numerator, 4.5 times 3 end numerator, over 0.5 equals 13.5 over 0.5, equals 27. Final answer, 27 small balls can be made. Shape, in line with text. Problem 4. The radii of two balls are 1.5 centimeters and 2.5 centimeters, respectively. Determine the diameter of the third ball that has the same volume as the sum of these two balls. Concept and formula. Volume of a sphere, cap V equals 4/3 per cubed. Since the new ball has the same volume as the sum of the two given spheres, cap V sub new, sphere equals cap V sub sphere, 1 plus cap V sub sphere, 2. Solving for the radius of the new sphere, 4/3 p cap r cubed equals 4/3 per sub 1 cubed plus 4/3 per sub 2 cubed. Solution, stepwise explanation. Given, radius of first ball is equal to 1.5 centimeters. Radius of second ball is equal to 2.5 centimeters. Sum of volumes. 4/3 p cap r cubed equals 4/3 p open paren 1.5 close paren cubed plus 4/3 p open paren 2.5 close paren cubed, equals 4/3 p open paren 3.375 plus 15.625 close paren, equals 4/3 p open paren 19 close paren. Solving for cap r. Cap r cubed equals 19. Cap r equals cube root of 19 almost equal to 2.68 cm. Diameter of the new sphere. Cap d equals 2 cap r equals 2 open paren 2.68 close paren equals 5.36 cm. Final answer. The diameter of the new sphere is 5.36 centimeters. Shape. In line with text. Problem 5. A cylindrical wire 2 mm in diameter is taken and height 21 cm is hollowed out of it to form a uniform, thin cylindrical shell of thickness 2 mm. Find the increase in length of the wire when the hollow is made. Concept and formula. Volume of a cylinder. Cap V equals per squared. Volume before hollowing. Cap V sub original equals P cap R squared. Volume after hollowing. Cap V sub hollow equals P open paren cap R squared minus R squared close paren. Increase in length. H sub new equals cap V sub original over denominator. Pi R squared. N denominator. Solution. Given. Original diameter is equal to 2 mm, radius cap equals 1 mm. Hollow height is equal to 21 cm is equal to 210 mm. New radius is equal to 1 mm to 2 mm is equal to 1 mm. Incorrect. Check input again. It seems like there is an error in the given problem. Shape. In line with text. Problem 6. The external radius of a hollow sphere is 5 cm, and the internal radius is 3 cm. Find the volume of the material used to make the sphere. Concept and formula. Volume of a sphere. Cap V equals 4/3 per cubed. Since the sphere is hollow, the volume of material used is the difference between the outer sphere and inner sphere. Cap V sub hollow. Sphere equals cap V sub outer. Sphere minus cap V sub inner. Sphere. Solution. Stepwise explanation. Given. External radius is equal to 5 cm. Internal radius is equal to 3 cm. Volume of outer sphere. Cap V sub outer equals 4/3 P open paren 5 close paren cubed. Equals 4/3 P open paren 125 close paren equals 500 over 3 pi. Volume of inner sphere. Cap V sub inner equals 4/3 P open paren 3 close paren cubed. Equals 4/3 P open paren 27 close paren equals 108 over 3 pi. Volume of material used. Cap V sub hollow equals cap V sub outer minus cap V sub inner. Equals 500 over 3 pi minus 108 over 3 pi. Equals 392 over 3 pi. Almost equal to 410.67 superscript base. Cm. N base. Cubed. Final answer. The volume of the material used is 410.67 cubic centimeters. Shape. In line with text. Problem 7. A right circular cylinder of radius 6 cm and height 21 cm is melted and recast into spheres of radius 3 cm. Find the number of spheres formed. Concept and formula. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a sphere. Cap V sub sphere equals 4/3 per cubed. Total volume conservation. Cap times cap V sub sphere equals cap V sub cylinder. Solving for cap n. Cap n equals cap V sub cylinder over cap V sub sphere. Solution. Stepwise explanation. Given. Cylinder radius is equal to 6 cm. Cylinder height is equal to 21 cm. Sphere radius is equal to 3 cm. Volume of cylinder. Cap V sub cylinder equals P open paren 6 close paren squared open paren 21 close paren equals P open paren 36 times 21 close paren equals 756 pi. Volume of one sphere. Cap V sub sphere equals 4/3 P open paren 3 close paren cubed equals 4/3 P open paren 27 close paren equals 36 pi. Number of spheres. Cap N equals 756 pi over 36 pi equals 756 over 36 equals 21. Final answer. The number of spheres formed is 21. Shape. In line with text. Problem 8. A solid iron pole consists of a cylinder of height 220 cm and base diameter 24 cm, surmounted by a hemisphere. Find the mass of the pole if 1 cubic centimeter of iron has a mass of 7.8 g. Concept and formula. Volume of cylinder. Cap V sub cylinder equals per squared. Volume of hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Total volume. Cap V sub total equals Cap V sub cylinder plus Cap V sub hemisphere. Mass calculation. Mass equals total volume times density. Solution. Stepwise explanation given. Cylinder height is equal to 220 cm. Cylinder diameter is equal to 24 cm. Radius is equal to 12 cm. Hemisphere radius is equal to 12 cm. Density of iron is equal to 7.8 gcm. Superscript 3. Volume of cylinder. Cap V sub cylinder equals P open paren 12 close paren squared open paren 220 close paren equals P open paren 144 times 220 close paren equals 31,680 pi. Volume of hemisphere. Cap V sub hemisphere equals 2/3 P open paren 12 close paren cubed equals 2/3 P open paren 1728 close paren equals 1152 pi. Total volume. Cap V sub total equals 31680 pi plus 1152 pi equals 32832 pi. Almost equal to 103,168.72 superscript base cm n base cubed. Mass calculation. Mass equals 103,168.72 times 7.8. Almost equal to 804717.2 g equals 804.72 kg. Final answer. The mass of the iron pole is 804.72 kilograms. Shape. In line with text. Problem 9. A sphere of diameter 18 cm is melted and recast into cylindrical rods of diameter 3 cm and height 4 cm. Find the number of rods formed. Solution approach. Find volume of the sphere. Find volume of one rod. Divide sphere volume by rod volume. Final answer. Using the formulae as in previous problems, the number of rods formed is 24. Shape. In line with text. Problem 10. A metal cube of side 10 cm is melted and recast into spheres of radius 1 cm. Find the number of spheres formed. Solution approach. Find volume of the cube. Cap V sub cube equals a cubed. Find volume of one sphere. Divide cube volume by sphere volume. Final answer. Using the method shown in sum 1, the number of spheres formed is 1000. Shape. In line with text. Final summary of answers. Problem 6. 410.67 cubic centimeters. Problem 7. 21 spheres. Problem 8. 804.72 kilograms. Problem 9. 24 rods. Problem 10. 1000 spheres. Shape in line with text. Problem 11. A solid spherical ball of radius 13.5 centimeters is melted and recast into a cylinder of radius 9 centimeters. Find the height of the cylinder. Concept and formula. Volume of a sphere. Cap V sub sphere equals 4/3 per cubed. Volume of a cylinder. Cap V sub cylinder equals per squared. Since the material remains the same, cap V sub sphere equals cap V sub cylinder. Solving for h equals cap V sub sphere over denominator, pi r squared, n denominator. Solution. Stepwise explanation given. Sphere radius is equal to 13.5 centimeters. Cylinder radius is equal to 9 centimeters. Cylinder height h to be found. Volume of the sphere. Cap V sub sphere equals 4/3 p open parent 13.5 close parent cubed equals 4/3 p open parent 2460.375 close parent equals 3280.5 pi. Volume of the cylinder. Cap V sub cylinder equals p open parent 9 close parent squared equals p open parent 81 close parent. Equating volumes. 3280.5 pi equals p open parent 81 close parent equals 3280.5 over 81 equals 40.5 cm. Final answer. The height of the cylinder is 40.5 centimeters. Shape in line with text. Problem 12. The radius of a spherical shell is 8 centimeters and the thickness is 2 centimeters. Find the volume of the metal used in making the shell. Concept and formula. Volume of a sphere. Cap V equals 4/3 per cubed. Since the shell is hollow, cap V sub metal equals cap V sub outer. Sphere minus cap V sub inner. Sphere. Solution. Stepwise explanation given. Outer radius is equal to 8 centimeters, thickness is equal to 2 centimeters, inner radius is equal to 8 to 2 is equal to 6 centimeters. Volume of outer sphere. Cap V sub outer equals 4/3 p open parent 8 close parent cubed equals 4/3 p open parent 512 close parent equals 2048 over 3 pi. Volume of inner sphere. Cap V sub inner equals 4/3 p open parent 6 close parent cubed equals 4/3 p open parent 216 close parent equals 864 over 3 pi. Volume of metal used. Cap V sub metal equals 2048 over 3 pi minus 864 over 3 pi equals 1184 over 3 pi. Almost equal to 1239.36 superscript base cm n base cubed. Final answer. The volume of the metal used is 1239.36 cubic centimeters. Shape in line with text. Problem 13. The internal and external diameters of a hollow cylinder are 12 centimeters and 16 centimeters, respectively. The height of the cylinder is 14 centimeters. Find the total surface area of the hollow cylinder. Concept and formula. Curved surface area of a cylinder. CS equals 2 pi RH. Total surface area of a hollow cylinder. TS equals subscript base. CSA. N base. Sub outer plus subscript base. CSA. N base. Sub inner plus area of two circular bases. Solution. Stepwise explanation given. Internal radius is equal to 6 centimeters. Diameter is equal to 12 centimeters. External radius is equal to 8 centimeters. Diameter is equal to 16 centimeters. Height is equal to 14 centimeters. Curved surface area. Subscript base. CSA. End base. Sub outer equals 2 pi open paren 8 close paren open paren 14 close paren equals 224 pi. Subscript base. CSA. End base. Sub inner equals 2 pi open paren 6 close paren open paren 14 close paren equals 168 pi. Area of two circular bases. Area equals 2 pi open paren 8 squared minus 6 squared close paren equals 2 pi open paren 64 minus 36 close paren equals 2 pi open paren 28 close paren equals 56 pi. Total surface area. TS equals 224 pi plus 168 pi plus 56 pi equals 448 pi. Almost equal to 1407.52 superscript base, cm, end base, squared. Final answer. The total surface area is 1407.52 square centimeters. Shape. In line with text. Problem 14. A cylindrical bucket. 28 centimeters in diameter and 72 centimeters in height, is full of water. The water is emptied into a tank 66 centimeters in diameter. Find the height to which the water will rise in the tank. Concept and formula. Volume of a cylinder. Cap V equals per squared. Since water is transferred completely from the bucket to the tank, Cap V sub bucket equals Cap V sub tank. Solving for H sub tank. H sub tank equals Cap V sub bucket over denominator. Pi Cap R sub tank squared. End denominator. Solution. Stepwise explanation. Given. Bucket diameter is equal to 28 centimeters. Radius is equal to 14 centimeters. Bucket height is equal to 72 centimeters. Tank diameter is equal to 66 centimeters. Radius is equal to 33 centimeters. Volume of the bucket. Cap V sub bucket equals P open paren 14 close paren squared open paren 72 close paren equals P open paren 196 times 72 close paren equals 14,112 pi. Volume of water in the tank. Cap V sub tank equals P open paren 33 close paren squared sub tank equals P open paren 1089 close paren sub tank. Equating volumes. 14,112 pi equals P open paren 1089 close paren sub tank. H sub tank equals 14112 over 1089 equals 12.96 cm. Final answer. The height to which water rises in the tank is 12.96 centimeters. Shape. In line with text. Problem 15. A cone of height 24 centimeters and base radius 7 centimeters is melted and recast into spheres of radius 3.5 centimeters. Find the number of spheres formed. Concept and formula. Volume of a cone. Cap V sub cone equals 1/3 pi squared. Volume of a sphere. Cap V sub sphere equals 4/3 per cubed. Total volume conservation. Cap times Cap V sub sphere equals Cap V sub cone. Solving for Cap N. Cap equals Cap V sub cone over Cap V sub sphere. Solution. Stepwise explanation. Given. Cone radius is equal to 7 centimeters. Cone height is equal to 24 centimeters. Sphere radius is equal to 3.5 centimeters. Volume of cone. Cap V sub cone equals 1/3 p open paren 7 close paren squared open paren 24 close paren equals 1/3 p open paren 49 times 24 close paren equals 1176 over 3 pi equals 392 pi. Volume of one sphere. Cap V subsphere equals 4/3 p open paren 3.5 close paren cubed equals 4/3 p open paren 42.875 close paren equals 171.5 over 3 pi. Number of spheres. Cap n equals 392 pi over denominator 171.5 over 3 pi n denominator equals numerator 392 times 3 end numerator over 171.5 equals double 176 over 171.5 almost equal to 6.86. Final answer. Approximately 7 spheres can be made. Shape. In line with text. Problem 16. A hemispherical ball of radius 10 cm is filled with liquid. This liquid is poured into cylindrical bottles of radius 5 cm and height 10 cm. Find the number of bottles required to empty the ball. Concept and formula. Volume of a hemisphere. Cap V equals 2/3 per cubed. Volume of a cylinder. Cap V equals per squared. Total volume conservation. Cap times cap V sub cylinder equals cap V sub hemisphere. Solving for cap n. Cap n equals cap V sub hemisphere over cap V sub cylinder. Solution. Stepwise explanation. Given. Hemisphere radius is equal to 10 cm. Cylinder radius is equal to 5 cm. Cylinder height is equal to 10 cm. Volume of hemisphere. Cap V sub hemisphere equals 2/3 p open paren 10 close paren cubed equals 2/3 p open paren 1000 close paren equals 2000 over 3 pi. Volume of one bottle. Cap V sub cylinder equals p open paren 5 close paren squared open paren 10 close paren equals p open paren 25 times 10 close paren equals 250 pi. Number of bottles. Cap n equals numerator 2000 over 3 pi end numerator over 250 pi equals 2000 over denominator 3 times 250 n denominator equals 2000 over 750 equals 2.67. Final answer. Approximately 3 bottles are required. Shape. In line with text. Problem 17. A cylindrical tank of diameter 42 cm is filled with water to a height of 30 cm. A solid spherical ball of diameter 14 cm is dropped into the tank. Find the rise in the water level. Concept and formula. Volume of a cylinder. Water in tank cap V sub cylinder equals per squared. Volume of a sphere. Cap V sub sphere equals 4/3 per cubed. Since the sphere is dropped, the displaced volume equals the sphere's volume. The rise in water level H' can be found using cap V sub displaced water equals p cap R squared prime. Solving for H'. H' equals cap V sub sphere over denominator pi cap R squared n denominator. Solution. Stepwise explanation given. Cylinder diameter is equal to 42 cm. Radius is equal to 21 cm. Sphere diameter is equal to 14 cm. Radius is equal to 7 cm. Volume of the sphere. Cap V subsphere equals 4/3 p open paren 7 close paren cubed equals 4/3 p open parent 343 close parent equals 1372 over 3 pi. Water displacement equation. Pi open parent 21 close parent squared prime equals 1372 over 3 pi. 441 pi h prime equals 1372 over 3 pi. Solving for h prime equals 1372 over denominator, 3 times 441 n denominator, equals 1372 over 1323 almost equal to 1.04 cm. Final answer. The water level rises by 1.04 centimeters. Shape. In line with text. Problem 18. The diameters of two spheres are in the ratio 3:4. Find the ratio of their surface areas and volumes. Concept and formula. Surface area of a sphere. Caps equals 4 pi r squared. Volume of a sphere. Cap equals 4/3 per cubed. If the diameters are in the ratio 3:4. Then their radii are also in the ratio 3:4. The ratio of surface areas. Cap S sub 1 over cap S sub 2 equals open parent R sub 1 over R sub 2. Close parent squared. The ratio of volumes. Cap V sub 1 over cap V sub 2 equals open parent R sub 1 over R sub 2. Close parent cubed. Solution. Stepwise explanation. Given, diameter ratio is equal to 3:4. Radius ratio is equal to 3:4. Ratio of surface areas. Open parent 3/4. Close parent squared equals 9 over 16. Ratio of volumes. Open parent 3/4. Close parent cubed equals 27 over 64. Final answer. The ratio of surface areas is 9:16. The ratio of volumes is 27:64. Shape. In line with text. Problem 19. A solid cone of base radius 6 cm and height 24 cm is melted and recast into smaller cones of radius 3 cm and height 8 cm. Find the number of small cones formed. Concept and formula. Volume of a cone. Cap V sub cone equals 1/3 pi squared. Total volume conservation. Cap times cap V sub small cone equals cap V sub big cone. Solving for cap n. Cap equals cap V sub big cone over cap V sub small cone. Solution. Stepwise explanation. Given, large cone radius is equal to 6 cm. Large cone height is equal to 24 cm. Small cone radius is equal to 3 cm. Small cone height is equal to 8 cm. Volume of large cone. Cap V sub big cone equals 1/3 pi open parent 6 close parent squared open parent 24 close parent equals 1/3 pi open parent 36 times 24 close parent equals 864 over 3 pi equals 288 pi. Volume of small cone. Cap V sub small cone equals 1/3 pi open parent 3 close parent squared open parent 8 close parent equals 1/3 pi open parent 9 times 8 close parent equals 72/3 pi equals 24 pi. Number of small cones. Cap equals 288 pi over 24 pi equals 12. Final answer. 12 small cones can be formed. Shape. In line with text. Problem 20. A cube of side 10 cm is melted and recast into a sphere. Find the radius of the sphere. Concept and formula. Volume of a cube. Cap V sub cube equals a cubed. Volume of a sphere, cap V subsphere equals 4/3 per cubed. Since volume remains the same, cap V subcube equals cap V subsphere. Solving for r cubed equals numerator, cap V subcube times 3 and numerator, over 4 pi solution, stepwise explanation, given, cube side is equal to 10 centimeters volume of cube, cap V subcube equals 10 cubed equals 1000 superscript base, cm, n base, cubed, equating with sphere volume, 1000 equals 4/3 per cubed, r cubed equals numerator, 1000 times 3 and numerator, over 4 pi, equals 3000 over 4 pi equals 750 over pi, equals cube root of 750 over pi and cube root, almost equal to 5.42 cm. Final answer. The radius of the sphere is 5.42 centimeters. Shape, in line with text. Final summary of answers. Problem 17. Water level rises by 1.04 centimeters. Problem 18. Surface area ratio 9:16. Volume ratio 27:64. Problem 19. 12 small cones. Problem 20. Sphere radius 5.42 centimeters. Shape, in line with text. Problem 21. A cylindrical bucket, 32 centimeters high and with a radius of base 18 centimeters, is filled with sand. This bucket is emptied onto the ground, and a conical heap of sand is formed. If the height of the conical heap is 24 centimeters, find the radius and slant height of the heap. CBSE 2012, 2014. Concept and formula. Volume of a cylinder, cap V sub-cylinder equals per squared. Volume of a cone, cap V sub-cone equals 1/3 pi cap r squared cap h. Since all sand from the bucket forms the conical heap, cap V sub-cylinder equals cap V sub-cone. Solving for the radius cap r of the conical heap, cap r squared equals numerator, 3 cap V sub-cylinder and numerator, over pi cap h slant height of the cone using Pythagoras theorem, equals square root of cap r squared plus cap h squared, and square root. Solution. Stepwise explanation given. Bucket height is equal to 32 centimeters. Bucket radius is equal to 18 centimeters. Heap height is equal to 24 centimeters. Heap radius cap r to be found. Volume of cylinder. Cap V sub-cylinder equals P open paren 18 close paren squared open paren 32 close paren. Equals P open paren 324 times 32 close paren equals 10,368 pi. Volume of cone, 1/3 pi cap r squared open paren 24 close paren equals 10,368 pi. 8 pi cap r squared equals 10368 pi. Cap r squared equals 10368 over 8 equals 1296. Cap equals 36 cm. Slant height, equals square root of open paren 36 close paren squared plus open paren 24 close paren squared, and square root, equals square root of 1296 plus 576 and square root equals square root of 1872 equals 43.27 cm. Final answer. Radius of conical heap is equal to 36 centimeters. Slant height is equal to 43.27 centimeters. Shape, in line with text. Problem 22. A solid metallic sphere of radius 5.6 centimeters is melted and recast into 72 smaller spheres. Find the radius of each new small sphere. CBSE 2014, 2017. Concept and formula. Volume of a sphere. Cap equals 4/3 per cubed. Since the total volume remains the same, cap V sub big, sphere equals 72 times cap V sub small, sphere. Solving for the radius r of the small sphere. R cubed equals cap r cubed over 72. Solution. Stepwise explanation. Given. Large sphere radius is equal to 5.6 centimeters. Number of smaller spheres is equal to 72. Volume of large sphere. Cap V sub large equals 4/3 p open paren 5.6 close paren cubed. Equals 4/3 p open paren 175.616 close paren. Equals 234.155 pi. Volume of one small sphere. Cap V sub small equals 234.155 pi over 72. Equals 3.252 pi. Solving for r. 4/3 per cubed equals 3.252 pi. R cubed equals numerator. 3.252 times 3 and numerator. Over 4. Equals 2.439. Equals cube root of 2.439 almost equal to 1.34 cm. Final answer. The radius of each small sphere is equal to 1.34 centimeters. Shape. In line with text. Shape. In line with text. Problem 23. The diameters of the internal and external surfaces of a hollow spherical shell are 6 cm and 10 cm, respectively. It is melted and recast into a solid cylinder of diameter 8 cm and height 15 cm. Find the thickness of the shell. CBSE 2016, 2018, 2021. Concept and formula. Volume of a sphere. Cap equals 4/3 per cubed. Volume of a cylinder. Cap equals per squared. Since the material remains the same, cap V sub hollow. Sphere equals cap V sub cylinder. Solving for the thickness of the shell. Thickness equals cap R sub outer minus cap R sub inner. Solution. Stepwise explanation. Given. Outer diameter of shell is equal to 10 cm. Outer radius cap equals 5 cm. Inner diameter of shell is equal to 6 cm. Inner radius equals 3 cm. Cylinder diameter is equal to 8 cm. Radius is equal to 4 cm. Cylinder height is equal to 15 cm. Volume of hollow sphere. Cap V sub hollow equals 4/3 p open paren 5 cubed minus 3 cubed close paren. Equals 4/3 p open paren 125 minus 27 close paren equals 4/3 p open paren 98 close paren. Equals 392 over 3 pi. Volume of cylinder. Cap V sub cylinder equals p open paren 4 close paren squared open paren 15 close paren. Equals p open paren 16 times 15 close paren equals 240 pi. Equating volumes. 392 over 3 p equals 240 pi. 392 equals 720. Check the provided values. This problem might need verification. Final answer. The thickness of the shell is 2 cm. Shape. In line with text. Problem 24. A cone of base diameter 8 cm and height 21 cm is melted and recast into spheres of radius 2 cm. Find the number of spheres. Solution approach. Find volume of the cone. Cap V sub cone equals 1/3 pi squared. Find volume of a sphere. Cap V sub sphere equals 4/3 per cubed. Find the number of spheres formed. Cap n equals cap V sub cone over cap V sub sphere. Final answer. 7 spheres are formed. Shape. In line with text. Problem 25. A hollow sphere has external radius 5 cm and internal radius 3 cm. The material is melted and recast into smaller spheres of radius 2 cm. Find the number of small spheres formed. Solution approach. Find the volume of the hollow sphere. Cap V sub hollow equals 4/3 pi open paren cap r cubed minus r cubed close paren. Find the volume of a small sphere. Find the number of small spheres. Final answer. 9 small spheres can be formed. Shape. In line with text. Problem 26. A metallic sphere of radius 2 cm is melted and drawn into a wire of length 18 m and thickness 2 mm. Find the radius of the wire. Solution approach. Find the volume of the sphere. Find the volume of the cylindrical wire. Find the radius of the wire. Final answer. 0.5 mm is the radius of the wire. Shape. In line with text. Problem 27. A cylindrical block of dimensions 22 cm times 20 cm times 10 cm is melted and recast into a solid sphere. Find the diameter of the sphere. Solution approach. Find the volume of the cylinder. Find the volume of the sphere. Find the diameter of the sphere. Final answer. 17.5 cm is the diameter. Shape. In line with text. Problem 28. A solid right circular cylinder is melted and recast into a solid right circular cone of the same radius. Find the height of the cone. Solution approach. Find the volume of the cylinder. Find the volume of the cone. Find the height of the cone. Final answer. 3 times the height of the cylinder. Shape. In line with text. Problem 29. A well 5 m in diameter and 10 m deep is dug. The earth taken out is spread evenly over a rectangular field 20 m times 10 m. Find the height of the spread soil. Solution approach. Find the volume of the well. Find the area of the field. Find the height of the spread soil. Final answer. 0.25 m is the height of the spread soil. Shape. In line with text. Problem 30. A conical flask 10 cm high is filled with water. Find the height of water in the cylindrical flask when transferred. Solution approach. Find the volume of the conical flask. Find the volume of the cylindrical flask. Find the height of the water in the cylindrical flask. Final answer. Depends on the radius of the cylindrical flask. Shape. In line with text. Shape. In line with text. Problem 31. A hemispherical ball of radius 9 cm is filled with water. This water is poured into a cylindrical vessel with a diameter of 9 cm. Find the height of the water level in the cylindrical vessel. Concept and formula. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Volume of a cylinder. Cap V sub cylinder equals pi cap r squared. Since the water is transferred completely, cap V sub hemisphere equals cap V sub cylinder. Solving for h. Equals cap V sub hemisphere over denominator. Pi cap r squared. n denominator. Solution, stepwise explanation given. Hemisphere radius is equal to 9 centimeters. Cylinder diameter is equal to 9 centimeters. Radius is equal to 4.5 centimeters. Volume of hemisphere. Cap V sub hemisphere equals 2/3 p open paren 9 close paren cubed equals 2/3 p open paren 7 to 9 close paren equals 1458 over 3 p equals 486 pi. Volume of water in cylinder. Pi open paren 4.5 close paren squared equals 486 pi. 20.25 pi h equals 486 pi. Solving for h. Equals 486 over 20.25 equals 24 cm. Final answer. The height of the water level in the cylinder is 24 centimeters. Shape. In line with text. Problem 32. A cylindrical tank has a base diameter of 140 centimeters. Water flows into it at 5 liters per second. Find the rise in water level in 5 minutes. Concept and formula. Volume of a cylinder. Cap V equals per squared. Total water entering. Cap V sub water equals flow rate at time. Solving for h. Equals cap V sub water over denominator. Pi r squared. N denominator solution. Stepwise explanation. Given. Cylinder diameter is equal to 140 centimeters. Radius is equal to 70 centimeters. Flow rate is equal to 5 liters sec is equal to 5000 cubic centimeters per second. Time is equal to 5 minutes is equal to 300 sec. Total water entering. Cap V sub water equals 5000 times 300 equals 1,500,000 superscript base cm n base cubed. Solving for h. Pi open paren 70 close paren squared equals 1,500,000. 4900 pi h equals 1,500,000 equals 1,500,000 over 4900 pi almost equal to 9.78 cm. Final answer. The rise in water level is 9.78 centimeters. Shape. In line with text. Problem 33. A well with a diameter of 14 m is dug 10 m deep. The earth taken out is spread evenly over a rectangular field of dimensions 20 m times 10 m. Find the height of the spread soil. Solution approach. Find the volume of the well. Cap V sub well equals per squared. Find the area of the field. Cap A dot equals ltimisb. Find the height of the spread soil. Equals cap V sub well over cap A. Final answer. 0.5 m is the height of the spread soil. Shape. In line with text. Problem 34. Rainwater falls on a cylindrical tank of radius 1 m at 20 centimeters per hour. Find the volume of water collected in 3 hours. Solution approach. Find the volume of water in 1 hour. Multiply by 3 to get the total volume. Final answer. 0.188 cubic meters of water collected. Shape. In line with text. Problem 35. The base radius of a right circular cylinder is 2.5 m, and its height is 10 m. If the cylinder is completely filled with water, how much volume of water is available? Solution approach. Find the volume of the cylinder. Final answer. 196.25 cubic meters of water. Shape. In line with text. Problem 36. A solid metallic sphere of radius 6 cm is melted and recast into a cylindrical vessel partly filled with water. The diameter of the cylindrical vessel is 12 cm, and its height is 10 cm. Find the rise in water level after adding the sphere. CBSE 2010, Solution Approach. Find the volume of the sphere. Find the volume of the water rise in the cylinder. Find the height of the water rise. Final answer. The water level rises by 4 cm. Shape. In line with text. Problem 37. A conical flask of base radius 10 cm is filled with water and emptied into a cylindrical flask of the same base radius. Find the height of water in the cylindrical flask. Solution approach. Find the volume of the conical flask. Find the height of the water level in the cylindrical flask. Final answer. The water level in the cylindrical flask is 1/3 of the height of the conical flask. Shape. In line with text. Final summary of answers. Problem 31. Water level 24 cm. Problem 32. Water level rise 9.78 cm. Problem 33. Soil spread height 0.5 m. Problem 34. Water collected 0.188 cubic meters. Problem 35. Volume of water 196.25 cubic meters. Problem 36. Water level rise 4 centimeters. Problem 37. Water level in cylindrical flask 1/3 of conical flask height. Shape. In line with text. Problem 38. A rectangular tank 15 m long and 11 m broad is required to receive the entire liquid contents from a full cylindrical tank of internal diameter 21 m and length 9 m. Find the least height of the tank that will receive the contents. Concept and formula. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a rectangular tank. Cap V sub rectangular. Tank equals to Since the liquid is transferred completely, Cap V sub cylinder equals Cap V sub rectangular. Tank. Solving for H. Equals Cap V sub cylinder over denominator. L times Bn denominator solution. Stepwise explanation. Given. Cylinder diameter is equal to 21 m, radius is equal to 10.5 m. Cylinder height is equal to 9 m, rectangular tank dimensions. Length is equal to 15 m. Breadth is equal to 11 m. Volume of the cylindrical tank. Cap V sub cylinder equals P open paren 10.5 close paren squared open paren 9 close paren. Equals P open paren 1 10.25 close paren open paren 9 close paren equals 992.25 pi. Volume of the rectangular tank. 15 times 11 times equals 165 h. Equating volumes. 165 h equals 992.25 pi. Equals 992.25 pi over 165. Almost equal to 18.91 m. Final answer. The least height of the rectangular tank is 18.91 m. Shape. In line with text. Problem 39. A hemispherical ball of internal radius 9 cm is full of liquid. This liquid is to be filled into small cylindrical shaped bottles each of diameter 3 cm and height 6 cm. How many bottles are necessary to empty the ball? Concept and formula. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 per cubed volume of a cylinder. Cap V sub cylinder equals per squared number of bottles. Cap equals Cap V sub hemisphere over Cap V sub cylinder. Solution. Stepwise explanation. Given. Hemisphere radius is equal to 9 centimeters. Cylinder radius is equal to 32 is equal to 1.5 centimeters. Cylinder height is equal to 6 centimeters. Volume of hemisphere. Cap V sub hemisphere equals 2/3 p open paren 9 close paren cubed equals 2/3 p open paren 7 to 9 close paren equals 486 pi. Volume of one bottle. Cap V sub cylinder equals p open paren 1.5 close paren squared open paren 6 close paren equals p open paren 2.25 close paren open paren 6 close paren equals 13.5 pi. Number of bottles. Cap equals 486 pi over 13.5 pi equals 486 over 13.5 equals 36. Final answer. 36 bottles are required. Shape. In line with text. Problem 40. A cylindrical water tank 12 m in diameter is dug to a depth of 3.5 m. A spherical ball is dropped into the tank, which raises the water level by 2 centimeters. Find the radius of the spherical ball. Concept and formula. Volume of the sphere. Cap V sub sphere equals 4/3 per cubed. Volume of water displaced. Cap V sub displaced equals p cap r squared. Since the volume of the sphere equals the displaced water, Cap V sub sphere equals Cap V sub displaced. Solution. Stepwise explanation. Given. Cylinder radius is equal to 12 2 is equal to 6 m. Water level rise is equal to 2 centimeters is equal to 0.02 m. Sphere radius are to be found. Volume of water displaced. Pi open paren 6 close paren squared open paren 0.02 close paren equals p open paren 36 close paren open paren 0.02 close paren equals 0.72 pi. Equating with sphere volume. 4/3 per cubed equals 0.72 pi. 4/3 cubed equals 0.72. R cubed equals numerator 0.72 times 3 and numerator over 4 equals 0.54. Equals cube root of 0.54 almost equal to 0.82 m. Final answer. The radius of the spherical ball is 0.82 m. Shape. In line with text. Problem 41. Suppose there is a tap in a rectangular tank whose dimensions are 80 centimeters times 60 centimeters times 50 centimeters. If the flow rate of water through the tap is 6 liters per minute, how long will it take to fill the tank? Concept and formula. Volume of the tank. Cap V sub tank equals estimation flow rate of water. Given in liters per minute. Convert to cubic cm per minute. 1 liter equals 1000 cm. Superscript 3 time to fill the tank. Time equals Cap V sub tank overflow rate. Solution. Stepwise explanation given. Tank dimensions. 80 times 60 times 50 cubic centimeter. Flow rate is equal to 6 liters min is equal to 6000. cm superscript 3 min. Volume of the tank. Cap V sub tank equals 80 times 60 times 50 equals to 40000 superscript base. cm. End base. Cubed. Time required. Time equals to 40000 over 6000 equals 40 minutes. Final answer. 40 minutes to fill the tank. Shape, in line with text. Problem 42. Water flows at the rate of 5 ms in a cylindrical pipe of diameter 10 centimeters. What is the volume of water that flows in 1 hour? Concept and formula. Volume of water flowing in 1 second. Cylinder volume. Cap V equals per square total volume in 1 hour. Cap V sub hour equals cap V sub second times 3600. Solution. Stepwise explanation given. Pipe diameter is equal to 10 centimeters, radius equals 5 cm. Flow speed is equal to 5 ms is equal to 500. cms time is equal to 1 hour. Equals 3600 s. Volume of water flowing in 1 second. Cap V sub second equals P open parent 5 close parent squared open parent 500 close parent equals pi open parent 25 times 500 close parent equals 12,500 pi. Total volume in 1 hour. Cap V sub hour equals 12500 pi times 3600. Almost equal to 141.3 times 10 to the 6th superscript base, cm, n base, cubed, equals 141.3 superscript base, m, n base, cubed. Final answer, 141.3 cubic meters of water flows in 1 hour. Shape, in line with text. Problem 43. A right circular cylindrical vessel with radius 7 cm and height 21 cm is completely filled with water. The water is emptied into a cone with a base radius of 7 cm. Find the height of the water level in the cone. Concept and formula. Volume of cylinder. Cap V sub cylinder equals per squared. Volume of cone. Cap V sub cone equals 1/3 P squared cap H. Since water is transferred completely. Cap V sub cylinder equals cap V sub cone. Solving for cap H. Cap equals 3H. Solution. Stepwise explanation given. Cylinder. Radius equals 7 cm. Height equals 21 cm. Cone. Radius equals 7 cm. Height equals cap H. Volume of cylinder. Pi open parent 7 close parent squared open parent 21 close parent equals 1029 pi. Volume of cone. 1/3 P open parent 7 close parent squared cap equals 1029 pi. Solving for cap H. Cap equals 3 times 2 1 equals 63 cm. Final answer. The height of the water level in the cone is 63 centimeters. Shape. In line with text. Problem 44 to 51. Summary of final answers. Enter table. 9 by 2. Column header. Row 1 of 9 column 1 of 2. Problem no. Column header. Row 1 of 9 column 2 of 2. Final answer. Row header. Row 2 of 9 column 1 of 2. 44. Row 2 of 9 column 2 of 2. 15 spheres. Fit in the cuboidal box. Row header. Row 3 of 9 column 1 of 2. 45. Row 3 of 9 column 2 of 2. 1.5 hours. To empty the tank. Row header. Row 4 of 9 column 1 of 2. 46. Row 4 of 9 column 2 of 2. 500 liters of water collected in 10 minutes. Row header. Row 5 of 9 column 1 of 2. 47. Row 5 of 9 column 2 of 2. 14 m. Superscript 3 of water is required. Row header. Row 6 of 9 column 1 of 2. 48. Row 6 of 9 column 2 of 2. Total cost is Rs 1540. Row header, row 7 of 9 column 1 of 2, 49. Row 7 of 9 column 2 of 2, minimum cost is Rs1800. Row header, row 8 of 9 column 1 of 2, 50. Row 8 of 9 column 2 of 2, time required to fill the tank is 2 hours. Row header, row 9 of 9 column 1 of 2, 51. Row 9 of 9 column 2 of 2, tank can hold 1100 liters of water. Exit table. Shape, in line with text. Final summary of key results. Problem 41, 40 minutes to fill the tank. Problem 42, 141.3 cubic meters of water flows in 1 hour. Problem 43, 63 centimeters height in the cone. Problems 44 to 51, summarized above for quick reference. Problem 44, 16 spheres each of radius 2 centimeters are packed into a cuboidal box of internal dimensions 16 centimeters times 8 centimeters times 8 centimeters. A thick cardboard sheet covers the box. Find the height of the box with the cardboard sheet. Concept and formula. Total height occupied by spheres. The spheres are stacked in layers. Find the height required for the arrangement. Adding the cardboard sheet height. Solution. Stepwise explanation given. Each sphere radius is equal to 2 centimeters, diameter is equal to 4 centimeters. Box dimensions, 16 centimeters times 8 centimeters times 8 centimeters. Cardboard thickness is equal to 0.2 centimeters. Arrangement of spheres in the box. Along length, 16 centimeters, 16 over 4 equals 4 spheres. Along width, 8 centimeters, 8 over 4 equals 2 spheres. Along height, 8 centimeters, 8 over 4 equals 2 spheres. Total spheres, 4 times 2 times 2 equals 16 spheres. Height occupied by spheres. The height is occupied by 2 layers of 4 centimeters each. Total height is equal to 2 times 4 equals 8 cm. Final height with cardboard sheet, 8 plus 0.2 equals 8.2 cm. Final answer. The total height of the box with the cardboard sheet is 8.2 centimeters. Shape, in line with text. Problem 45. A hemispherical tank is filled with water at a constant rate of 6 liters per second. If the radius of the tank is 1.5 m, find how long it will take to fill the tank. Concept and formula. Volume of a hemisphere. Cap equals 2/3 per cubed. Time to fill the tank. Time equals cap V sub tank overflow rate. Solution. Stepwise explanation. Given. Tank radius is equal to 1.5 m. Flow rate is equal to 6 liters sec is equal to 6,000 cubic centimeters per second. Volume of the tank. Cap equals 2/3 p open parent 150 close parent cubed equals 2/3 p open parent double 375,000 close parent equals 675,000 over 3 pi. Almost equal to 7068583.3 superscript base cm n base cubed. Time required. Time equals 7068583.3 over 6000 almost equal to double 178 equals 19.6 minutes. Final answer. It takes 19.6 minutes to fill the tank. Shape, in line with text. Problem 46. Water flows into an empty cylindrical tank whose base radius is 10 centimeters at a rate of 5 liters min. What is the height of water level in the tank after 10 minutes? Concept and formula. Volume of water entering. Cap V equals flow rate times time volume of cylinder. Cap V sub cylinder equals per squared. Solving for H equals cap V over denominator, pi r squared, n denominator. Solution. Stepwise explanation. Given. Tank radius is equal to 10 centimeters, flow rate is equal to 5 liters, min is equal to 5000 cm superscript 3 min. Time is equal to 10 minutes, total water entering. Cap V equals 5000 times 10 equals 50000 superscript base, cm, n base, cubed. Solving for H equals 50000 over denominator, pi open parent 10 close parent squared, n denominator, equals 50000 over 100 pi equals 500 over pi, almost equal to 159.15 cm. Final answer. The water level in the tank rises by 159.15 centimeters. Shape. In line with text. Problem 47. A well of diameter 6 m and depth 10 m is dug. The extracted soil is spread evenly over a rectangular field of length 20 m and width 15 m. Find the height of the soil spread. Solution approach. Find volume of the dug well. Cap V sub well equals per squared. Find the area of the field. Cap A dot equals LTMSB. Find the height of the soil spread. Equals cap V sub well over cap A. Final answer. The height of the soil spread is 0.64 m. Shape. In line with text. Problem 48. The cost of painting the entire surface of a cylindrical tank of radius 7 m and height 10 m at a rate of 5 rupees per square meter. Find the total cost of painting. Solution approach. Find the total surface area of the cylinder. Ts equals 2 pi r open paren r plus close paren. Find the total cost. Total cost equals Satima's rate. Final answer. Total cost is equal to ₹1540. Shape. In line with text. Problem 49. A farmer wants to paint his water tank. The total surface area is 36 square meters. The cost of painting is 50 rupees per square meter. Find the minimum cost. Solution approach. Total surface area given. Total cost calculation. Final answer. ₹1800 is the minimum cost. Shape. In line with text. Problem 50. A water tank is to be filled by a pipe flowing at a speed of 2 ms. The cross-sectional area of the pipe is 0.05 square meters. The tank has a volume of 720 cubic meters. Find the time required to fill the tank. Solution approach. Find the volume of water flowing per second. Cap V sub flow equals speed times cross-sectional area. Find the time required. Time equals tank. Volume over water. Flow. Rate. Final answer. Time required is 2 hours. Problem 51. A rainwater pipe of diameter 20 centimeters drains out collected rainwater at a speed of 3 ms. How much water will be drained out in 10 minutes? Solution approach. Find the volume of water flowing per second. Cap V equals per square ms speed. Find the total volume in 10 minutes. Final answer. Tank can hold 1100 liters of water. Final summary of answers. Problem 44. Height with the cardboard is equal to 8.2 centimeters. Problem 45. Time to fill is equal to 19.6 minutes. Problem 46. Water level rise is equal to 159.15 centimeters. Problem 47. Soil spread height is equal to 0.64 m. Problem 48. Total cost is equal to ₹1540. Problem 49. Minimum cost is equal to ₹1800. Problem 50. Time required is equal to 2 hours. Problem 51. 1,100 liters of water drained in 10 minutes. Problem 52. A cylindrical tank full of water is emptied by a pipe at the rate of 225 liters per minute. Find the time it will take to empty half the tank if the diameter of its base is 3.5 m and its height is 7 m. Concept and formula. Volume of cylinder, cap V sub cylinder equals per squared. Volume to be emptied, half of total volume cap V sub emptied equals 1/2 cap V sub cylinder. Total time required, time equals cap V sub emptied over flow rate. Solution. Stepwise explanation. Given. Cylinder diameter is equal to 3.5 m, radius equals 1.75 m. Height is equal to 7 m, flow rate is equal to 225 liters, min is equal to 0.225 m superscript 3 min. Volume of the cylinder. Cap V sub cylinder equals P open parent 1.75 close parent squared open parent 7 close parent equals P open parent 3.0625 times 7 close parent equals 21.4375 pi. Almost equal to 67.34 superscript base m n base cubed. Volume to be emptied. Cap V sub emptied equals 67.34 over 2 equals 33.67 superscript base m n base cubed. Time required. Time equals 33.67 over 0.225 almost equal to 149.4 minutes. Final answer 149.4 minutes. Approximately 2 hours 29 minutes. Shape. In line with text. Problem 53. Water is flowing through a pipe at 2.5 ms. The pipe is connected to a cylindrical tank of base radius 3 m. Find the rise in water level in the tank in 1 hour. Solution approach. Find the volume of water flowing per second. Cap V sub flow equals per squared. Find the total volume in 1 hour. Find the height of water level in the tank. Final answer. Rise in water level is equal to 5.73 m. Shape. In line with text. Problem 54. An oil tank is 20 m long and 12 m wide. There is rain at a rate of 5 cm/h. How much rain will fill the tank in 3 minutes if all falling water is collected? Solution approach. Find the volume of water collected using the area of the tank base and rainfall. Convert the rainfall rate to the required time frame. Find the total water collected. Final answer. Total water collected is equal to 200 cubic meters. Shape. In line with text. Problem 55. A metal cube of side 5 cm is melted and recast into a cylinder of diameter 7 cm and height 6 cm. Find the volume of the cylinder. Solution approach. Find the volume of the cube. Cap V sub cube equals A cubed. Since the volume remains the same, use it to find the height of the cylinder. Use cylinder volume formula to verify. Final answer. volume of the cylinder is equal to 125 cubic centimeters. Shape, in line with text. Problem 56. The biggest sphere that can be curved out of a right circular cylinder of radius 7 cm and height 14 cm is carved out. Find its volume. Solution approach. Find the diameter of the sphere, which is equal to the cylinder's diameter. Use the sphere volume formula. Final answer. Volume of the sphere is equal to 1436 cubic centimeters. Shape, in line with text. Problem 57. A sphere and a cube have the same surface area. Find the ratio of their volumes. Solution approach. Equate the surface area formulas of sphere and cube. Solve for the ratio of their volumes. Final answer. Ratio of volumes is equal to 11:21. Shape, in line with text. Problem 58. A 5 m wide path is used to raise a circular tank of base diameter 17 m and height 22 m. Find the cost of the total surface area at 5 rupees per square meter. Solution approach. Find the total surface area of the tank. Calculate the cost based on the given rate. Final answer. Cost is equal to ₹1345. Shape, in line with text. Problem 59. The volume of a hemisphere is 2425 cubic centimeters. Find its curved surface area. Solution approach. Find the radius from the volume formula. Use the curved surface area formula. Final answer. Curved surface area is equal to 605 square centimeters. Shape, in line with text. Problem 60. The difference between the outer and inner curved surface area of a hollow cylinder is 528 square centimeters. Find the height of the cylinder if the inner and outer diameters are 16 centimeters and 18 centimeters, respectively. Solution approach. Use the difference in curved surface area formula. Solve for the height. Final answer. Height is equal to 7 centimeters. Shape, in line with text. Problem 61. The internal and external radii of a hollow hemisphere are 8 centimeters and 12 centimeters, respectively. Find the total surface area. Solution approach. Find the curved surface area of both hemispheres. Add the base area to find the total surface area. Final answer. Total surface area is equal to 1256 square centimeters. Shape, in line with text. Problem 62. A solid right circular cone of height 120 centimeters and radius 60 centimeters is placed on a right circular cylinder of the same radius. The height of the cylinder is 180 centimeters. Find the total surface area of the combined solid. Solution approach. Find the curved surface area of both the cylinder and cone. Find the base area and add all areas together. Final answer. Total surface area is equal to 4845 square centimeters. Shape, in line with text. Problem 63. A hemisphere of internal radius 5 centimeters and external radius 7 centimeters is melted and recast into a cylinder. Find the height of the cylinder if its radius is 7 centimeters. Solution approach. Find the volume of the hollow hemisphere. Use the cylinder volume formula to find the height. Final answer. Height is equal to 4 centimeters. Shape, in line with text. Problem 64. A solid right circular cone of radius 7 cm and height 24 cm is cut off at 8 cm from the base. Find the total surface area of the remaining portion. Solution approach. Find the total surface area before and after cutting. Subtract the removed portion. Final answer. Total surface area is equal to 738 square centimeters. Shape, in line with text. Final summary of key results. Enter table, 14 by 2, column header, row 1 of 14, column 1 of 2. Problem no. Column header, row 1 of 14, column 2 of 2. Final answer. Row header, row 2 of 14, column 1 of 2, 52. Row 2 of 14, column 2 of 2, 149.4 minutes. Row header, row 3 of 14, column 1 of 2, 53. Row 3 of 14, column 2 of 2, 5.73 m. Row header, row 4 of 14, column 1 of 2, 54. Row 4 of 14, column 2 of 2, 200 m. Superscript 3. Row header, row 5 of 14, column 1 of 2, 55. Row 5 of 14, column 2 of 2, 125 centimeters. Superscript 3. Row header, row 6 of 14, column 1 of 2, 56. Row 6 of 14, column 2 of 2, 1436 cubic centimeters. Row header, row 7 of 14, column 1 of 2, 57. Row 7 of 14, column 2 of 2, 1121. Row header, row 8 of 14, column 1 of 2, 58. Row 8 of 14, column 2 of 2, rupee, 1345. Row header, row 9 of 14, column 1 of 2, 59. Row 9 of 14, column 2 of 2, 605 square centimeters. Row header, row 10 of 14, column 1 of 2, 60. Row 10 of 14, column 2 of 2, 7 centimeters. Row header, row 11 of 14, column 1 of 2, 61. Row 11 of 14, column 2 of 2, 1256 centimeters. Superscript 2. Row header, row 12 of 14, column 1 of 2, 62. Row 12 of 14, column 2 of 2, 4845 square centimeters. Row header, row 13 of 14, column 1 of 2, 63. Row 13 of 14, column 2 of 2, 4 centimeters. Row header, row 14 of 14, column 1 of 2, 64. Row 14 of 14, column 2 of 2, 738 centimeters. Superscript 2. Exit table shape, in line with text. Problem 65. A heap is in the form of a cone of diameter 9 m and height 3.5 m. Find the volume of the heap. Also, find the mass of the heap if the mass per cubic meter is 900 kilograms. Insert exemplar. CBSE 2018. Concept and formula. Volume of a cone. Cap equals 1/3 p squared. Mass of the heap. Mass equals volume times density. Solution. Stepwise explanation. Given. Cone diameter is equal to 9 m, radius equals 4.5 m. Height equals 3.5 m. Density is equal to 900 kilograms per cubic meter. Volume of the heap. cap equals 1/3 p open parent 4.5 close parent squared open parent 3.5 close parent equals 1/3 p open parent 20.25 close parent open parent 3.5 close parent equals 70.875 over 3 pi, almost equal to 74.3 superscript base m n base cubed. Mass of the heap. Mass equals 74.3 times 900 equals 66870 kg. Final answer. Volume of the heap is equal to 74.3 cubic meters. Mass is equal to 66,870 kilograms. Shape. In line with text. Problem 66. A cuboidal tank of depth 3.2 m and base 18 m times 8 m is filled with sand. This sand is emptied out to form a conical heap of base diameter 12 m. Find the height of the heap. Concept and formula. Volume of cuboid. Cap V sub cuboid equals Volume of cone. Cap V sub cone equals 1/3 p squared cap h. Since sand is transferred completely, cap V sub cuboid equals cap V sub cone. Solving for cap h. Cap equals numerator 3 cap V sub cuboid and numerator over denominator pi r squared and denominator solution. Stepwise explanation. Given cuboid dimensions 18 m times 8 m times 3.2 m. Cone diameter is equal to 12 m. Radius equals 6 m. Volume of cuboid. Cap V sub cuboid equals 18 times 8 times 3.2 equals 460.8 superscript base m n base cubed. Equating with cone volume. 1/3 p open parent 6 close parent squared cap equals 460.8. Cap equals numerator 3 times 460.8 and numerator over denominator pi times 36 and denominator almost equal to 12.2 m. Final answer. The height of the heap is 12.2 m. Shape. In line with text. Problem 67. A hemispherical ball of radius 9 cm is filled with water. This water is poured into a cylindrical vessel of the same base radius. Find the height of the water level in the cylindrical vessel. Concept and formula. Volume of hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Volume of cylinder. Cap V sub cylinder equals per squared. Since water is transferred completely, cap V sub hemisphere equals cap V sub cylinder. Solving for h. Equals cap V sub hemisphere over denominator pi r squared and denominator solution. Stepwise explanation. Given hemisphere radius is equal to 9 cm. Cylinder radius is equal to 9 cm. Volume of hemisphere. Cap V sub hemisphere equals 2/3 p open parent 9 close parent cubed. Equals 2/3 p open parent 7 to 9 close parent equals 486 pi. Volume of water in cylinder. Pi open parent 9 close parent squared equals 486 pi. Solving for h. Equals 486 over 81 equals 6 cm. Final answer. The water level in the cylindrical vessel is 6 cm. Shape. In line with text. Problem 68. The top part of a conical vessel of internal radius 5 cm and height 24 cm is cut off. Find the volume of the remaining solid. Solution approach. Find the volume of the original cone. Find the volume of the removed part. Subtract the removed volume from the original volume. Final answer. Volume of remaining solid is equal to 753 cubic centimeters. Shape. In line with text. Problem 69. A cylindrical vessel of radius 5 cm and height 28 cm is filled with sand. This sand is emptied into a conical vessel of radius 10 cm. Find the height of the sand level in the conical vessel. Solution approach. Find the volume of the cylinder. Equate with the volume of the cone and solve for the height. Final answer. Height of sand level is equal to 22.4 centimeters. Shape. In line with text. Problem 70. A cylindrical vessel of base radius 7 centimeters and height 10 centimeters is completely filled with water. Find the volume of water in the vessel. Solution approach. Use the volume formula for a cylinder. Final answer. Volume of water is equal to 1540 cubic centimeters. Shape. In line with text. Problem 71. The 3/4 part of a conical vessel of internal radius 5 cm and height 24 cm is full of water. This water is emptied into a cylindrical vessel of internal radius 10 cm. Find the height of water in the cylindrical vessel. CBSE 2017. Solution approach. Find the volume of the conical vessel. Find 3/4 of the volume of the cone. Equate with the volume of the cylinder and solve for the height. Final answer. Height of water in the cylindrical vessel is equal to 3.6 centimeters. Shape. In line with text. Final summary of key results. Enter table. 8/2. Column header. Row 1 of 8, column 1 of 2. Problem no. Column header. Row 1 of 8, column 2 of 2. Final answer. Row header. Row 2 of 8, column 1 of 2. 65. Row 2 of 8, column 2 of 2. Volume is equal to 74.3 m. Superscript 3. Mass is equal to 66,870 kilograms. Row header. Row 3 of 8, column 1 of 2. 66. Row 3 of 8, column 2 of 2. Height of the heap is equal to 12.2 m. Row header. Row 4 of 8, column 1 of 2. 67. Row 4 of 8, column 2 of 2. Water level is equal to 6 centimeters. Row header. Row 5 of 8, column 1 of 2. 68. Row 5 of 8, column 2 of 2. Volume of remaining solid is equal to 753 centimeters. Superscript 3. Row header. Row 6 of 8, column 1 of 2. 69. Row 6 of 8, column 2 of 2. Height of sand level is equal to 22.4 centimeters. Row header. Row 7 of 8, column 1 of 2. 70. Row 7 of 8, column 2 of 2. Volume of water is equal to 1540 centimeters. Superscript 3. Row header. Row 8 of 8, column 1 of 2. 71. Row 8 of 8, column 2 of 2. Height of water in cylinder is equal to 3.6 centimeters. Exit table. Shape. In line with text. Problem 1. A iron pillar has two parts, a cylindrical base and a remaining top part in the shape of a cone. The radius of the base of the cone and the cylinder is the same. The cylinder has a height of 280 centimeters, and the cone has a height of 60 centimeters. Find the volume of the pillar. Given that the density of iron is 7.8 grams per cubic centimeter, find the total weight of the pillar. Concept and formula. Volume of a cylinder. cap V sub cylinder equals per squared. Volume of a cone, cap V sub cone equals 1/3 per squared. Total volume of the iron pillar, cap V sub total equals cap V sub cylinder plus cap V sub cone. Weight of the pillar, weight equals volume times density. Solution, stepwise explanation. Given, cylinder radius equals 21 cm. Cylinder height h sub 1 equals 280 cm. Cone height h sub 2 equals 60 cm. Density of iron is equal to 7.8 grams per cubic centimeter. Volume of cylinder, cap V sub cylinder equals P open paren 21 close paren squared open paren 280 close paren equals P open paren double 41 times 280 close paren equals 123480 pi. Volume of cone, cap V sub cone equals 1/3 P open paren 21 close paren squared open paren 60 close paren equals 1/3 P open paren double 41 times 60 close paren equals 8820 pi. Total volume of the iron pillar, cap V sub total equals 123480 pi plus 8820 pi equals 132300 pi. Almost equal to 415,908 superscript base, cm, n base, cubed. Total weight of the pillar, weight equals 415,908 times 7.8. Almost equal to 3,243,080.8 g equals 3,243 kg. Final answer, total volume is equal to 415,908 cubic centimeter. Total weight is equal to 3,243 kilograms. Shape, in line with text. Problem 2. The interior of a building is in the form of a right circular cylinder of diameter 4.2 m and height 3.6 m surmounted by a cone. The total height of the building is 5.4 m. Find the external surface area of the building. Concept and formula. Curved surface area of cylinder, subscript base, CSA, n base, sub-cylinder equals 2 pi rh. Curved surface area of cone, subscript base, CSA, n base, subcone equals PRL, where slant height L is given by equal square root of r squared plus h squared, n square root total surface area of the building, TS equals subscript base, CSA, n base, sub-cylinder plus subscript base, CSA, n base, subcone. Solution, stepwise explanation given. Cylinder diameter is equal to 4.2 m, radius equals 2.1 m. Cylinder height h sub 1 equals 3.6 m. Cone height h sub 2 equals 5.4 minus 3.6 equals 1.8 m. Finding slant height L of the cone. Equal square root of open paren 2.1 close paren squared plus open paren 1.8 close paren squared, n square root, equal square root of 4.41 plus 3.24 n square root equal square root of 7.65. Almost equal to 2.76 m. Curved surface area of cylinder, subscript base, CSA, n base, sub-cylinder equals 2 pi open paren 2.1 close paren open paren 3.6 close paren, equals 15.12 pi. Almost equal to 47.52 superscript base, m, n base, squared. Curved surface area of cone, subscript base, CSA, n base, subcone equals P open paren 2.1 close paren open paren 2.76 close paren, equals 5.796 pi, almost equal to 18.2 superscript base m n base squared. Total surface area of the building TS equals 47.52 plus 18.2 equals 65.72 superscript base m n base squared. Final answer: total external surface area is equal to 65.72 square meters. Shape: in line with text. Final summary of key results. Enter table. 3 by 2. Column header. Row 1 of 3, column 1 of 2. Problem no. Column header. Row 1 of 3, column 2 of 2. Final answer. Row header. Row 2 of 3, column 1 of 2. 1. Row 2 of 3, column 2 of 2. Volume is equal to 415,908 cm. Superscript 3. Weight is equal to 3,243 kilograms. Row header. Row 3 of 3, column 1 of 2. 2. Row 3 of 3, column 2 of 2. Total surface area is equal to 65.72 square meters. Exit table. Shape: in line with text. Problem 3. A circus tent is cylindrical up to a height of 3 m and conical above it. If the diameter of the base is 105 m and the slant height of the conical part is 53 m, find the total canvas required to make the tent. CBSE 2004. Concept and formula. Curved surface area CSA of a cylinder. Subscript base CSA n base subcylinder equals 2 pi rh. Curved surface area CSA of a cone. Subscript base CSA n base subcone equals PRL. Total canvas required. Total canvas equals subscript base CSA n base subcylinder plus subscript base CSA n base subcone. Solution: stepwise explanation. Given base diameter is equal to 105 m, radius equals 52.5 m, cylinder height equals 3 m, slant height of the cone equals 53 m. Curved surface area of cylinder. Subscript base CSA n base subcylinder equals 2 pi open paren 52.5 close paren open paren 3 close paren equals 6 pi open paren 52.5 close paren equals 315 pi, almost equal to 990.63 superscript base m n base squared. Curved surface area of cone. Subscript base CSA n base subcone equals P open paren 52.5 close paren open paren 53 close paren equals 2786.25 pi, almost equal to 8755.83 superscript base m n base squared. Total canvas required 990.63 plus 8755.83 equals 9746.46 superscript base m n base squared. Final answer: the total canvas required is 9746.46 square meters. Shape: in line with text. Problem 4. A right circular cylinder having diameter 12 cm and height 15 cm is half filled with ice cream. The ice cream is then shaped into a cone having the same diameter as the cylinder. Find the height of the ice cream cone. CBSE 2005. Concept and formula. Volume of cylinder. Half filled cap V sub cylinder equals per square red cap V sub ice. Cream equals 1/2 cap V sub cylinder. Volume of cone. Cap V sub cone equals 1/3 per square red cap H. Since the ice cream is transferred completely, cap V sub ice. Cream equals cap V sub cone. Solution. Stepwise explanation. Given. Cylinder diameter is equal to 12 cm, radius equals 6 cm. Cylinder height equals 15 cm. Volume of half-filled cylinder. Cap V sub ice. Cream equals 1/2 p open parent 6 close parent squared open parent 15 close parent. Equals 1/2 p open parent 36 times 15 close parent equals 540 pi over 2. Equals 270 pi. Equating to cone volume. 1/3 p open parent 6 close parent square red cap equals 270 pi. 1/3 p open parent 36 close parent cap equals 270 pi. 12 cap H equals 270. Cap equals 22.5 cm. Final answer. The height of the ice cream cone is 22.5 centimeters. Shape. In line with text. Final summary of key results. Enter table. 3/2. Column header. Row 1 of 3 column 1 of 2. Problem no. Column header. Row 1 of 3 column 2 of 2. Final answer. Row header. Row 2 of 3 column 1 of 2. 3. Row 2 of 3 column 2 of 2. Total canvas required is equal to 9746.46 m. Superscript 2. Row header. Row 3 of 3 column 1 of 2. 4. Row 3 of 3 column 2 of 2. Height of ice cream cone is equal to 22.5 centimeters. Exit table. Shape. In line with text. Problem 5. At a fair. The shape of a large cylindrical glass of ice cream consists of a cylinder and then a conical part. The cylinder has a height of 3 m and a radius of 1.4 m. The slant height of the cone is 1.75 m. Find the total curved surface area of the shape. Also, find the cost of putting a thin silver-like sheet on the surface if the cost is 2 rupees per square meter. CBSE 2005. Concept and formula. Curved surface area of a cylinder. Subscript base. CSA. End base. Subcylinder equals 2 pi RH. Curved surface area of a cone. Subscript base. CSA. End base. Subcone equals PRL. Total surface area. Total CS equals subscript base. CSA. End base. Subcylinder plus subscript base. CSA. End base. Subcone. Cost calculation. Total cost equals total CS Adamash rate. Solution. Stepwise explanation. Given. Cylinder radius equals 1.4 m. Cylinder height equals 3 m. Cone slant height equals 1.75 m. Cost of covering is equal to 2 rupees per square meter. Curved surface area of cylinder. Subscript base. CSA. End base. Subcylinder equals 2 pi open parent 1.4 close parent open parent 3 close parent. Equals 8.4 pi. Almost equal to 26.4 superscript base. M. End base. Squared. Curved surface area of cone. Subscript base. CSA. End base. Subcone equals P open parent 1.4 close parent open parent 1.75 close parent. Equals 2.45 pi. Almost equal to 7.7 superscript base. M. End base. Squared. Total surface area. 26.4 plus 7.7 equals 34.1 superscript base m n base squared. Cost calculation. Total cost equals 34.1 times 2 equals 68.2 rupees. Final answer. Total curved surface area is equal to 34.1 square meters. Total cost is equal to rupee 68.2. Shape. In line with text. Problem 6. A solid hemisphere is placed on a cylinder such that their bases are equal. If the total height of the shape is 20 centimeters, and the radius of the base is 4.2 centimeters, find the total surface area of the solid. CBSE 2012. Concept and formula. Curved surface area of a cylinder. Subscript base. CSA. N base. Subcylinder equals 2 pi RH. Curved surface area of a hemisphere. Subscript base. CSA. N base. Subhemisphere equals 2 pi r squared. Total surface area. Total CS equals subscript base. CSA. N base. Subcylinder plus subscript base. CSA. N base. Subhemisphere. Solution. Stepwise explanation. Given. Base radius equals 4.2 cm. Total height of shape is equal to 20 centimeters. Cylinder height equals 20 minus 4.2 equals 15.8 cm. Curved surface area of cylinder. Subscript base. CSA. N base. Subcylinder equals 2 pi open paren 4.2 close paren open paren 15.8 close paren. Equals 132.48 pi. Almost equal to 416.2 superscript base. cm. N base. Squared. Curved surface area of hemisphere. Subscript base. CSA. N base. Subhemisphere equals 2 pi open paren 4.2 close paren squared. Equals 35.28 pi. Almost equal to 110.8 superscript base. cm. N base. Squared. Total surface area. 416.2 plus 110.8 equals 527 superscript base. cm. N base. Squared. Final answer. Total surface area is equal to 527 square centimeters. Shape. In line with text. Problem 7. A toy is in the shape of a right circular cone mounted on a hemisphere. The radius of the base is 3 centimeters, and the height of the cone is 4 centimeters. Find the total surface area of the toy. Concept and formula. Curved surface area of a cone. Subscript base. CSA. N base. Subcone equals PRL. Curved surface area of a hemisphere. Subscript base. CSA. N base. Subhemisphere equals 2 pi r squared. Total surface area. Total CS equals subscript base. CSA. N base. Subcone plus subscript base. CSA. N base. Subhemisphere. Solution. Stepwise explanation. Given. Radius of base equals 3 cm. Cone height equals 4 cm. Slant height L is calculated using equal square root of r squared plus h squared, n square root equals square root of 3 squared plus 4 squared, n square root equals square root of 9 plus 16 and square root equals square root of 25 equals 5 cm. Curved surface area of cone. Subscript base. CSA. N base. Subcone equals P open paren 3 close paren open paren 5 close paren. Equals 15 pi. almost equal to 47.1 superscript base, cm, n base, squared. Curved surface area of hemisphere, subscript base, CSA, n base, subhemisphere equals 2 pi open parent 3 close parent squared, equals 18 pi, almost equal to 56.5 superscript base, cm, n base, squared. Total surface area, 47.1 plus 56.5 equals 103.6 superscript base, cm, n base, squared. Final answer, total surface area of the toy is equal to 103.6 square centimeters. Shape, in line with text. Final summary of key results. Enter table, 4 by 2, column header, row 1 of 4 column 1 of 2, problem no. Column header, row 1 of 4 column 2 of 2, final answer. Row header, row 2 of 4 column 1 of 2, 5. Row 2 of 4 column 2 of 2, total CSA is equal to 34.1 m. Superscript 2, cost is equal to rupee 68.2. Row header, row 3 of 4 column 1 of 2, 6. Row 3 of 4 column 2 of 2, total surface area is equal to 527 centimeters. Superscript 2, row header, row 4 of 4 column 1 of 2, 7. Row 4 of 4 column 2 of 2, total surface area of the toy is equal to 103.6 square centimeters. Exit table. Shape, in line with text. Problem 8. A cylindrical container with a conical height of 15 centimeters is filled with ice cream. The ice cream is scooped to form 10 hemispherical tops. If the height of the cylindrical part is 45 centimeters and its base radius is 5 centimeters, find the radius of the hemispherical tops. CBSE 2016. Concept and formula. Volume of cone, cap V sub cone equals 1/3 pi squared. Volume of cylinder, cap V sub cylinder equals per squared. Volume of hemisphere, cap V sub hemisphere equals 2/3 per cubed. Equating volumes, volume of ice cream equals volume of 10 hemispheres. Solution, stepwise explanation. Given, cylinder height h sub 1 equals 45 cm. Cone height h sub 2 equals 15 cm. Base radius equals 5 cm. Number of hemispheres is equal to 10. Volume of cone, cap V sub cone equals 1/3 pi open parent 5 close parent squared open parent 15 close parent, equals 1/3 pi open parent 25 times 15 close parent equals 375 pi over 3 equals 125 pi. Volume of cylinder, cap V sub cylinder equals pi open parent 5 close parent squared open parent 45 close parent, equals pi open parent 25 times 45 close parent equals 1125 pi. Total ice cream volume, cap V sub total equals 125 pi plus double 125 pi equals 1250 pi. Volume of 10 hemispheres, 10 times 2/3 per cubed equals 1250 pi. 20/3 per cubed equals 1250 pi. R cubed equals numerator, 1250 times 3 and numerator, over 20 equals 187.5. Equals cube root of 187.5 almost equal to 5.7 cm. Final answer, the radius of the hemispherical tops is 5.7 centimeters. Shape, in line with text. Problem 9. A bucket is in the form of a cylinder with hemispherical ends. The total height of the bucket is 15 centimeters. If the capacity of the bucket is 6,216 cubic centimeters, find the radius of the well. Asterisk. Use equals 3.14. Concept and formula. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of two hemispheres. Cap V sub hemisphere S equals 2 times 2/3 per cubed. Total volume. Cap V sub total equals cap V sub cylinder plus cap V sub hemispheres. Solution. Stepwise explanation. Given. Total height is equal to 15 centimeters. Volume is equal to 6,216 cubic centimeters. Let radius be r and cylinder height be. Equals 15 minus 2r. Volume equation. P squared open parent 15 minus 2r close parent plus 4/3 per cubed equals 6216. After solving, r equals 6 cm. Final answer. The radius of the bucket is 6 centimeters. Shape. In line with text. Problem 10. A solid capsule is in the shape of a cylinder with hemispherical ends. If the height of the entire capsule is 12 centimeters and the radius is 2 centimeters, find its total surface area. Concept and formula. Curved surface area of a cylinder. Subscript base. CSA. End base. Subcylinder equals 2 pi RH. Curved surface area of two hemispheres. Subscript base. CSA. End base. Subhemisphere S equals 2 pi r squared. Total surface area. Total surface area equals subscript base. CSA. End base. Subcylinder plus subscript base. CSA. End base. Subhemispheres. Solution. Stepwise explanation. Given. Total height is equal to 12 centimeters. Radius equals 2 cm. Cylinder height is equal to 12 minus 4 equals 8 cm. Curved surface area of cylinder. Subscript base. CSA. End base. Subcylinder equals 2 pi open parent 2 close parent open parent 8 close parent. Equals 32 pi. Almost equal to 100.48 superscript base. cm. End base. Squared. Curved surface area of hemispheres. Subscript base. CSA. End base. Subhemisphere S equals 2 pi open parent 2 close parent squared. Equals 8 pi. Almost equal to 25.12 superscript base. cm. End base. Squared. Total surface area. 100.48 plus 25.12 equals 125.6 superscript base. cm. End base. Squared. Final answer. The total surface area of the capsule is 125.6 square centimeters. Shape. In line with text. Final summary of key results. Enter table. 4 by 2. Column header. Row 1 of 4 column 1 of 2. Problem no. Column header. Row 1 of 4 column 2 of 2. Final answer. Row header. Row 2 of 4 column 1 of 2. 8. Row 2 of 4 column 2 of 2. Radius of hemispherical tops is equal to 5.7 centimeters. Row header. Row 3 of 4 column 1 of 2. 9. Row 3 of 4 column 2 of 2. Radius of the bucket is equal to 6 centimeters. Row header. Row 4 of 4 column 1 of 2. 10. Row 4 of 4 column 2 of 2. Total surface area of capsule is equal to 125.6 centimeters. Superscript 2. Exit table shape, in line with text. Problem 11. A toy is in the shape of a right circular cylinder with a hemispherical top and a conical bottom. The height of the cylindrical part is 12 centimeters, and the radius is 5 centimeters. The height of the conical part is 12 centimeters. Find the total surface area of the toy. Concept and formula. Curved surface area of a cylinder. Subscript base, CSA, end base, sub-cylinder equals 2 pi RH. Curved surface area of a hemisphere. Subscript base, CSA, end base, sub-hemisphere equals 2 pi R squared. Curved surface area of a cone. Subscript base, CSA, end base, subcone equals PRL. Slant height L of the cone is found using equal square root of R squared plus H squared, end square root. Total surface area. Total surface area equals subscript base, CSA, end base, sub-cylinder plus subscript base, CSA, end base, sub-hemisphere plus subscript base, CSA, end base, subcone. Solution. Stepwise explanation. Given. Cylinder height equals 12 cm. Cone height h sub c equals 12 cm. Radius equals 5 cm. Slant height of the cone. Equal square root of 5 squared plus 12 squared. End square root equals square root of 25 plus 144, end square root equals square root of 169 equals 13 cm. Curved surface area of the cylinder. Subscript base, CSA, end base, sub-cylinder equals 2 pi open paren 5 close paren open paren 12 close paren equals 120 pi. Almost equal to 376.99 superscript base, cm, end base, squared. Curved surface area of the hemisphere. Subscript base, CSA, end base, sub-hemisphere equals 2 pi open paren 5 close paren squared equals 50 pi. Almost equal to 157.08 superscript base, cm, end base, squared. Curved surface area of the cone. Subscript base, CSA, end base, subcone equals p open paren 5 close paren open paren 13 close paren equals 65 pi. Almost equal to 204.2 superscript base, cm, end base, squared. Total surface area. 376.99 plus 157.08 plus 204.2 equals 738.27 superscript base, cm, end base, squared. Final answer. Total surface area of the toy is equal to 738.27 square centimeters. Shape. In line with text. Problem 12. A vessel is in the form of a hemispherical ball inside a cylinder. The height of the cylindrical part is 8 centimeters, and its base radius is 7 centimeters. Find the total capacity of the vessel. Asterisk. Use P equals 22/7. Concept and formula. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Total volume. Cap V sub total equals cap V sub cylinder plus cap V sub hemisphere. Solution. Stepwise explanation. Given. Radius equals 7 cm. Cylinder height equals 8 cm. Volume of cylinder. Cap V sub cylinder equals P open paren 7 close paren squared open paren 8 close paren. equals P open paren 49 times 8 close paren equals 392 pi. Almost equal to 1231.5 superscript base, cm, n base, cubed. Volume of hemisphere, cap V sub hemisphere equals 2/3 P open paren 7 close paren cubed, equals 2/3 P open paren 343 close paren equals 686 over 3 pi. Almost equal to 718.7 superscript base, cm, n base, cubed. Total volume, 1231.5 plus 718.7 equals 1950.2 superscript base, cm, n base, cubed. Final answer. Total capacity of the vessel is equal to 1950.2 cubic centimeters. Shape, in line with text. Problem 13. A solid consists of a cylinder surmounted by a hemisphere. The total height of the solid is 19 centimeters, and its base radius is 7 centimeters. Find the volume of the solid. Concept and formula. Volume of a cylinder, cap V sub cylinder equals per squared. Volume of a hemisphere, cap V sub hemisphere equals 2/3 per cubed. Total volume, cap V sub total equals cap V sub cylinder plus cap V sub hemisphere. Solution. Stepwise explanation. Given, total height is equal to 19 centimeters. Radius equals 7 cm. Cylinder height equals 19 minus 7 equals 12 cm. Volume of cylinder, cap V sub cylinder equals P open paren 7 close paren squared open paren 12 close paren, equals P open paren 49 times 12 close paren equals 588 pi. Almost equal to 1847.5 superscript base, cm, n base, cubed. Volume of hemisphere, cap V sub hemisphere equals 2/3 P open paren 7 close paren cubed, equals 2/3 P open paren 343 close paren equals 686 over 3 pi. Almost equal to 718.7 superscript base, cm, n base, cubed. Total volume, 1847.5 plus 718.7 equals 2566.2 superscript base, cm, n base, cubed. Final answer. Total volume of the solid is equal to 2566.2 cubic centimeters. Shape, in line with text. Final summary of key results. Enter table, 4x2, column header, row 1 of 4 column 1 of 2, problem no. Column header, row 1 of 4 column 2 of 2, final answer. Row header, row 2 of 4 column 1 of 2, 11. Row 2 of 4 column 2 of 2. Total surface area of the toy is equal to 738.27 centimeters. Superscript 2. Row header, row 3 of 4 column 1 of 2, 12. Row 3 of 4 column 2 of 2. Total capacity of the vessel is equal to 1950.2 cubic centimeters. Row header, row 4 of 4 column 1 of 2, 13. Row 4 of 4 column 2 of 2. Total volume of the solid is equal to 2566.2 centimeters. Superscript 3. Exit table shape, in line with text. Problem 14. A gas holder is built in the form of a cylindrical tank with hemispherical ends. The total height of the structure is 35 m. If the cylinder has a radius of 3.5 m and height 20 m, Find the total volume of gas the holder can contain. Concept and formula. Volume of a cylinder, cap V sub cylinder equals per squared. Volume of a hemisphere, cap V sub hemisphere equals 2/3 per cubed. Total volume, cap V sub total equals cap V sub cylinder plus 2 cap V sub hemisphere. Solution. Stepwise explanation. Given. Total height is equal to 35 m. Cylinder height equals 20 m. Radius equals 3.5 m. Volume of cylinder. Cap V sub cylinder equals P open parent 3.5 close parent squared open parent 20 close parent equals P open parent 12.25 times 20 close parent equals 245 pi. Almost equal to 769.69 superscript base m n base cubed. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 P open parent 3.5 close parent cubed equals 2/3 P open parent 42.875 close parent equals 85.75 over 3 pi. Almost equal to 89.92 superscript base m n base cubed. Total volume 769.69 plus 2 open parent 89.92 close parent equals 949.53 superscript base m n base cubed. Final answer. Total gas capacity is equal to 949.53 cubic meters. Shape. In line with text. Problem 15. A toy is in the shape of a hemisphere mounted on a right circular cone. Height of the cone is 4 centimeters, and the base radius is 2 centimeters. Find the total volume of the toy. Concept and formula. Volume of a cone, cap V sub cone equals 1/3 P squared. Volume of a hemisphere, cap V sub hemisphere equals 2/3 per cubed. Total volume, cap V sub total equals cap V sub cone plus cap V sub hemisphere. Solution. Stepwise explanation. Given. Cone height equals 4 cm. Radius equals 2 cm. Volume of cone. Cap V sub cone equals 1/3 P open parent 2 close parent squared open parent 4 close parent equals 1/3 P open parent 16 close parent equals 16/3 P. Almost equal to 16.76 superscript base cm n base cubed. Volume of hemisphere. Cap V sub hemisphere equals 2/3 P open parent 2 close parent cubed equals 2/3 P open parent 8 close parent equals 16/3 P. Almost equal to 16.76 superscript base cm n base cubed. Total volume 16.76 plus 16.76 equals 33.52 superscript base cm n base cubed. Final answer. Total volume of the toy is equal to 33.52 cubic centimeters. Shape. In line with text. Problem 16. A solid cylinder is 10 centimeters high and 6 centimeters in diameter. A conical hole is drilled in the cylinder to half of its height. The radius of the cone's base is half the cylinder's base. Find the volume of the remaining solid. Asterisk. Use P equals 3.14. Concept and formula. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a cone. Cap V sub cone equals 1/3 P squared. Remaining volume. Cap V sub remaining equals cap V sub cylinder minus cap V sub cone. Solution. Stepwise explanation. Given. Cylinder height equals 10 cm. Cylinder radius equals 3 cm. Cone height h sub c equals 10 halves equals 5 cm. Cone radius r sub c equals 3 halves equals 1.5 cm. Volume of cylinder. Cap V sub cylinder equals P open parent 3 close parent squared open parent 10 close parent equals 90 pi. Almost equal to 282.6 superscript base cm n base cubed. Volume of cone. Cap V sub cone equals 1/3 P open parent 1.5 close parent squared open parent 5 close parent equals 1/3 P open parent 2.25 times 5 close parent equals 11.25 over 3 pi. Almost equal to 11.8 superscript base cm n base cubed. Remaining volume. 282.6 minus 11.8 equals 270.8 superscript base cm n base cubed. Final answer. Volume of the remaining solid is equal to 270.8 cubic centimeters. Shape. In line with text. Final summary of key results. Enter table. 4 by 2. Column header. Row 1 of 4 column 1 of 2. Problem no. Column header. Row 1 of 4 column 2 of 2. Final answer. Row header. Row 2 of 4 column 1 of 2. 14. Row 2 of 4 column 2 of 2. Total gas capacity is equal to 949.53 m. Superscript 3. Row header. Row 3 of 4 column 1 of 2. 15. Row 3 of 4 column 2 of 2. Total volume of the toy is equal to 33.52 cubic centimeters. Row header. Row 4 of 4 column 1 of 2. 16. Row 4 of 4 column 2 of 2. Volume of the remaining solid is equal to 270.8 centimeters. Superscript 3. Exit table shape. In line with text. Problem 17. A hollow sphere is made by carving out a hemisphere from one end of a solid sphere. The radius of the original sphere is 7 centimeters. Find the total surface area of the resulting structure. CBSE 2015. Insert exemplar. Concept and formula. Surface area of a sphere. Cap S subsphere equals 4 pi r squared. Curved surface area of a hemisphere. The inner carved out portion cap S subhemisphere equals 2 pi r squared. Total surface area. Cap S subtotal equals cap S subsphere plus cap S subhemisphere. Solution. Stepwise explanation. Given. Radius of sphere equals 7 cm. Surface area of sphere. Cap S subsphere equals 4 pi open parent 7 close parent squared. Equals 4 pi open parent 49 close parent equals 196 pi. Almost equal to 616 superscript base cm n base squared. Curved surface area of hemisphere. Cap S subhemisphere equals 2 pi open parent 7 close parent squared. Equals 2 pi open parent 49 close parent equals 98 pi. Almost equal to 308 superscript base cm n base squared. Total surface area. 616 plus 308 equals 924 superscript base cm n base squared. Final answer. Total surface area of the hollow sphere is equal to 924 square centimeters. Shape. In line with text. Problem 18. A tent is in the shape of a cylinder surmounted by a conical top. The height and diameter of the cylindrical part are 2.1 m and 4.2 m. and the slant height of the cone is 2.8 m. Find the total area of canvas required for the tent. Concept and formula. Curved surface area of a cylinder. Cap S sub cylinder equals 2 pi rh. Curved surface area of a cone. Cap S sub cone equals PRL. Total surface area. Cap S sub total equals cap S sub cylinder plus cap S sub cone. Solution. Stepwise explanation. Given. Cylinder radius equals 4.2 over 2 equals 2.1 m. Cylinder height equals 2.1 m. Slant height of cone equals 2.8 m. Curved surface area of cylinder. Cap S sub cylinder equals 2 pi open paren 2.1 close paren open paren 2.1 close paren. Equals 8.82 pi. Almost equal to 27.7 superscript base, m, n base, squared. Curved surface area of cone. Cap S sub cone equals P open paren 2.1 close paren open paren 2.8 close paren. Equals 5.88 pi. Almost equal to 18.5 superscript base, m, n base, squared. Total area of canvas required. 27.7 plus 18.5 equals 46.2 superscript base, m, n base, squared. Final answer. Total canvas required is equal to 46.2 square meters. Shape. In line with text. Problem 19. From a solid right circular cylinder of height 10 cm and base radius 6 cm, a conical cavity of the same base and height is hollowed out. Find the total surface area of the remaining solid. Insert. CBSE 2017. Concept and formula. Curved surface area of a cylinder. Cap S sub cylinder equals 2 pi rh. Curved surface area of a cone. Cap S sub cone equals PRL. Base area of cylinder and cone. Cap S sub bus equals per squared. Total surface area. Cap S sub total equals cap S sub cylinder plus cap S sub cone plus cap S sub base. Solution. Stepwise explanation. Given. Cylinder height equals 10 cm. Cylinder radius equals 6 cm. Cone height equals 10 cm. Slant height of cone equals square root of 6 squared plus 10 squared. N square root equals square root of 36 plus 100 and square root equals square root of 136 almost equal to 11.7 cm. Curved surface area of cylinder. Cap S sub cylinder equals 2 pi open paren 6 close paren open paren 10 close paren equals 120 pi. Almost equal to 376.8 superscript base, cm, n base, squared. Curved surface area of cone. Cap S sub cone equals P open paren 6 close paren open paren 11.7 close paren equals 70.2 pi. Almost equal to 220.5 superscript base, cm, n base, squared. Base area. Cap S sub bus equals P open paren 6 close paren squared equals 36 pi. Almost equal to 13.1 superscript base, cm, n base, squared. Total surface area. 376.8 plus 220.5 plus 113.1 equals 710.4 superscript base, cm, n base, squared. Final answer. Total surface area of the remaining solid is equal to 710.4 square centimeters. Shape. In line with text. Problem 20. A conical vessel is surmounted on a cylindrical base of the same radius. The total height of the structure is 18 centimeters, and the base radius is 6 centimeters. If the conical height is 9 centimeters, find the total surface area of the structure. Concept and formula. Curved surface area of a cylinder, cap S sub cylinder equals 2 pi rh. Curved surface area of a cone, cap S sub cone equals PRL. Base area of cylinder, cap S sub bus equals per squared. Total surface area, cap S sub total equals cap S sub cylinder plus cap S sub cone plus cap S sub base. Solution. Stepwise explanation. Given. Cylinder height equals 18 minus 9 equals 9 cm. Radius equals 6 cm. Cone height h sub c equals 9 cm. Slant height of cone. Equals square root of 6 squared plus 9 squared. And square root equals square root of 36 plus 81 and square root equals square root of 117 almost equal to 10.8 cm. Curved surface area of cylinder, cap S sub cylinder equals 2 pi open paren 6 close paren open paren 9 close paren equals 108 pi. Curved surface area of cone, cap S sub cone equals P open paren 6 close paren open paren 10.8 close paren equals 64.8 pi. Total surface area, 108 pi plus 64.8 pi plus 36 pi equals 208.8 pi. Almost equal to 656.4 superscript base, cm, n base, squared. Final answer. Total surface area of the structure is equal to 656.4 centimeters. Problem 21. A rocket is in the form of a cylinder of radius 1.5 centimeters and height 5 centimeters. Surmounted by two conical parts each of height 2 centimeters and base radius 1.5 centimeters. Find the total volume of the rocket. Insert exemplar. Concept and formula. Volume of a cylinder, cap V sub cylinder equals per squared. Volume of a cone, cap V sub cone equals 1/3 pi squared. Total volume, cap V sub total equals cap V sub cylinder plus 2 cap V sub cone. Solution. Stepwise explanation. Given. Cylinder radius equals 1.5 cm. Cylinder height h sub cylinder equals 5 cm. Cone height h sub cone equals 2 cm. Cone base radius equals 1.5 cm. Same as cylinder. Volume of cylinder, cap V sub cylinder equals P open paren 1.5 close paren squared open paren 5 close paren equals P open paren 2.25 times 5 close paren equals 11.25 pi. Almost equal to 35.34 superscript base, cm, n base, cubed. Volume of one cone, cap V sub cone equals 1/3 P open paren 1.5 close paren squared open paren 2 close paren equals 1/3 P open paren 2.25 times 2 close paren equals 1.5 pi. Almost equal to 4.71 superscript base, cm, n base, cubed. Total volume of two cones. 2 times 4.71 equals 9.42 superscript base, cm, n base, cubed. Total volume of rocket, 35.34 plus 9.42 equals 44.76 superscript base, cm, n base, cubed. Final answer. Total volume of the rocket is equal to 44.76 cubic centimeters. Shape, in line with text. Problem 22. A gulab jamun when completely ready contains sugar syrup up to about 30% of its volume. If a gulab jamun has a radius of 1.4 centimeters and length of the cylindrical portion as 7 centimeters, find the volume of sugar syrup in 6 such gulab jamuns. Insert exemplar. CBSE 2017. Concept and formula. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Volume of a cylinder. Cap V sub cylinder equals per squared. Total volume of one gulab jamun. Cap V sub total equals 2 cap V sub hemisphere A plus cap V sub cylinder. Volume of sugar syrup. Cap V sub syrup equals 30% times 6 cap V sub total. Solution. Stepwise explanation. Given. Cylinder radius equals 1.4 cm. Cylinder height equals 7 cm. Each gulab jamun has 2 hemispherical ends. Volume of one hemisphere. Cap V sub hemisphere equals 2/3 p open parent 1.4 close parent cubed. Equals 2/3 p open parent 2.74 close parent equals 1.83 pi. Almost equal to 5.75 superscript base, cm, n base, cubed. Total volume of 2 hemispheres. 2 times 5.75 equals 11.5 superscript base, cm, n base, cubed. Volume of cylinder. Cap V sub cylinder equals p open parent 1.4 close parent squared open parent 7 close parent. Equals p open parent 1.96 times 7 close parent equals 13.72 pi. Almost equal to 43.1 superscript base, cm, n base, cubed. Total volume of one gulab jamun. 11.5 plus 43.1 equals 54.6 superscript base, cm, n base, cubed. Total volume of 6 gulab jamuns. 6 times 54.6 equals 327.6 superscript base, cm, n base, cubed. Volume of sugar syrup. Cap V sub syrup equals 30% times 327.6. Equals 30 over 100 times 327.6 equals 98.28 superscript base, cm, n base, cubed. Final answer. Volume of sugar syrup in 6 gulab jamuns is equal to 98.28 cubic centimeters. Shape. In line with text. Final summary of key results. Enter table. 3 by 2. Column header. Row 1 of 3 column 1 of 2. Problem no. Column header. Row 1 of 3 column 2 of 2. Final answer. Row header. Row 2 of 3 column 1 of 2. 21. Row 2 of 3 column 2 of 2. Total volume of the rocket is equal to 44.76 centimeters. Superscript 3. Row header. Row 3 of 3 column 1 of 2. 22. Row 3 of 3 column 2 of 2. Volume of sugar syrup in 6 gulab jamuns is equal to 98.28 centimeters. Superscript 3. Exit table. Problem 23. A metal ice cream cone is formed by joining a cone and a spherical base. The cone has a radius of 5 centimeters and height 8 centimeters. The spherical base has a radius of 5 centimeters. Find the total volume of the ice cream cone. Insert exemplar. Concept and formula. Volume of a cone. Cap V sub cone equals 1/3 pi squared. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Total volume. cap v sub total equals cap v sub cone plus cap v sub hemisphere. Solution. Stepwise explanation. Given. Cone radius equals 5 cm. Cone height equals 8 cm. Hemisphere radius equals 5 cm. Volume of cone. Cap v sub cone equals 1/3 p open paren 5 close paren squared open paren 8 close paren equals 1/3 p open paren 25 times 8 close paren equals 200 over 3 pi. Almost equal to 209.44 superscript base cm n base cubed. Volume of hemisphere. Cap v sub hemisphere equals 2/3 p open paren 5 close paren cubed equals 2/3 p open paren 125 close paren equals 250 over 3 pi. Almost equal to 261.8 superscript base cm n base cubed. Total volume. 209.44 plus 261.8 equals 471.24 superscript base cm n base cubed. Final answer. Total volume of the ice cream cone is equal to 471.24 cubic centimeters. Shape. In line with text. Problem 24. A spherical ball of radius 10 cm is melted and drawn into a wire of uniform cross-section. If the wire has a radius of 1 cm, find its length. Concept and formula. Volume of a sphere. Cap v sub sphere equals 4/3 per cubed. Volume of a cylinder. Wire cap v sub cylinder equals per squared. Since the material is conserved, cap v sub sphere equals cap v sub cylinder. Solution. Stepwise explanation. Given. Sphere radius equals 10 cm. Wire radius equals 1 cm. Wire height h. To be determined. Volume of sphere. Cap v sub sphere equals 4/3 p open paren 10 close paren cubed. Equals 4/3 p open paren 1000 close paren equals 4000 over 3 pi. Almost equal to 4188.8 superscript base cm n base cubed. Volume of cylinder. Wire. Cap v sub cylinder equals p open paren 1 close paren squared equals ph. Equating volumes. Pi h equals 4000 over 3 pi. Equals 4000 over 3 equals 1333.33 cm. Final answer. Length of the wire is equal to 1333.33 centimeters, or 13.33 m. Shape. In line with text. Problem 25. A solid is in the form of a cylinder surmounted by a hemisphere. The height of the entire solid is 18 centimeters, and the radius of the base is 7 centimeters. Find the volume of the solid. Concept and formula. Volume of a cylinder. Cap v sub cylinder equals per squared. Volume of a hemisphere. Cap v sub hemisphere equals 2/3 per cubed. Total volume. Cap v sub total equals cap v sub cylinder plus cap v sub hemisphere. Solution. Stepwise explanation. Given. Cylinder height equals 18 minus 7 equals 11 cm. Radius equals 7 cm. Volume of cylinder. Cap v sub cylinder equals p open paren 7 close paren squared open paren 11 close paren equals p open paren 49 times 11 close paren equals 539 pi. Almost equal to 1693.9 superscript base cm n base cubed. Volume of hemisphere. Cap v sub hemisphere equals 2/3 p open paren 7 close paren cubed equals 2/3 p open paren 3/4 close paren equals 686 over 3 pi, almost equal to 718.7 superscript base, cm, n base, cubed. Total volume, 1693.9 plus 718.7 equals 2412.6 superscript base, cm, n base, cubed. Final answer, total volume of the solid is equal to 2412.6 cubic centimeters. Shape, in line with text. Problem 26. A cylindrical container of radius 7 cm and height 15 cm is completely filled with milk. The milk is poured into small cylindrical glasses of radius 3.5 cm and height 5 cm. Find the number of glasses that can be completely filled. Concept and formula. Volume of a cylinder, cap V sub cylinder equals per squared. Number of glasses equals volume of large cylinder over volume of small cylinder. Solution, stepwise explanation, given. Large cylinder, radius equals 7 cm, height equals 15 cm. Small glass, radius equals 3.5 cm, height equals 5 cm. Volume of large cylinder, cap V sub large equals p open paren 7 close paren squared open paren 15 close paren, equals p open paren 49 times 15 close paren equals 735 pi, almost equal to 2309.6 superscript base, cm, n base, cubed. Volume of small glass, cap V sub small equals p open paren 3.5 close paren squared open paren 5 close paren, equals p open paren 12.25 times 5 close paren equals 61.25 pi, almost equal to 192.2 superscript base, cm, n base, cubed. Number of glasses, 2309.6 over 192.2 equals 12. Final answer, number of glasses that can be completely filled is equal to 12. Shape, in line with text. Final summary of key results. Enter table, 5 by 2, column header, row 1 of 5 column 1 of 2, problem no. Column header, row 1 of 5 column 2 of 2, final answer. Row header, row 2 of 5 column 1 of 2, 23. Row 2 of 5 column 2 of 2, total volume of ice cream cone is equal to 471.24 cubic centimeters. Row header, row 3 of 5 column 1 of 2, 24. Row 3 of 5 column 2 of 2, length of the wire is equal to 1333.33 centimeters, or 13.33 m. Row header, row 4 of 5 column 1 of 2, 25. Row 4 of 5 column 2 of 2, total volume of the solid is equal to 2412.6 centimeters. Superscript 3. Row header, row 5 of 5 column 1 of 2, 26. Row 5 of 5 column 2 of 2, number of glasses is equal to 12. Exit table. Shape, in line with text. Problem 27. A solid is in the form of a hemisphere surmounted by a conical cap. If the height of the conical portion is equal to the radius of the hemisphere, find the total volume of the solid. Insert exemplar. Concept and formula. Volume of a cone, cap V sub cone equals 1/3 p squared. Volume of a hemisphere, cap V sub hemisphere equals 2/3 per cubed. Total volume, cap V sub total equals cap V sub cone plus cap V sub hemisphere. Solution, stepwise explanation, given. Radius of hemisphere r, height of cone equals r, volume of cone, cap V sub cone equals 1/3 pi squared equals 1/3 pi cubed. Volume of hemisphere, cap V sub hemisphere equals 2/3 per cubed. Total volume, cap V sub total equals 1/3 pi cubed plus 2/3 per cubed, equals 3/3 per cubed equals per cubed. Final answer, total volume of the solid is equal to pi cubed. Shape, in line with text. Problem 28. A right circular cylinder is surmounted by a hemisphere. If the radius of the hemisphere is 7 cm and the total height of the solid is 21 cm, find the total surface area of the solid. Insert CBSE 2016. Concept and formula. Curved surface area of a cylinder, cap S sub cylinder equals 2 pi RH. Curved surface area of a hemisphere, cap S sub hemisphere equals 2 pi r squared. Total surface area, cap S sub total equals cap S sub cylinder plus cap S sub hemisphere plus cap S sub base. Solution, stepwise explanation, given. Radius of hemisphere equals 7 cm. Total height cap equals 21 cm. Cylinder height equals 21 minus 7 equals 14 cm. Curved surface area of cylinder, cap S sub cylinder equals 2 pi open paren 7 close paren open paren 14 close paren, equals 196 pi. Almost equal to 615.75 superscript base, cm, n base, squared. Curved surface area of hemisphere, cap S sub hemisphere equals 2 pi open paren 7 close paren squared, equals 98 pi. Almost equal to 307.88 superscript base, cm, n base, squared. Base area, cap S sub bus equals p open paren 7 close paren squared equals 49 pi. Almost equal to 153.94 superscript base, cm, n base, squared. Total surface area, 615.75 plus 307.88 plus 153.94 equals 1077.57 superscript base, cm, n base, squared. Final answer, total surface area is equal to 1077.57 square centimeters. Shape, in line with text. Problem 29. A hemispherical ball is placed over a cuboidal box such that their bases are equal. If the radius of the hemisphere is 10 cm and the height of the cuboid is 6 cm, find the total surface area of the solid. CBSE 2014. Insert exemplar. Concept and formula. Surface area of a hemisphere, cap S sub hemisphere equals 2 pi r squared. Surface area of a cuboid, excluding base cap S sub cuboid equals 2 open parental h plus h close paren. Total surface area, cap S sub total equals cap S sub hemisphere plus cap S sub cuboid. Solution, stepwise explanation, given. Radius of hemisphere equals 10 cm. Height of cuboid equals 6 cm. Base dimensions equals 20 cm. Since 2r equals 20. Surface area of hemisphere, cap S sub hemisphere equals 2 pi open paren 10 close paren squared, equals 200 pi. almost equal to 628.32 superscript base, cm, n base, squared. Surface area of cuboid, excluding base. Cap S sub cuboid equals 2 open paren 20 times 6 plus 20 times 6 close paren equals 2 open paren 120 plus 120 close paren equals 480. Total surface area 628.32 plus 480 equals 108.32 superscript base, cm, n base, squared. Final answer, total surface area is equal to 1108.32 square centimeters. Shape, in line with text. Problem 30. A solid consists of a hemisphere surmounted by a right circular cone. If the radius of both the hemisphere and the cone is 10 centimeters and the slant height of the cone is 13 centimeters, find the total surface area of the solid. Concept and formula. Curved surface area of a cone. Cap S sub cone equals PRL. Curved surface area of a hemisphere. Cap S sub hemisphere equals 2 pi r squared. Total surface area. Cap S sub total equals cap S sub cone plus cap S sub hemisphere. Solution. Stepwise explanation. Given. Radius of hemisphere equals 10 cm. Slant height of cone equals 13 cm. Curved surface area of cone. Cap S sub cone equals P open paren 10 close paren open paren 13 close paren equals 130 pi. Almost equal to 408.41 superscript base, cm, n base, squared. Curved surface area of hemisphere. Cap S sub hemisphere equals 2 pi open paren 10 close paren squared equals 200 pi. Almost equal to 628.32 superscript base, cm, n base, squared. Total surface area, 408.41 plus 628.32 equals 1036.73 superscript base, cm, n base, squared. Final answer. Total surface area is equal to 1036.73 square centimeters. Shape, in line with text. Final summary of key results. Enter table, 5 by 2, column header, row 1 of 5 column 1 of 2, problem no. Column header, row 1 of 5 column 2 of 2, final answer. Row header, row 2 of 5 column 1 of 2, 27. Row 2 of 5 column 2 of 2, total volume is equal to P cubed. Row header, row 3 of 5 column 1 of 2, 28. Row 3 of 5 column 2 of 2, total surface area is equal to 1077.57 centimeters. Superscript 2. Row header, row 4 of 5 column 1 of 2, 29. Row 4 of 5 column 2 of 2, total surface area is equal to 1108.32 square centimeters. Row header, row 5 of 5 column 1 of 2, 30. Row 5 of 5 column 2 of 2, total surface area is equal to 1036.73 centimeters. Superscript 2. Exit table. Problem 31. A solid is in the shape of a right circular cylinder with hemispherical ends. The total height of the solid is 20 centimeters, and the diameter of the hemisphere is 7 centimeters. Find the total surface area of the solid. Insert exemplar. Concept and formula. Curved surface area of a cylinder. Cap S sub cylinder equals 2 pi rh. Curved surface area of a hemisphere. cap S sub hemisphere equals 2 pi r squared. Total surface area, cap S sub total equals cap S sub cylinder plus 2 cap S sub hemisphere. Solution, stepwise explanation, given. Total height of solid cap equals 20 cm. Diameter of hemisphere equals 7 cm. Radius of hemisphere equals 7 halves equals 3.5 cm. Cylinder height equals 20 minus 2 open paren 3.5 close paren equals 13 centimeters. Curved surface area of cylinder, cap S sub cylinder equals 2 pi open paren 3.5 close paren open paren 13 close paren equals 91 pi, almost equal to 285.6 superscript base cm n base squared. Curved surface area of two hemispheres, 2 cap S sub hemisphere equals 2 open paren 2 pi open paren 3.5 close paren squared close paren equals 49 pi, almost equal to 153.94 superscript base cm n base squared. Total surface area, 285.6 plus 153.94 equals 439.54 superscript base cm n base squared. Final answer, total surface area is equal to 439.54 square centimeters. Shape, in line with text. Problem 32. A cylindrical bucket of diameter 28 centimeters and height 72 centimeters is full of water. It is emptied into a rectangular tank of length 66 centimeters and breadth 28 centimeters. Find the height to which the water level will rise in the tank. Concept and formula. Volume of a cylinder, bucket cap V sub cylinder equals per squared. Volume of a rectangular tank, cap V sub tank equals to. Since the water is transferred, cap V sub cylinder equals cap V sub tank. Solution, stepwise explanation, given. Bucket radius equals 28 halves equals 14 cm. Bucket height equals 72 cm. Tank dimensions equals 66 cm. B equals 28 cm. Water height in tank cap H, to be determined. Volume of cylinder, bucket, cap V sub cylinder equals P open paren 14 close paren squared open paren 72 close paren equals 14112 pi, almost equal to 44291.2 superscript base cm n base cubed. Volume of water in tank, 44291.2 equals 66 times 2a times cap H. Solving for cap H, cap equals 44291.2 over 1848 almost equal to 23.96 cm. Final answer, water level rises in the tank by 23.96 centimeters. Shape, in line with text. Problem 33. A toy is in the shape of a hemisphere mounted on a cylinder. The radius is 3.5 centimeters. The height of the cylinder is 7 centimeters. Find the volume of the toy. Concept and formula. Volume of a cylinder, cap V sub cylinder equals per squared. Volume of a hemisphere, cap V sub hemisphere equals 2/3 per cubed. Total volume, cap V sub total equals cap V sub cylinder plus cap V sub hemisphere. Solution, stepwise explanation, given. Radius equals 3.5 cm. Cylinder height equals 7 cm. Volume of cylinder, cap V sub cylinder equals P open paren 3.5 close paren squared open paren 7 close paren equals 85.75 pi. almost equal to 269.34 superscript base, cm, n base, cubed. Volume of hemisphere. Cap V sub hemisphere equals 2/3 p open parent 3.5 close parent cubed. Equals 2/3 p open parent 42.875 close parent equals 28.58 pi. Almost equal to 89.83 superscript base, cm, n base, cubed. Total volume. 269.34 plus 89.83 equals 359.17 superscript base, cm, n base, cubed. Final answer. Total volume of the toy is equal to 359.17 cubic centimeters. Shape. In line with text. Problem 34. A cone is divided into two portions by drawing a plane through the midpoint of its axis parallel to the base. Find the ratio of the volumes of the two portions. Concept and formula. Volume of a cone. Cap V sub cone equals 1/3 pi squared. Since the plane cuts the cone at the midpoint of its height, the top portion forms a smaller cone similar to the original one. Height of small cone h sub s equals 1/2. Radius of small cone r sub s equals 1/2. Volume of small cone. Cap V sub small equals 1/3 p open parent r over 2. Close parent squared open parent h over 2. Close parent. Ratio of volumes. Cap V sub small over cap V sub large equals open parent 1/2. Close parent cubed equals 1/8. The remaining volume. Cap V sub large minus cap V sub small equals 7/8 cap V sub large. Ratio of large portion to small portion. 7/8. 1/8 equals 7. 1. Final answer. Ratio of volumes of the two portions is equal to 7. 1. Shape. In line with text. Final summary of key results. Enter table. 5/2. Column header. Row 1 of 5 column 1 of 2. Problem no. Column header. Row 1 of 5 column 2 of 2. Final answer. Row header. Row 2 of 5 column 1 of 2. 31. Row 2 of 5 column 2 of 2. Total surface area is equal to 439.54 centimeters. Superscript 2. Row header. Row 3 of 5 column 1 of 2. 32. Row 3 of 5 column 2 of 2. Water level rises by 23.96 centimeters. Row header. Row 4 of 5 column 1 of 2. 33. Row 4 of 5 column 2 of 2. Total volume of the toy is equal to 359.17 centimeters. Superscript 3. Row header. Row 5 of 5 column 1 of 2. 34. Row 5 of 5 column 2 of 2. Ratio of volumes is equal to 7. 1. Exit table. Shape. In line with text. Problem 35. The interior of a building is in the shape of a right circular cylinder of diameter 4.2 m and height 3.6 m surmounted by a cone. The height of the conical part is 2.1 m. Find the total volume of the air inside the building. Concept and formula. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a cone. Cap V sub cone equals 1/3 pi squared. Total volume. Cap V sub total equals cap V sub cylinder plus cap V sub cone. Solution. Stepwise explanation. Given. Cylinder diameter is equal to 4.2 m. Radius equals 4.2 over 2 equals 2.1 m. Cylinder height equals 3.6 m. Cone height h sub c equals 2.1 m. Volume of cylinder. Cap V sub cylinder equals P open paren 2.1 close paren squared open paren 3.6 close paren equals P open paren 4.41 times 3.6 close paren equals 15.876 pi. Almost equal to 49.86 superscript base m n base cubed. Volume of cone. Cap V sub cone equals 1/3 P open paren 2.1 close paren squared open paren 2.1 close paren equals 1/3 P open paren 4.41 times 2.1 close paren equals 3.087 pi. Almost equal to 9.7 superscript base m n base cubed. Total volume 49.86 plus 9.7 equals 59.56 superscript base m n base cubed. Final answer. Total volume of air inside the building is equal to 59.56 cubic meters. Shape. In line with text. Problem 36. The base of a right circular cylinder is 4 cm and its height is 6 cm. A conical hole is cut out from the cylinder in such a way that the height of the cone is equal to the height of the cylinder. Find the volume of the remaining solid. Concept and formula. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a cone. Cap V sub cone equals 1/3 P squared. Remaining volume. Cap V sub remaining equals Cap V sub cylinder minus Cap V sub cone. Solution. Stepwise explanation. Given. Cylinder radius equals 4 cm. Cylinder height equals 6 cm. Cone height h sub c equals 6 cm. Volume of cylinder. Cap V sub cylinder equals P open paren 4 close paren squared open paren 6 close paren equals P open paren 16 times 6 close paren equals 96 pi. Almost equal to 301.59 superscript base cm n base cubed. Volume of cone. Cap V sub cone equals 1/3 P open paren 4 close paren squared open paren 6 close paren equals 1/3 open paren 96 pi close paren equals 32 pi. Almost equal to 100.53 superscript base cm n base cubed. Remaining volume. 301.59 minus 100.53 equals 201.06 superscript base cm n base cubed. Final answer. Volume of the remaining solid is equal to 201.06 cubic centimeters. Shape. In line with text. Problem 37. A toy is in the form of a cone mounted on a hemisphere. The height of the toy is 14 centimeters, and the radius of its base is 3 centimeters. Find the total surface area of the toy. Concept and formula. Curved surface area of a cone. Cap S sub cone equals PRL. Curved surface area of a hemisphere. Cap S sub hemisphere equals 2 pi r squared. Total surface area. Cap S sub total equals Cap S sub cone plus Cap S sub hemisphere. Solution. Stepwise explanation. Given. Toy height cap equals 14 cm. Radius equals 3 cm. Height of cone equals 14 minus 3 equals 11 cm. Slant height of cone. Equals square root of r squared plus h squared, and square root equals square root of 3 squared plus 11 squared, and square root equals square root of 9 plus 121 and square root equals square root of 130 almost equal to 11.4 cm. Curved surface area of cone. Cap S subcone equals P open paren 3 close paren open paren 11.4 close paren equals 34.2 pi. Almost equal to 107.44 superscript base cm n base squared. Curved surface area of hemisphere. Cap S sub hemisphere equals 2 pi open paren 3 close paren squared equals 18 pi. Almost equal to 56.52 superscript base cm n base squared. Total surface area 107.44 plus 56.52 equals 163.96 superscript base cm n base squared. Final answer. Total surface area of the toy is equal to 163.96 square centimeters. Shape in line with text. Final summary of key results. Enter table 4 by 2, column header, row 1 of 4 column 1 of 2, problem no. Column header, row 1 of 4 column 2 of 2, final answer. Row header, row 2 of 4 column 1 of 2, 35. Row 2 of 4 column 2 of 2. Total volume of air inside the building is equal to 59.56 m. Superscript 3. Row header, row 3 of 4 column 1 of 2, 36. Row 3 of 4 column 2 of 2. Volume of the remaining solid is equal to 201.06 centimeters. Superscript 3. Row header, row 4 of 4 column 1 of 2, 37. Row 4 of 4 column 2 of 2. Total surface area of the toy is equal to 163.96 square centimeters. Exit table. Shape in line with text. Problem 38. A solid right circular cone has height 24 centimeters and slant height 25 centimeters. It contains two other cones that are similar to it with their heights in the ratio 4, 6, 8 respectively. Find the ratio of the total surface areas of these three cones. Concept and formula. Slant height of a cone equals square root of r squared plus h squared n square root. Surface area of a cone caps equals PRL. Since the cones are similar, their linear dimensions are proportional. If heights are in the ratio 4, 6, 8, then radii and slant heights will also be in the same ratio. Solution. Stepwise explanation. Given height of the largest cone equals 24 cm. Slant height of the largest cone equals 25 cm. Heights of three cones are in the ratio 4, 6, 8. Let the common ratio be k. Then, heights of cones 4k, 6k, 8k. Since they are similar, the radii and slant heights are also in the same ratio. Finding ratio of surface areas. Surface area of a cone is proportional to r squared. Since radii are in the ratio 4, 6, 8. The surface areas are in the ratio open paren 4k close paren squared, open paren 6k close paren squared, open paren 8k close paren squared 16k squared, 36k squared, 64k squared. Final answer. Ratio of total surface areas is equal to 16, 36, 64. Shape in line with text. Problem 39. A cylindrical vessel of internal diameter 21 cm and height 20 cm is full of water. A metallic sphere of diameter 7 cm is dropped into the vessel, and it is completely submerged. Find the rise in the water level in the cylindrical vessel. Concept and formula. Volume of a sphere. Cap V subsphere equals 4/3 per cubed. Volume of a cylinder. Cap V subcylinder equals per squared. Since the sphere is submerged, the water it displaces equals the volume of the sphere. Cap V subcylinder equals cap V subsphere. Solution. Stepwise explanation. Given. Cylinder diameter is equal to 21 cm. Radius equals 21 halves equals 10.5 cm. Cylinder height equals 20 cm. Sphere diameter is equal to 7 cm. Radius equals 7 halves equals 3.5 cm. Volume of sphere. Cap V subsphere equals 4/3 p open parent 3.5 close parent cubed equals 4/3 p open parent 42.875 close parent equals 57.17 pi. Almost equal to 179.6 superscript base cm n base cubed. Rise in water level h. Pi open parent 10.5 close parent squared equals 179.6. 110.25 pi h equals 179.6. Equals 179.6 over 110.25 pi. Almost equal to 0.52 cm. Final answer. Rise in water level is equal to 0.52 centimeters. Shape. In line with text. Problem 40. A hemispherical ball of diameter 28 centimeters is full of water. The water is poured into a cylindrical vessel with diameter 14 centimeters. Find the height to which the water level rises in the cylindrical vessel. Concept and formula. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Volume of a cylinder. Cap V sub cylinder equals per squared. Since the water is transferred, their volumes are equal. Cap V sub hemisphere equals cap V sub cylinder. Solution. Stepwise explanation. Given. Hemisphere diameter is equal to 28 cm. Radius equals 28 halves equals 14 cm. Cylinder diameter is equal to 14 cm. Radius equals 14 halves equals 7 cm. Height h to be determined. Volume of hemisphere. Cap V sub hemisphere equals 2/3 p open parent 14 close parent cubed. Equals 2/3 p open parent 2744 close parent equals 5488 over 3 pi. Almost equal to 5755.5 superscript base cm n base cubed. Volume of cylinder. Pi open parent 7 close parent squared equals 5755.5. 49 pi h equals 5755.5. Equals 5755.5 over 49 pi. Almost equal to 37.4 cm. Final answer. Water level rises in the cylindrical vessel by 37.4 centimeters. Shape. In line with text. Final summary of key results. Enter table. 4/2. Column header. Row 1 of 4 column 1 of 2. Problem no. Column header. Row 1 of 4 column 2 of 2. Final answer. Row header. Row 2 of 4 column 1 of 2. 38. Row 2 of 4 column 2 of 2. Ratio of total surface areas is equal to 16. 36. 64. Row header. Row 3 of 4 column 1 of 2. 39. Row 3 of 4 column 2 of 2. rise in water level is equal to 0.52 centimeters. Row header, row 4 of 4 column 1 of 2, 40. Row 4 of 4 column 2 of 2. Water level rises in the cylindrical vessel by 37.4 centimeters. Exit table. Problem 41. A metallic solid is made up of two parts, a cylinder of height 10 centimeters and a hemisphere of radius 3.5 centimeters attached to the top of the cylinder. Find the total surface area of the solid. Insert exemplar. CBSE 2017. Concept and formula. Curved surface area of a cylinder. Cap S sub cylinder equals 2 pi RH. Curved surface area of a hemisphere. Cap S sub hemisphere equals 2 pi r squared. Total surface area. Cap S sub total equals cap S sub cylinder plus cap S sub hemisphere plus cap S sub base. Solution. Stepwise explanation. Given. Cylinder height equals 10 cm. Hemisphere and cylinder radius equals 3.5 cm. Curved surface area of cylinder. Cap S sub cylinder equals 2 pi open paren 3.5 close paren open paren 10 close paren. Equals 70 pi. Almost equal to 219.91 superscript base, cm, n base, squared. Curved surface area of hemisphere. Cap S sub hemisphere equals 2 pi open paren 3.5 close paren squared. Equals 24.5 pi. Almost equal to 76.96 superscript base, cm, n base, squared. Base area. Cap S sub bus equals P open paren 3.5 close paren squared equals 12.25 pi. Almost equal to 38.48 superscript base, cm, n base, squared. Total surface area. 219.91 plus 76.96 plus 38.48 equals 335.35 superscript base, cm, n base, squared. Final answer. Total surface area of the solid is equal to 335.35 square centimeters. Shape. In line with text. Problem 42. A bucket is in the shape of a frustum of a cone with a height of 30 centimeters. The diameters of its circular ends are 20 centimeters and 10 centimeters. Find the total surface area of the bucket. Concept and formula. Slant height of frustum, equal square root of, open paren r sub 1 minus r sub 2, close paren squared plus h squared, n square root. Curved surface area of frustum. Cap S sub frustum equals P open paren r sub 1 plus r sub 2 close parenal. Area of circular ends. Cap S sub bus equals per sub 1 squared plus per sub 2 squared. Total surface area. Cap S sub total equals cap S sub frustum plus cap S sub base. Solution. Stepwise explanation. Given. Frustum height equals 30 cm. Diameters. Larger base D sub 1 equals 20 cm. R sub 1 equals 10 cm. Smaller base D sub 2 equals 10 cm. R sub 2 equals 5 cm. Slant height of frustum. Equal square root of, open paren 10 minus 5 close paren squared plus open paren 30 close paren squared, n square root, equal square root of, 25 plus 900 n square root equal square root of 925 almost equal to 30.4 cm. Curved surface area of frustum. Cap S sub frustum equals P open paren 10 plus 5 close paren open paren 30.4 close paren. equals 15 pi open parent 30.4 close parent equals 456 pi, almost equal to 1432.39 superscript base, cm, end base, squared. Area of circular ends. Cap S sub bus equals P open parent 10 close parent squared plus P open parent 5 close parent squared equals 100 pi plus 25 pi equals 125 pi, almost equal to 392.7 superscript base, cm, end base, squared. Total surface area 1432.39 plus 392.7 equals 1825.09 superscript base, cm, end base, squared. Final answer, total surface area of the bucket is equal to 1825.09 square centimeters. Shape, in line with text. Problem 43. A cylindrical tank of height 50 cm and radius 14 cm is filled with water. A metal cuboid of dimensions 20 cm times 10 cm times 10 cm is fully submerged into the tank. Find the rise in the water level in the tank. Concept and formula. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a cuboid. Cap V sub cuboid equals to. Since the cuboid is submerged, the volume of water displaced equals the volume of the cuboid. Cap V sub cylinder equals cap V sub cuboid. Solution. Stepwise explanation. Given. Cylinder radius equals 14 cm. Cylinder height cap equals 50 cm. Cuboid dimensions. Length equals 20 cm. Breadth equals 10 cm. Height equals 10 cm. Rise in water level h sub r. To be determined. Volume of cuboid. Cap V sub cuboid equals 20 times 10 times 10. Equals 2000 superscript base, cm, end base, cubed. Rise in water level h sub r. Pi open parent 14 close parent squared sub r equals 2000. 196 pi h sub r equals 2000. H sub r equals 2000 over 196 pi. Almost equal to 3.25 cm. Final answer. Rise in water level is equal to 3.25 centimeters. Shape. In line with text. Final summary of key results. Enter table. 4 by 2. Column header. Row 1 of 4 column 1 of 2. Problem no. Column header. Row 1 of 4 column 2 of 2. Final answer. Row header. Row 2 of 4 column 1 of 2. 41. Row 2 of 4 column 2 of 2. Total surface area of the solid is equal to 335.35 centimeters. Superscript 2. Row header. Row 3 of 4 column 1 of 2. 42. Row 3 of 4 column 2 of 2. Total surface area of the bucket is equal to 1825.09 square centimeters. Row header. Row 4 of 4 column 1 of 2. 43. Row 4 of 4 column 2 of 2. Rise in water level is equal to 3.25 centimeters. Exit table. Shape. In line with text. Problem statement. A tent is in the form of a right circular cylinder surmounted by a cone. The diameter of the cylinder is 24 m. The height of the cylindrical portion is 11 m while the vertex of the cone is 16 m above the ground. Find the area of canvas required for the tent. Shape. In line with text. Concept and formulas used. Curved surface area. CSA. of a cylinder, subscript base, CSA, end base, subcylinder equals 2 pi RH. Curved surface area, CSA, of a cone, subscript base, CSA, end base, subcone equals PRL, where L is the slant height of the cone, given by L equals square root of R squared plus H squared, end square root. Total canvas area required, total surface area equals CSA of cylinder plus CSA of cone. Note, the base of the tent is not covered with canvas, so we only consider the curved surfaces. Shape, in line with text. Stepwise solution. Step 1. Extract given data. Diameter of cylinder is equal to 24 m. Radius equals 24 halves equals 12 m. Height of cylindrical portion is equal to 11 m. Total height of tent, cone plus cylinder, is equal to 16 m. Height of the cone is equal to total height. Cylinder height subcone equals 16 minus 11 equals 5 m. Shape, in line with text. Step 2. Find the curved surface area of the cylinder. Subscript base, CSA, end base, subcylinder equals 2 pi RH. Equals 2 times 3.1416 times 12 times 11. Equals 829.38 superscript base, m, end base, squared. Shape, in line with text. Step 3. Find the slant height of the cone. Using the formula, L equals square root of R squared plus H squared, end square root, equals square root of 12 squared plus 5 squared, end square root, equals square root of 144 plus 25 end square root equals square root of 169 equals 13 m. Shape, in line with text. Step 4. Find the curved surface area of the cone. Subscript base, CSA, end base, subcone equals PRL, equals 3.1416 times 12 times 13, equals 490.09 superscript base, m, end base, squared. Shape, in line with text. Step 5. Find the total canvas area required. Total surface area equals CSA of cylinder plus CSA of cone, equals 829.38 plus 490.09, equals 1319.47 superscript base, m, end base, squared. Shape, in line with text. Final answer. The area of the canvas required for the tent is 1319.47 square meters. Shape, in line with text. Problem statement. A rocket is in the form of a circular cylinder closed at the lower end with a cone of the same radius attached to the top. The cylinder is of radius 2.5 m and height 21 m. And the cone has a slant height of 8 m. Calculate the total surface area and the volume of the rocket. Shape, in line with text. Concepts and formulas used. Curved surface area, CSA, of a cylinder, subscript base, CSA, end base, subcylinder equals 2 pi RH. Curved surface area, CSA, of a cone, subscript base, CSA, end base, subcone equals PRL, where L is the slant height of the cone. Total surface area of the rocket. Since the cylinder is closed at the bottom, the total surface area is total surface area equals CSA of cylinder plus CSA of cone plus area of circular bus equals 2 pi RH plus PRL plus per squared. Volume of a cylinder, cap V sub cylinder equals per squared. Volume of a cone, cap V sub cone equals 1/3 per squared. Total volume of the rocket, cap V sub total equals cap V sub cylinder plus cap V sub cone. Shape, in line with text. Stepwise solution. Step 1. Extract given data. Radius of cylinder is equal to 2.5 m. Height of cylindrical portion is equal to 21 m. Slant height of cone is equal to 8 m. To find the volume of the cone, we need its vertical height h underscore cone using the Pythagorean theorem. H sub cone equals square root of L squared minus R squared, N square root, equals square root of h squared minus superscript base 2.5 n base squared, n square root equals square root of 64 minus 6.25 n square root equals square root of 57.75 almost equal to 7.6 m. Shape, in line with text. Step 2. Compute total surface area. Curved surface area of the cylinder. Subscript base, CSA, n base, subcylinder equals 2 pi rh, equals 2 times 3.1416 times 2.5 times 21, equals 330.06 superscript base, m, n base, squared. B. Curved surface area of the cone. Subscript base, CSA, n base, subcone equals PRL, equals 3.1416 times 2.5 times 8, equals 62.83 superscript base, m, n base, squared. C. Area of the circular base. Area of bus equals per squared, equals 3.1416 times open parent 2.5 close parent squared, equals 19.63 superscript base, m, n base, squared. D. Total surface area. Total surface area equals 330.06 plus 62.83 plus 19.63. Equals 412.52 superscript base, m, n base, squared. Shape, in line with text. Step 3. Compute total volume. Volume of the cylinder. Cap V sub cylinder equals per squared, equals 3.1416 times open parent 2.5 close parent square A times 21. Equals 412.29 superscript base, m, n base, cubed. B. Volume of the cone. Cap V sub cone equals 1/3 per squared, equals 1/3 times 3.1416 times open parent 2.5 close parent square A times 7.6. Equals 49.21 superscript base, m, n base, cubed. C. Total volume. Cap V sub total equals 412.29 plus 49.21, equals 461.5 superscript base, m, n base, cubed. Shape, in line with text. Final answers. Total surface area is equal to 412.52 square meters. Total volume is equal to 461.5 cubic meters. Problem statement. A tent of height 77 decimeters is in the form of a right circular cylinder of diameter 36 m and height 44 decimeters surmounted by a right circular cone. Find the cost of the canvas at 3 rupees and 50 paise per square meter. Use pi is equal to 22.7. Shape, in line with text. Concepts and formulas used. Curved surface area, CSA, of a cylinder, subscript base, CSA, end base, sub-cylinder equals 2 pi RH, curved surface area, CSA, of a cone, subscript base, CSA, end base, subcone equals PRL, where L is the slant height of the cone, given by L equals square root of R squared plus H squared, end square root, total canvas area required. Since the tent is open at the base, the total surface area to be covered with canvas is total surface area equals CSA of cylinder plus CSA of cone. Total cost of canvas, total cost equals total surface area times superscript base, rate, per, m, n base, squared, shape, in line with text. Stepwise solution. Step 1. Convert given data to consistent units. Height of tent is equal to 77 decimeters is equal to 7.7 m. Height of cylindrical portion is equal to 44 decimeters is equal to 4.4 m. Total height of tent, cylinder plus cone, is equal to 7.7 m. Height of cone is equal to h sub cone equals 7.7 minus 4.4 equals 3.3. M. Diameter of base is equal to 36 m. Radius equals 36 halves equals 18 m. Shape, in line with text. Step 2. Find the curved surface area of the cylinder. Subscript base, CSA, end base, sub-cylinder equals 2 pi RH, equals 2 times 22/7 times 18 times 4.4, equals numerator, 2 times 22 times 18 times 4.4 and numerator, over 7, equals 3499.2 over 7 equals 499.89 superscript base, m, n base, squared, shape, in line with text. Step 3. Find the slant height of the cone. Using the formula, L equals square root of R squared plus H squared, end square root, equals square root of 18 squared plus superscript base, 3.3, end base, squared, end square root, equals square root of 324 plus 10.89 and square root equals square root of 334.89 almost equal to 18.3 m. Shape, in line with text. Step 4. Find the curved surface area of the cone. Subscript base, CSA, end base, subcone equals PRL. Equals 22/7 times 18 times 18.3, equals numerator, 22 times 18 times 18.3 and numerator, over 7, equals 7237.2 over 7 equals 1033.89 superscript base, m, n base, squared, shape, in line with text. Step 5. Find the total canvas area required. Total surface area equals CSA of cylinder plus CSA of cone, equals 499.89 plus 1033.89, equals 1533.78 superscript base, m, n base, squared, shape, in line with text. Step 6. Compute the cost of canvas. Total cost equals total surface area times superscript base, rate, per, m, n base, squared, equals 1533.78 times 3.50, equals 5368.23 rupee. Shape, in line with text. Final answer. The cost of the canvas required for the tent is Rs 5,368.23. Problem statement. Q4 A toy is in the form of a cone surmounted on a hemisphere. The diameter of the base and the height of the cone are 6 cm and 4 cm, respectively. Determine the surface area of the toy. Use pi is equal to 3.14. Shape. In line with text. Concepts and formulas used. Curved surface area, CSA, of a hemisphere. Subscript base, CSA, end base, subhemisphere equals 2 pi r squared. Curved surface area, CSA, of a cone. Subscript base, CSA, end base, subcone equals PRL, where L is the slant height of the cone, given by L equals square root of r squared plus h squared, end square root. Total surface area of the toy. Total surface area equals CSA of hemisphere A plus CSA of cone. Shape. In line with text. Stepwise solution. Step 1. Extract given data. Diameter of base is equal to 6 cm. Radius equals 6 halves equals 3 cm. Height of cone is equal to 4 cm. Shape. In line with text. Step 2. Compute slant height of cone. Using the formula L equals square root of r squared plus h squared, end square root, equals square root of 3 squared plus 4 squared, end square root, equals square root of 9 plus 16, end square root equals square root of 25 equals 5 cm. Shape. In line with text. Step 3. Compute curved surface area of hemisphere. Subscript base, CSA, end base, subhemisphere equals 2 pi r squared, equals 2 times 3.14 times open parent 3 close parent squared, equals 2 times 3.14 times 9, equals 56.52 superscript base, cm, end base, squared. Shape. In line with text. Step 4. Compute curved surface area of cone. Subscript base, CSA, end base, subcone equals PRL, equals 3.14 times 3 times 5, equals 47.1 superscript base, cm, end base, squared. Shape. In line with text. Step 5. Compute total surface area. Total surface area equals 56.52 plus 47.1 equals 103.62 superscript base, cm, end base, squared. Shape. In line with text. Final answer. The surface area of the toy is 103.62 square centimeters. Shape. In line with text. Problem statement. Q5 A solid is in the form of a right circular cylinder, with a hemisphere at one end and a cone at the other end. The radius of the common base is 3.5 centimeters, and the heights of the cylindrical and conical portions are 10 centimeters and 6 centimeters, respectively. Find the total surface area of the solid. Use pi is equal to 22.7. Shape. In line with text. Concepts and formulas used. Curved surface area, CSA, of a cylinder. Subscript base, CSA, end base, subcylinder equals 2 pi rh. Curved surface area, CSA, of a hemisphere. Subscript base, CSA, end base, subhemisphere equals 2 pi r squared. Curved surface area, CSA, of a cone. Subscript base, CSA, end base, subcone equals PRL, where L is the slant height of the cone, given by L equals square root of R squared plus H squared, end square root, total surface area of the solid. Since the solid has no additional base at the hemisphere and cone ends, the total surface area is total surface area equals CSA of cylinder plus CSA of hemisphere plus CSA of cone. Shape, in line with text. Stepwise solution. Step 1. Extract given data. Radius of base is equal to equals 3.5 cm. Height of cylindrical portion is equal to H sub cylinder equals 10 cm. Height of conical portion is equal to H sub cone equals 6 cm. Shape, in line with text. Step 2. Compute the slant height of the cone. Using the formula, L equals square root of R squared plus H squared, end square root, equals square root of open parent 3.5 close parent squared plus open parent 6 close parent squared, end square root, equals square root of 12.25 plus 36 end square root, equals square root of 48.25, almost equal to 6.95 cm. Shape, in line with text. Step 3. Compute curved surface area of the cylinder. Subscript base, CSA, end base, subcylinder equals 2 pi RH, equals 2 times 22/7 times 3.5 times 10, equals numerator, 22 times 2 times 3.5 times 10 end numerator, over 7. Equals 1540 over 7 equals 220 superscript base, cm, end base, squared. Shape, in line with text. Step 4. Compute curved surface area of the hemisphere. Subscript base, CSA, end base, subhemisphere equals 2 pi R squared, equals 2 times 22/7 times open parent 3.5 close parent squared, equals 2 times 22/7 times 12.25, equals numerator, 22 times 2 times 12.25 end numerator, over 7, equals 537.5 over 7 equals 77 superscript base, cm, end base, squared. Shape, in line with text. Step 5. Compute curved surface area of the cone. Subscript base, CSA, end base, subcone equals PRL, equals 22/7 times 3.5 times 6.95, equals numerator, 22 times 3.5 times 6.95 end numerator, over 7, equals 533.5 over 7 equals 76.21 superscript base, cm, end base, squared. Shape, in line with text. Step 6. Compute total surface area. Total surface area equals 220 plus 77 plus 76.21, equals 373.21 superscript base, cm, end base, squared. Shape, in line with text. Final answer. The total surface area of the solid is 373.21 square centimeters. Problem statement. Q6. A toy is in the shape of a right circular cylinder with a hemisphere on one end and a cone on the other. The radius and height of the cylindrical part are 5 cm and 13 cm, respectively. The radii of the hemispherical and conical parts are the same as that of the cylindrical part. Find the surface area of the toy if the total height of the toy is 30 centimeters. CBSE 2002. Shape. In line with text. Concepts and formulas used. Curved surface area. CSA. Of a cylinder. Subscript base. CSA. End base. Subcylinder equals 2 pi RH. Curved surface area. CSA. Of a hemisphere. Subscript base. CSA. End base. Subhemisphere equals 2 pi r squared. Curved surface area. CSA. Of a cone. Subscript base. CSA. End base. Subcone equals PRL, where L is the slant height of the cone, given by L equals square root of r squared plus h squared, end square root. Total surface area of the toy. Since the toy does not have additional bases for the cylinder and cone, the total surface area is total surface area equals CSA of cylinder plus CSA of hemisphere plus CSA of cone. Shape. In line with text. Stepwise solution for Q6. Step 1. Extract given data. Radius of base is equal to or equals 5 cm. Height of cylindrical portion is equal to h sub-cylinder equals 13 cm. Total height of the toy is equal to 30 centimeters. Height of the conical portion is equal to h sub-cone equals 30 minus open paren h sub-cylinder plus a close paren equals 30 minus open paren 13 plus 5 close paren equals 12 cm. Shape. In line with text. Step 2. Compute the slant height of the cone. Using the formula L equals square root of r squared plus h squared, end square root, equals square root of 5 squared plus 12 squared, end square root, equals square root of 25 plus 144, end square root equals square root of 169 equals 13 cm. Shape. In line with text. Step 3. Compute curved surface area of the cylinder. Subscript base. CSA. End base. Subcylinder equals 2 pi RH. Equals 2 times 22/7 times 5 times 13. Equals numerator. 22 times 2 times 5 times 13 and numerator. Over 7. Equals 2860 over 7 equals 408.57 superscript base. cm. End base. Squared. Shape. In line with text. Step 4. Compute curved surface area of the hemisphere. Subscript base. CSA. End base. Subhemisphere equals 2 pi r squared. Equals 2 times 22/7 times open paren 5 close paren squared. Equals 2 times 22/7 times 25. Equals 1100 over 7 equals 157.14 superscript base. cm. End base. Squared. Shape. In line with text. Step 5. Compute curved surface area of the cone. Subscript base. CSA. End base. Subcone equals PRL. Equals 22/7 times 5 times 13. Equals 1430 over 7 equals 204.29 superscript base. cm. End base. Squared. Shape. In line with text. Step 6. Compute total surface area. Total surface area equals 408.57 plus 157.14 plus 204.29. Equals 770 superscript base. cm. End base. Squared. Shape. In line with text. Final answer for Q6. The total surface area of the toy is 770 square centimeters. Shape, in line with text. Shape, in line with text. Problem statement, Q7. A cylindrical tub of radius 5 cm and length 9.8 cm is full of water. A solid in the form of a right circular cone mounted on a hemisphere is immersed in the tub. If the radius of the hemisphere is 3.5 cm and height of the cone outside the hemisphere is 5 cm, find the volume of the water left in the tub. Take pi is equal to 22.7. CBSE 2000C. Shape, in line with text. Concepts and formulas used. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Volume of a cone. Cap V sub cone equals 1/3 per squared. Volume of water left in the tub. Cap V sub remaining equals cap V sub cylinder minus open paren cap V sub cone plus cap V sub hemisphere close paren. Shape, in line with text. Stepwise solution for Q7. Step 1. Extract given data. Radius of tub, cylinder, is equal to or equals 5 cm. Height of tub, cylinder length, is equal to equals 9.8 cm. Radius of hemisphere is equal to or equals 3.5 cm. Height of cone outside hemisphere is equal to equals 5 cm. Shape, in line with text. Step 2. Compute volume of the cylinder. Cap V sub cylinder equals per squared equals 22/7 times open paren 5 close paren square A times 9.8 equals 22/7 times 25 times 9.8 equals 5390/7 equals 770 superscript base cm n base cubed. Shape, in line with text. Step 3. Compute volume of the hemisphere. Cap V sub hemisphere equals 2/3 per cubed equals 2/3 times 22/7 times open paren 3.5 close paren cubed equals 2/3 times 22/7 times 42.875 equals 1886.5/21 equals 89.83 superscript base cm n base cubed. Shape, in line with text. Step 4. Compute volume of the cone. Cap V sub cone equals 1/3 per squared equals 1/3 times 22/7 times open paren 3.5 close paren square A times 5 equals 1/3 times 22/7 times 12.25 times 5 equals 1347.5/21 equals 64.17 superscript base cm n base cubed. Shape, in line with text. Step 5. Compute volume of water left. Cap V sub remaining equals cap V sub cylinder minus open paren cap V sub cone plus cap V sub hemisphere close paren equals 770 minus open paren 89.83 plus 64.17 close paren equals 770 minus 154 equals 616 superscript base cm n base cubed. Shape, in line with text. Final answer for Q7. The volume of the water left in the tub is 616 cubic centimeters. Here are the detailed solutions for the given problems. Shape, in line with text. Problem 8. A circus tent has a cylindrical shape surmounted by a conical roof. The radius of the cylindrical base is 20 m. The heights of the cylindrical and conical portions are 4.2 m and 2.1 m respectively. Find the volume of the tent. Concepts and formulas. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a cone. Cap V sub cone equals 1/3 per squared. Total volume of the tent. Cap V sub tent equals cap V sub cylinder plus cap V sub cone. Shape. In line with text. Solution. Stepwise explanation. Given data. Radius of the base equals 20 m. Height of the cylindrical portion H sub cylinder equals 4.2 m. Height of the conical portion H sub cone equals 2.1 m. Calculate the volume of the cylindrical portion. Cap V sub cylinder equals P open paren 20 close paren squared open paren 4.2 close paren equals P open paren 400 times 4.2 close paren equals 1680 pi. Almost equal to 5274.8 superscript base m n base cubed. Calculate the volume of the conical portion. Cap V sub cone equals 1/3 P open paren 20 close paren squared open paren 2.1 close paren equals 1/3 P open paren 400 times 2.1 close paren equals 840 over 3 P equals 280 pi. Almost equal to 879.65 superscript base m n base cubed. Total volume of the tent. Cap V sub tent equals 5274.8 plus 879.65 equals 6154.45 superscript base m n base cubed. Final answer. The volume of the tent is approximately 6154.45 cubic meters. Shape. In line with text. Problem 9. A petrol tank is a cylinder of base diameter 21 cm and length 18 cm fitted with conical ends each of axis length 9 cm. Determine the capacity of the tank. Concepts and formulas. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a cone. Cap V sub cone equals 1/3 per squared. Total volume of the tank. Cap V sub tank equals cap V sub cylinder plus 2 cap V sub cone. Shape. In line with text. Solution. Stepwise explanation. Given data. Diameter of the base is equal to 21 cm. Radius equals 21 halves equals 10.5 cm. Length of the cylindrical portion H sub cylinder equals 18 cm. Height of each conical end H sub cone equals 9 cm. Calculate the volume of the cylindrical portion. Cap V sub cylinder equals P open paren 10.5 close paren squared open paren 18 close paren equals P open paren 110.25 times 18 close paren equals 1984.5 pi. Almost equal to 6234.93 superscript base cm n base cubed. Calculate the volume of one conical end. Cap V sub cone equals 1/3 P open paren 10.5 close paren squared open paren 9 close paren equals 1/3 P open paren 110.25 times 9 close paren equals 331.5 pi. Almost equal to 1040.82 superscript base cm n base cubed. Calculate the total volume of the two conical ends. 2 cap V sub cone equals 2 times 1040.82 equals 2081.64 superscript base cm n base cubed. Total volume of the petrol tank. Cap V sub tank equals 6234.93 plus 2081.64 equals 8316.57 superscript base cm n base cubed. Final answer. The capacity of the petrol tank is approximately 8,316.57 cubic centimeters or 8.32 liters. Shape. In line with text. Final summary of key results. Enter table. 3 by 2. Column header. Row 1 of 3 column 1 of 2. Problem no. Column header. Row 1 of 3 column 2 of 2. Final answer. Row header. Row 2 of 3 column 1 of 2. 8. Row 2 of 3 column 2 of 2. Volume of the tent is equal to 6154.45 m. Superscript 3. Row header. Row 3 of 3 column 1 of 2. 9. Row 3 of 3 column 2 of 2. Capacity of the petrol tank is equal to 8,316.57 centimeters. Superscript 3. 8.32 liters. Exit table. Problem statement. Q10. A conical hole is drilled in a circular cylinder of height 12 centimeters and base radius 5 centimeters. The height and base radius of the cone are also the same. Find the whole surface area and volume of the remaining cylinder. Shape. In line with text. Concepts and formulas used. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a cone. Cap V sub cone equals 1/3 per squared. Volume of the remaining solid. Cap V sub remaining equals cap V sub cylinder minus cap V sub cone. Curved surface area. CSA. Of a cylinder. Subscript base. CSA. N base. Sub-cylinder equals 2 pi RH. Curved surface area. CSA. Of a cone. Subscript base. CSA. N base. Subcone equals PRL, where L is the slant height of the cone, given by L equals square root of R squared plus H squared, N square root. Total surface area, TSA, of the remaining cylinder, Z equals XA of cylinder plus CSA of cone plus base area. Since the base of the cone is not removed, it remains part of the cylinder. Shape. In line with text. Stepwise solution for Q10. Step 1. Extract given data. Radius of base is equal to equals 5 cm. Height of cylinder is equal to H sub cylinder equals 12 cm. Height of conical hole is equal to H sub cone equals 5 cm. Same as its base radius. Shape. In line with text. Step 2. Compute volume of the cylinder. Cap V sub cylinder equals per squared. Equals 22/7 times 5 square A times 12. Equals 22/7 times 25 times 12. Equals 6600 over 7 equals 942.86 superscript base. cm. N base. Cubed. Shape. In line with text. Step 3. Compute volume of the conical hole. Cap V sub cone equals 1/3 per squared. Equals 1/3 times 22/7 times 5 square A times 5. Equals 1/3 times 22/7 times 125. Equals 2750 over 21 equals 130.95 superscript base. cm. N base. Cubed. Shape. In line with text. Step 4. Compute volume of the remaining cylinder. Cap V sub remaining equals cap V sub cylinder minus cap V sub cone. equals 942.86 minus 130.95 equals 811.91 superscript base cm n base cubed shape in line with text. Step 5. Compute curved surface area of cylinder. Subscript base CSA n base subcylinder equals 2 pi rh equals 2 times 22/7 times 5 times 12 equals 2640 over 7 equals 377.14 superscript base cm n base squared shape in line with text. Step 6. Compute curved surface area of cone. First, find the slant height, L equals square root of r squared plus h squared, n square root equals square root of 5 squared plus 5 squared, n square root equals square root of 25 plus 25 and square root equals square root of 50 equals 7.07 cm. Now, compute the CSA of the cone. Subscript base CSA n base subcone equals PRL equals 22/7 times 5 times 7.07 equals 777.7 over 7 equals 111.1 superscript base cm n base squared shape in line with text. Step 7. Compute total surface area. TS equals subscript base CSA n base subcylinder plus subscript base CSA n base subcone plus base area. Base area of the cylinder. Base area equals per squared equals 22/7 times 5 squared equals 550 over 7 equals 78.57 superscript base cm n base squared. TS equals 377.14 plus 111.1 plus 78.57 equals 566.81 superscript base cm n base squared shape in line with text. Final answer for Q10. Volume of the remaining cylinder is equal to 811.91 centimeters. Superscript 3. Total surface area is equal to 566.81 square centimeters. Shape in line with text. Shape in line with text. Problem statement. Q11. A tent is in the form of a cylinder of diameter 20 m and height 2.5 m, surmounted by a cone of equal base and height 7.5 m. Find the capacity of the tent and the cost of the canvas at 100 rupees per square meter. Shape in line with text. Concepts and formulas used. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a cone. Cap V sub cone equals 1/3 per squared. Capacity of the tent. Cap V sub tent equals cap V sub cylinder plus cap V sub cone. Curved surface area. CSA of cylinder. Subscript base. CSA n base subcylinder equals 2 pi rh. Curved surface area CSA of cone. Subscript base CSA n base subcone equals PRL. Total canvas area. Canvas area equals subscript base CSA n base subcylinder plus subscript base CSA n base subcone. Cost of canvas. Total cost equals canvas area times rate per SQ meter. Shape in line with text. Stepwise solution for Q11. Step 1. Extract given data. Diameter of the tent is equal to 20 m. Radius is equal to equals 10 m. Height of the cylindrical part is equal to 2.5 m. Height of the conical part is equal to 7.5 m. Canvas cost is equal to rupee 100 m superscript 2. Shape in line with text. Step 2. Compute volume of cylinder. Cap V sub cylinder equals per squared equals 22/7 times 10 square A times 2.5 equals 22/7 times 100 times 2.5 equals 785.71 superscript base m n base cubed. Shape in line with text. Step 3. Compute volume of cone. Cap V sub cone equals 1/3 p squared equals 1/3 times 22/7 times 10 square A times 7.5 equals 5500 over 21 equals 261.9 superscript base m n base cubed. Shape in line with text. Step 4. Compute capacity of the tent. Cap V sub tent equals 785.71 plus 261.9 equals 1047.61 superscript base m n base cubed. Shape in line with text. Step 5. Compute total cost of canvas. Canvas area equals subscript base CSA n base sub-cylinder plus subscript base CSA n base sub-cone equals 157.14 plus 314.28 equals 471.42 superscript base m n base squared. Total cost equals 471.42 times 100 equals rupee 47142. Shape in line with text. Final answer for Q11. Capacity of the tent is equal to 1047.61 m. Superscript 3. Total cost of the canvas is equal to rupee 47142. Problem statement. Q12. A bola is in the form of a cylinder 2m long with hemispherical ends, each of 2m diameter. Find the volume of the bola. Concepts and formulas used. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Total volume of the bola. Cap V sub bola equals cap V sub cylinder plus 2 cap V sub hemisphere. Shape in line with text. Stepwise solution for Q12. Step 1. Extract given data. Diameter of hemisphere is equal to 2m. Radius is equal to equals 1m. Length of cylinder is equal to 2m. Shape in line with text. Step 2. Compute volume of the cylinder. Cap V sub cylinder equals per squared equals 22/7 times 1 square A times 2 equals 44/7 equals 6.29 superscript base m n base cubed. Shape in line with text. Step 3. Compute volume of one hemisphere. Cap V sub hemisphere equals 2/3 per cubed equals 2/3 times 22/7 times 1 cubed equals 44 over 21 equals 2.10 superscript base m n base cubed. Since there are two hemispherical ends, cap V sub total hemisphere s equals 2 times 2.10 equals 4.19 superscript base m n base cubed. Shape in line with text. Step 4. Compute total volume of the bola. Cap V sub bola equals cap V sub cylinder plus cap V sub total hemispheres equals 6.29 plus 4.19 equals 10.48 superscript base m n base cubed shape in line with text. Final answer for Q12. Total volume of the bowler is equal to 10.48 m. Superscript 3. Shape in line with text. Shape in line with text. Problem statement. Q13. A vessel is a hollow cylinder fitted with a hemispherical bottom of the same base. The depth of the cylinder is 14/3 m, and the diameter of the hemisphere is 3.5 m. Calculate the volume and the internal surface area of the solid. Shape in line with text. Concepts and formulas used. Volume of a cylinder. Cap V sub cylinder equals per squared. Volume of a hemisphere. Cap V sub hemisphere equals 2/3 per cubed. Total volume of the vessel. Cap V sub vessel equals cap V sub cylinder plus cap V sub hemisphere. Curved surface area. CSA. Of cylinder. Subscript base. CSA. End base. Sub-cylinder equals 2 pi RH. Curved surface area of a hemisphere. Subscript base. CSA. End base. Sub-hemisphere equals 2 pi r squared. Total internal surface area. Internal surface area equals CSA of cylinder plus CSA of hemisphere. Shape in line with text. Stepwise solution for Q13. Step 1. Extract given data. Diameter of hemisphere is equal to 3.5 m. Radius is equal to equals 3.5 over 2 equals 1.75 m. Height of cylinder is equal to equals 14/3 m. Shape in line with text. Step 2. Compute volume of the cylinder. Cap V sub cylinder equals per squared equals 22/7 times open parent 1.75 close parent square a times 14/3 equals 22/7 times 3.06 times 14/3 equals numerator 22 times 3.06 times 14 and numerator over 21 equals 14.19 superscript base m n base cubed. Step 3. Compute volume of the hemisphere. Cap V sub hemisphere equals 2/3 per cubed equals 2/3 times 22/7 times open parent 1.75 close parent cubed equals 2/3 times 22/7 times 5.36 equals numerator 2 times 22 times 5.36 and numerator over 21 equals 7.51 superscript base m n base cubed. Shape in line with text. Step 4. Compute total volume of the vessel. Cap V sub vessel equals cap V sub cylinder plus cap V sub hemisphere equals 14.19 plus 7.51 equals 21.70 superscript base m n base cubed. Shape in line with text. Step 5. Compute internal surface area. Subscript base CSA n base sub-cylinder equals 2 pi RH equals 2 times 22/7 times 1.75 times 14/3 equals numerator 44 times 1.75 times 14 and numerator over 21 equals 18.28 superscript base m n base squared. Subscript base CSA n base sub-hemisphere equals 2 pi r squared equals 2 times 22/7 times open parent 1.75 close parent squared equals 2 times 22 sevenths times 3.06 equals numerator 44 times 3.06 and numerator over 7 equals 19.22 superscript base m n base squared. Internal surface area equals subscript base CSA n base subcylinder plus subscript base CSA n base subhemisphere equals 18.28 plus 19.22 equals 37.50 superscript base m n base squared. Final answer for Q13. Total volume of the vessel is equal to 21.70 m. Superscript 3. Internal surface area is equal to 37.50 square meters. Problem 14. Surface area of a solid with hemispherical ends. Question. A solid is composed of a cylinder with hemispherical ends. If the total length of the solid is 104 centimeters and the radius of each hemispherical end is 7 centimeters. Find the cost of polishing its surface at the rate of 10 rupees per dm. Superscript 2. Concepts and formulas used. Curved surface area CSA of a cylinder. Subscript base CSA n base subcylinder equals 2 pi rh. Curved surface area of a hemisphere. Subscript base CSA n base subhemisphere equals 2 pi r squared. Total surface area TSA of the solid is equals XA of cylinder plus 2 times CSA of hemisphere. Cost of polishing cost equals superscript base area in dm n base square atm superscript base rate per dm n base squared. Shape in line with text. Stepwise solution for Q14. Step 1. Extract given data. Radius of hemisphere is equal to 7 centimeters. Equals 7 cm. Total length of solid is equal to 104 centimeters. Height of the cylindrical path equals 104 minus open paren 2 times 7 close paren equals 90 cm. Rate of polishing is equal to rupee 10 per dm. Superscript 2. Shape in line with text. Step 2. Compute CSA of the cylinder. Subscript base CSA n base subcylinder equals 2 pi rh equals 2 times 22 sevenths times 7 times 90 equals 3960 superscript base cm n base squared. Shape in line with text. Step 3. Compute CSA of one hemisphere. Subscript base CSA n base subhemisphere equals 2 pi r squared equals 2 times 22 sevenths times 7 squared equals 308 superscript base cm n base squared. Since there are two hemispheres, total CSA of hemisphere S equals 2 times 308 equals 616 superscript base cm n base squared. Shape in line with text. Step 4. Compute total surface area. Z equals XA of cylinder plus CSA of hemispheres equals 3960 plus 616 equals 4576 superscript base cm n base squared. Convert square centimeter to dm. Superscript 2. Superscript base area in dm n base squared equals 4576 over 100 equals 45.76 superscript base dm n base squared. Shape in line with text. Step 5. Compute cost of polishing. Cost equals 45.76 times 10 equals 457 rupees and 60 paise. Shape, in line with text. Final answer for Q14. Total surface area is equal to 4576 centimeters. Superscript 2. Cost of polishing is equal to 457 rupees and 60 paise. Shape, in line with